is 5:38. Let's go ahead. Everybody, as was already mentioned, and as you guys should see in the chats, should hopefully be able to go ahead and start up your vulnerable lab, right? So we're going to want to make sure you guys are working within the VMs that we have available there for you guys inside of the vulnerability labs. Now, as we kind of pointed out, the first few ones, we're going to be using our Kali machine. And then as Justin was saying, we are also going to be using that Ubuntu machine later on, right? So let's go ahead and get started. If you haven't done so already, please turn on your cameras if it's safe to do so. If you're driving, you can go ahead and keep them off. And then once you get to a safe location, then you can go ahead and turn them on, right? And then, of course, if you haven't done so already, turn on your virtual machines so that way they can be ready to be able to follow along or for when we go into the breakout rooms. And of course, double checking once again, the vulnerability lab VMs are the ones you want to be able to start up, right? So let me go ahead. Let me share my screen. So here we are in the LMS. We left off last time with discussing our burp suite, right? Justin was able to go ahead and kind of show us a little bit about burp suite, how we can be able to use it to be able to go ahead and intercept communications. It can kind of be that middleman, right? And then we can be able to look at to see how not only is the messages or the stuff that we are sending over to a website, how it's looking, but we can be able to also be able to go ahead and kind of modify it as well if we wanted to, right? So that's kind of what we were looking at. We do point out that there was 3 tools we want to be aware of, right? Our burp proxy, the burp intruder, and the burp repeater, right? And so we were using these 3 tools to be able to go ahead and try and be able to help us out with what we were doing. And so we said that the burp proxy this is what allows us to be able to intercept those requests, right? So we're intercepting our HTTP requests and the responses that are being sent between the burp's browser and the target server. And of course, this allows us to be able to see what is actually being exchanged between our computer and something else to see what's happening and possibly how we can take advantage of it, right? We said the burp intruder. Well, this is going to automate customized attacks against web applications, right? We do point out it's an extremely powerful configurable tool that can help us do a whole range of tasks. And then the repeater, right? We went ahead and I believe Justin was the one that kind of told us that this is allowing us to be able to resend a message over and over again, right? So if we can be able to go ahead and find an interesting request, we can reissue it, right? And so we can modify the information that's there. We can change the packets and we can send it over and over again. So we can be able to go ahead and see what's the website's response to different input without having to intercept the request every time. We just send out the new one, right? And so part of what we wanted to do for this exercise was the following, right? We see right here a few steps that they want us to do. We wanted to be able to go ahead and open up our burp suite, right? And then we wanted to navigate over to DVWA. And then we wanted to do this within our burp suite browser, right? So let me go ahead. Let me see if my lab is ready. I did go ahead and start it up. And let me stop sharing here. And I'll share my lab. All right. Hopefully you guys are able to go ahead and see my lab. So we said that what we wanted to do here, if you hadn't done so already, right? We wanted to be able to go ahead and download and install DVWA. So if you're having difficulties with this, right, we wanted to be able to go ahead and make sure that what we did was to be able to go ahead and we could switch into sudo s, right? This way, we're able to go ahead and do things with permissions of our root account. So we said sudo -s, that allows us to switch into root. And then after we did that, if we didn't have it installed, we could go apt install DVWA, right? And then once we did that, we'll go ahead and try and be able to retrieve the packages. Notice right here, it didn't do anything because we already installed it, right? But we said that it would go ahead and retrieve the packages. If we're using the vulnerability lab, it shouldn't give any errors. It should go ahead and then ask us, I want to install it? It'll tell us how big the package is. And we'd say yes. It would go ahead and complete installing it, right? Then after that, we said we go DVWA-start, that should go ahead and start up our web interface. And we said after a little bit, it should open it up for us. And so here it is. Here's our web interface. And we said that it should open it up to our self-referential IP, right? So 127.0.0.1:42001. So 42,001. And so if we go ahead and copy this, we can be able to go ahead and open up our Burp Suite. And so there we go. Starting up Burp Suite. And then Justin went ahead and pointed out that we could be able to go ahead and if we wanted to be able to actually save the information we're going to be working on or whatever, we could be able to go ahead and choose one of these other things. But we are keeping it as a temporary project and hitting next. And then we're going to keep it with the defaults and we'll start up Burp. And then once it's done starting up, we're able to go ahead and we can go here to our proxy tab. So if we're able to go ahead and see near the top, not all the way at the top, right? We have our proxy tab. And so we're able to go ahead and click there to be able to go ahead and set up the stuff that we want to intercept. Now we can click open browser right here. And this is going to be a browser designed by those that create Burp Suite to be able to interact with Burp Suite directly, right? And so we can go ahead and paste our address into there and it'll take us over to DVWA. So now we have this opened up inside of our browser for Burp Suite, right? And so if we go back to our LMS, it tells us, let's go ahead and navigate inside of our Burp Suite browser over to DVWA. And it tells us that we can then be able to go ahead and change the security to low, right? So if we go ahead and scroll down, we said the way to do that to make sure that it was in low was to click here in DVWA security. It's typically going to start off at impossible, so it has the highest level of security, right? And we can go ahead and change that down here to low, submit. And then once we see that it tells us that the current security is low, that's when we know that we're at the right level of security to be able to go ahead and do what we need, right? So it tells us then navigate over to the brute force section of this application. So that's right here. We said it was on the left-hand side, the different categories. We're going to be going to brute force. And so now we're here and we're looking at being able to try and get into a login screen, right? So we have a username and a password, and then we have this login button. And so then it tells us that we're going to want to configure our Burp Suite to intercept this request once we try to be able to send it in, right? So how can we do that? Well, if we go and let's get our browser, let's go ahead and make it a little bit smaller for right now and go back over to our Burp Suite. This is where Justin was talking to us, right? That right now it says intercept is off. So it's not capturing anything. But we can toggle it on. And then once it says intercept is on, now anything that we do in that browser, right, it's going to go ahead and kind of capture it for us. And it's going to go ahead and work with it. So let's see. Here's our browser that's working inside of our Burp Suite. And if I go ahead and I put in any name, so let's say I just go name, let's say for password, I just go password, and I click login, we see that it takes us over here to our interceptor, and it shows us what is being sent, right? So we can be able to break this down as part of what's happening when we are looking at our HTTP protocol, right? So we see that we're doing a GET request, and we're seeing that it's sending over this as part of that website, right? So it's saying, hey, go to DVWA, go to the vulnerabilities directory, go to brute, since we're in the brute force category, right? And then it's showing us the username and password that we're sending over, right? It says username is equal to name, password is equal to password. And then it tells us what action we are trying to do. Our action is that we're trying to log in, right? And so if we have the correct username, if we have the correct password, and it sends it over for this action of logging in, then it should be able to go ahead and get us into the account, right? It should be able to log us in. It tells us where are we sending this, right? So where's the host? And it gives us a lot more information, such as our user agents, so what browser are we using to be able to go ahead and connect to this. We see right here, what type of formatting in the data that it's sending over does it accept, and so on, right? And so we are going to go ahead. Let's go back to over here. We configured our burp to intercept this request, right? And then it says send the request to the repeater, right? And then it says note where our username and password is being sent. And then we're going to see that we're going to want to go through a get request instead of a post request. So let's go ahead and see if we can piece that together. So right here, I have it that I can forward the message. So right now it's kind of paused this message before it actually gets to its destination, right? We're sending out this request with this information from the web browser. And before it gets to that server that's running our DVWA, it's paused it here. So what can we do? We can forward it, right? Send it along its way. We can drop it. It never gets sent anywhere else. I could turn off my intercept, right? Which typically, unless we want to be able to go ahead and get more information, that he says that we can be able to turn that off and then just only turn it on when we need to, right? Which is pretty smart. That's what we kind of were doing earlier, right? Everything for DVWA up until the part where we got to the login page, we had our interceptor off. We only turn it on when we want to actually gather the data, because otherwise everything's going to be blocked. It's going to be doing this man in the middle thing until we either forward, drop, or turn the interceptor back off, right? And we've already opened up a browser. So what's happening is we want to click on this action button, right? This is how we're going to go ahead and send it to the other areas of Burp Suite. So if I click on that action, it's asking us to send it over to the repeater, right? So I can click on that and notice that up here at the top where we first clicked proxy, that now my repeater turned orange, right? When we sent it over there. So if I click on repeater, we're going to see that now it has this exact request, right? And then we can be able to go ahead and change things about this request and click send, and then be able to go ahead and see what is the response, right? So we have it right now that it's showing this in raw. We could see it, what it looks like in hex, and we can click pretty, right? If that was available, to see the different forms, to be able to see how is it presenting this to us, right? We can also right here on the right-hand side, we can drop down the request attributes, and we can kind of see what's being sent over, right? So you see right here, the method, this is a get request. The path, what is the path that it's requesting, right? The parameters, we see that happening right here. Here's our username, and then the value we provided. Here's our password and the value we provided, right? And then our action that we're trying to do a log in, right? And so that's kind of what they were hinting at over here, right? They said, note where our username and password is being sent, right? And we want to make sure that we are sending it as a get request instead of a post request, right? And then what they're having us do is essentially guess the credentials to the form, right? So since we have it as a low security, this username and password, right? We can be able to go ahead and double click here and be able to change this. We can try and be able to go ahead and guess at what this likely is. And we can change what the username is, right? So I can change that from name to something like admin, right? I can change this from something like password, maybe password 123 or something like that, right? The moment I go ahead and hit enter or click out of it, we see that it's changed that information here. If we look on the left-hand side, it's changed that there in the request, and I can hit send to see if it comes up with a good response, right? So here it's telling us, hey, it's getting an internal server error, right? So it's not getting a response back. So this is likely a valid username and password combination, right? Antonino, I see your hand is raised. Go ahead.
Yes, could you elaborate more on requesting query parameters? What does that actually mean? Is it from like number to number, word to word, or I don't really understand this part.
So right there, the query parameters is pretty much what is it sending over? What type of things is it trying to be able to deal with, right? And so we can kind of see that right here. After this sort of question mark, we see in the request, right? This doing what type of get request is this, right? What type of HTTP request style? We've seen a few different ones, right? We've seen get, we've seen post. I believe there's also stuff like update, right? So we're seeing the different ones. Get and post are going to be your most common ones. And then after that, we see right here, this is where is it sending this request to? So it's sending it to the DVWA website, but then specifically to this directory that is on that server, right? So once it goes to that website, wherever it's being hosted, it's then sending it to vulnerabilities/brute. And then we see we have this question mark. So this is the beginning of our query, right? So this is sort of what type of thing, what type of information are we sending over in this request for it to be able to process, right? And so anything that comes after this, these are our query stuff. This is our query information, right? Our query attributes. And so the first thing is going to be, in this case, they specify it as our username, and then they set it equal to, and then it's pulling this information. Typically, it's going to be from our form that we filled out, right? So if we go back over here, this is what we typed into our username area right here, right? So that's normally what it's going to be filled with. Then we have password, and then whatever we filled into right here, right? So we see that's typically what it's setting up right here. Username is equal to this, and password is equal to this. And then this last part right here, for our purposes, this is the action that we are having the form take, right? When we're hitting that submit button on the form, what is it that we're trying to do? We're trying to take this login action, right? So what we're seeing over here, when we go ahead and talk about those query parameters, so you see right here, request query parameters, it's those things that are coming after that question mark, right? And it's essentially what additional information are we sending over when we're posting our request, right?
Okay, yeah, so we're conducting a brute force, right?
Mhm.
And we're setting a parameter. Where
The
does it stop
parameter is
and end?
defined by the form is what it is, right? So we can kind of picture it almost like when it comes to Python. If you remember with our Python programming, when we defined a function, something we wanted Python to be able to do, we said when we define it, if it is expecting extra information and we put that into the definition header, we call that a parameter, right? And then we said once we actually then use that function and we send the information over, that's an argument. So right here, when we're talking about this request query parameters, this is saying, hey, if you
Oh,
want to do this action, if you're submitting this form, what information is it expecting? Well, it's expecting a username, a password, and some action that we're titling login, right?
okay, the definition of parameter is different. I got you.
Mm-hmm.
Okay, thank you.
Yep. Any other excellent questions like that so far? Let's see. Min says, can we script this with a bunch of different username and passwords? In the repeater, not really, right? The repeater is just we're manually kind of doing it ourselves. And so they're having you kind of learn how to be able to go ahead and do that right here, right? We can be able to go ahead and try different things. We can be able to go ahead and try, for example, a very common default username and password might be something like admin, right? So we can be able to go ahead and send that over, see if it gets a different response. And that's doing it manually. So Min is asking, can we be able to go ahead and do this more like where it's scripted, do it more automated? And so if we come back here to our proxy, this is more what the intruder is for. So if we send this to the intruder, notice the intruder went ahead and turned orange once we sent it over. So now it has this information. So if I go right here, we're going to see again, down right here in this area that I'm now highlighting, this is our requests, right? This is what we're trying to send over. This is what we captured. And I can be able to go over here to payloads, and I can be able to go ahead and change this up to what we're going to do. So for example, here we have different attacks that this one can do, right? So Sniper says this attack uses a single set of payloads and one or more payload positions. We see a battering ram uses a single set of payloads and it iterates through them. Pitchfork, this attack uses multiple payload sets, different payload sets being defined for different ones. And then there's the cluster bomb, right? We could be able to use multiple payload sets with a different payload for each one. So that's more or less what we're kind of picturing here, right? Cluster bomb. Why? Because when we go to payloads, we're going to see if we click here on payload sets, typically if we do this right, let's see, do I got this one with the right thing? So if we do this right, let me go ahead and hit refresh right here. Let's go back here. It should come up with how many entries we have to put into our forms. Right now, it seems like that's doing 5. Let me go ahead and close this and let's try this again. So let me go right here. Let's go ahead and try to move this on over to our intruder. And let's see. We change this to a cluster bomb and let's go to payloads. So what should be happening when we do this correctly is if we go back over to here, we see that there is just one thing to enter for username, one thing to enter for password. And so it should be able to go ahead and find that there's just two. When we go to our intruder, for example, for our payloads, there should be just two payload sets really. And so what we can then do is we can change what is it that we are going to be trying to fill in into each of those areas, right? So for example, if we go a simple list, I can be able to go ahead and give it a list of different usernames, right? I could type this in, right? I could be able to say something like, let's try admin, let's try root, let's try user, let's try MSF admin, which if you've used the Metasploitable, that's the username that they use for that, right? And any other amounts of usernames I might want to use, right? I could be able to load up from a file. So I could click load and then go look for a file with a list of usernames, right? So if I already have a list that's available, I don't have to type them in here one by one. I can just load it up, right? Or I could copy and paste, right? Then I could be able to go here to our second one. And so how do we know what's what? Well, again, coming over here, the first field that we're filling in would be that first set, right? The second field that we're filling in would be that second set. So I can be able to go ahead and say, okay, the first one was usernames. The second one is passwords. So maybe I'm going to have something like password. Maybe I'm going to have admin again. Maybe I'm going to have something like Tor, which if you know the default username and password that Callie used to have for the longest time was root backwards Tor, right? And so on and so forth, right? So I can be able to go ahead and put in all this stuff. And then we can be able to go ahead and once we have all the stuff ready, right? We have it right here in positions. What is the packet we're going to be trying to be able to send over with the payloads, right? We set up our payload sets 1 and 2. So we kind of have what is it that we're going to be filling in for that first part of the file? What is it we're going to be filling in for the second part? And then we can try to click start attack here because it's still expecting 3, 4, and 5. It gives us that error. But if we had it with just those two, right? It should be able to go ahead and then fill this in correctly and be able to go and try all those combinations and kind of give us what's going to be happening, right? Let's see.
Hey, Tony.
Yes.
I think under positions for the if you send that back to the intruder again, because now you've got the post method.
Right. All right.
Yeah, and then under positions, click clear on the right. Yeah, and then highlight first name, which is like your first position, the orange variable. Yeah, not the ampersand though. I made that mistake. Yeah, and then click add. And the same thing with password. And then click add, and that defines those two positions, and then you can execute your cluster bomb.
Excellent. All right, so that's a way of more manually doing it rather than relying on it to try to auto detect it, right? So excellent. Thank you for sharing that, John. And we can click on cluster bomb. And then if we go here to payloads, so there we go. Those are the two. So we can kind of do like what we were doing before, right? Maybe we'll keep it at that simple list. We'll go with the different stuff. And then we can be able to go ahead and change it to the second one and then give it some passwords. And then we can go ahead and click start attack. And so right here, it tells us that because right now for our version, we are using a free version, right? The demo version, it's not going to be as efficient. So it could take some time. And it's also going to be that some stuff, some key aspects of the more advanced features are not going to be available. So we'll just hit OK. And we see right here, it's going to go ahead and kind of run through this and see what comes back, right? So we'll notice that it did go ahead and automate this. So this is kind of what Min was talking about when he asked, right? And it shows us what's the result, right? So it says, hey, we tried admin with password. We got a 500 status, right? We tried root with password, 500 status, username with password, right? 500 status, and so on and so forth. So all of these combinations came back with a 500. So none of these combinations of passwords and usernames worked, right? If we had gotten something like maybe a 200 status, if you recall, when it comes to HTTP, a 200 status is saying that everything's okay. That means it was able to submit that information and it came back with a valid website, right? It came back with something that was good versus these are coming back with errors, right? So that's what we're going to be looking for. We can be able to go ahead and if you wanted to, you can look online for a list of passwords, or you can be able to go ahead and look for a list of usernames, right? And be able to supply it. If you recall, which I'm not sure if we went over this, but if we actually go ahead, let me go ahead and open up a folder to explore. Our Kali Linux actually comes with a list of passwords for us. Although we may not want to use such a big list for this one because it's just a simple exploration, right? So it's going to be a basic thing. But let's say that I want to go ahead. Let's see. Let's go. Here is our root directory, right? If you recall this when we're looking in our terminal, you'll recognize we see our bin, boot, dev, etc, right? Home, and so on and so forth. A lot of these. So I believe it's here in user. Then I think it's share. And then if we scroll down, so right here in user, share, word lists, and we see right here, this is a very useful directory because we're going to see then we have a lot of different folders here and a lot of different files that have a lot of text stuff that we're going to want to be using. For example, right here, we'll see that we have this rocku.txt, and you'll notice it ends in .gz. So this is gunzipped, right? But if we go ahead and take a look at this visually, so we're doing this through our GUI, right? And we open up this rocku.txt file that it has inside, we see we get this file right here. And we'll go a little bit more in depth about this as we get more into Red Team, but suffice it to say that this is a built-in list of passwords that Kali Linux already has, right? So we could, in fact, even go ahead and get this list, right? If we really wanted to, if we wanted to be able to be a little bit more thorough. And again, we could click load, we could go to that area and load up that text file to load it up with those passwords, right? And then we could do something similar to be able to go ahead and go back to our first section and change the passwords, load it up with a lot of different passwords, and then click start attack to be able to go ahead and find it, right? And it would go through that automated process. But we want to be able to try and see if we can do it ourselves. So we have our repeater here, right? We've already tried some of these, right? So we've already tried something like admin, right? We've already tried something like user and password, right? And exactly what we see here on the right-hand side is what that intruder was going through, right? So it sent this request, and we see that it came back with this 500, right? Which is exactly what would have happened over here if we were to go ahead and type this in, right? If I were to go to something like user and then password, and I hit login, well, right now, Burp Suite is still going to capture it, right? We still have our proxy on. So if I were to turn this off, right? And then if I were to go ahead and submit it, you'll notice that it submitted it, it went through. It's no longer being caught by that man in the middle from our burp, right? It's no longer intercepting it, but it's doing exactly what we're seeing that was the result when we're using our repeater, right? Saying, hey, we have this error, 500, right? It's not handling this. And we see up here exactly what we were seeing there with our request, right? It sent over this information saying, hey, try to log in with this username and password, username and name, password, and what action were we doing? We were trying to log in, and it comes back with this error report, right? That, hey, using that information, we're not going anywhere. Instead, we're getting this 500 error, right? So if we were to get the right username and password combination and click login, it should be able to go ahead and take us to a login page, right? It should be able to go ahead and take us to something that's actually legitimate. And so we should then see if we were to do that, this request right here should no longer be 500, right? So that's kind of the exercise that we wanted to do. And then it says, once you find out what the correct credentials are, it says research the following with your group. And it asks us this question: how can websites be more secure from brute force attempts? So if we think about this, right, what is something that we can do, or what's something that we could be able to implement to prevent somebody from just doing what we're doing right here, right? Going back over here, changing that information, submitting it again, didn't work, change it, submit it again until they finally get in, right? What's something that we could do differently to be able to block that from happening? All right, Alex says we could issue single-use keys. That's one thing we can do, right? but that could be a little bit intensive, because when we think about that, how many people want to be able to log into their accounts, and every time they log in, they have to, let's say that we didn't change the username, that we were changing the password every time. How many people would want to use a different password every time and have to know what that password is, right? That's going to be very inconvenient for our users. And that's one thing that we're going to see is going to be a lot of a give and take type of thing when it comes to cybersecurity, right? That the more secure we try to make things, the more it's going to be a little bit inconvenient for our users. And so they push back on that, right? So we have to find the right balance of how can we make this secure while our users are still feeling that it's not going too inconvenient for them, right? Because a lot of the times they're just going to flat out refuse to be able to do something, or they're going to complain until like that security measure is removed because of the inconvenience, right? Let's see, in the chat, another answer was by Antonino. How about multi-form authentication? So MFA. Yes, that's one definite way we could do this, right? That in addition to just using a username and password, then they also have to do some form of multi-factor authentication so that way they can verify who they are, right? And so therefore, every attempt that they're trying to submit can't go too far, because then they also have to have this additional thing, right? Let's see, John says throttle or restrict speed or the number of login attempts on the server side. Or Cam, to kind of tie into that, right, says limit the amount of times that one can do that. Yes, excellent. That's the other idea, right? That we can limit how many attempts for an account that somebody can be able to submit, right? So if somebody's saying, oh, I know the username is such and such because that's their email or something like that, right? And then they try to be able to go ahead and guess what the password is. Right now, with the security being the way it is on DVWA, I can go ahead and submit a new password as many times as I want, no consequences, right? But in order to prevent that from happening, in order to prevent that type of brute forcing, we would want to limit it, right? Hey, maybe within a 10-minute period, I only want there to be 3 invalid logins. After that, we're going to lock the account, and then we're going to have them be able to have to change their password or reset it or something, right? That right there alone would be able to shut down brute forcing it, because the moment they get just a few incorrect, now the account is kind of shut down or locked out, right? So that's another way to be able to go ahead and do that. Let's see, Edwin says, what about something like biometrics? Excellent, right? That comes into almost like the multi-factor authentication, right? That we're using some other way of being able to go ahead and verify that they are indeed who they say they are, either biometrics or the way that we kind of picture authentication, right? There's really 3 ways we can do authentication, right? It's something you have, something you know, or something you are, right? So those are kind of the ways we go, right? So biometrics is something you are, right? Nobody else has like the same voice as you, or the same eyes, or the same fingerprint, or something like that, right? So something you are. Passwords, that's something you know, right? And then there's something you have. So if you have like a cell phone or something like that, that's how we're able to sort of verify that you are as well, by sending like a text message to your phone, or through an app that you have to open up and put in some information, right? Or something similar. And so multi-factor authentication is a way of having it that we're doing more than just one of those categories. That's what I mean by multi-factor, right? We're doing 2 or more of these different authentication styles to be able to verify that the person is who they say they are. So excellent. Let's see. Antonino also said maybe using a scheduled security pen testing for vulnerabilities. We could definitely be able to do that, right? Be able to do something like what we were doing with Nessus, or to do a red team exercise, or to do some penetration testing to see if there's any place where we have it that brute force is still available. But then the way to stop that brute force is kind of with what we've been discussing, right? We can be able to limit how many failed login attempts or something like that, or how many times we can be able to send in a request for a login, so that way it sort of locks it out, or temporarily suspends that account, or blocks it, or something similar, right? Until they reset it. Or we're going to have multi-factor authentication to where they can't really complete their request until they verify themselves in more than one way, right? Let's see, Cam says, tell the complainers that security supersedes convenience. Yes, that's exactly what we would love to do, right? That we can be able to go ahead and be able to say, hey, we're even this is inconvenient. We're doing this because we need that level of security, right? But you're going to see that a lot of the times businesses don't really care that much when it comes to that, right? That's one of the reasons why we're seeing the sudden shift in this decade to a much more focus on being able to implement stuff like cybersecurity, right? Because when the internet first started out, the main thing was can we get this to work, right? Can we have a website that can be able to do e-commerce on? It wasn't so much on, can we be able to have this website that can do this and be secure for everybody, right? Then after that, it was a little bit more about also then convenience. Now that we got this up and running, how can we make it convenient for the users to be able to use our products so they'll do the shopping, right? It's only now with the big sort of hacks that we've seen within the past few years that people are starting to say, okay, we need to go ahead and secure this. We need to be able to go ahead and lock this stuff down so that that way we can't keep having these hacks happen, right? But you're still going to see that there's going to be a lot of pushback by users. It's going to be a lot of pushback by businesses that until they see a need, right, which unfortunately usually means that some type of security hack happened, they're going to push back against it, right? Where they're going to say, I'd rather it be convenient for me than to have to worry about all this additional stuff to make it secure, right? And that's just the sad way that a lot of businesses, a lot of people in general are, right? Convenience over most other things. They'll give up security for convenience. Any other questions so far with what we have with this first part for Burp Suite? All right, was there anybody that was able to figure out what username and password combo could be able to work here?
Hey, Tony, yeah, on mine, it was just admin and password with the
All
low
right.
security.
Let me see if there's something right here that we can be able to go ahead and try. I don't think I turned back on. Let's see. Let me go back to the proxy. Yeah, so that's still off. Let's see if right here if this is working properly. And let's try that. I'm gonna go admin, password. And so maybe it's just that this isn't working correctly right here. So that's why that's not happening. Let me see over here. Let's try it in right here in Firefox. So here we're gonna go ahead and in Firefox, let's bring this down to low. Let's go ahead and submit. So we keep that here. Let's try this in Firefox with admin. Let's try password. I hit don't save. And so right here, it does seem like we were able to go ahead and get this. So maybe it's with the what's happening inside of the Burp Suite browser, that's why it's happening. So I'll show you this. Here we're using Burp Suite's browser, but we could actually be able to go ahead and there's a way to interact with other browsers, right? So I can go here in Burp Suite, and if I click on proxy, I can go here to, I believe, options, and it tells us that this is going to be, if we are trying to run it on our machine, this is the interface that we could run it on, right? So 127.0.0.1 on port 8080. So if I set my proxy to this in my web browser, Burp Suite will be able to intercept it, right? So if I go here, let me go ahead and I'm going to click on the three lines over here on the top right, right? I'm going to go down here to settings. And then in settings, I'm going to search for proxy. So if I go there and I click on the settings for the proxy, notice right here, I kind of already did it ahead of time. Usually it's going to be something like either no proxy or it might say like auto detect or something, but you can click manual, right? And then we can be able to go ahead and specify right here, what is the address? Well, according to Burp Suite, it was 127.0.0.1. And then I can be able to specify the port. And according to Burp Suite, it was 8080, right? So once I do that and I hit OK, now this is going to have hey, if there's a proxy up there, it's going to be able to send it to that spot, right? So if I go over here, I go back to this, let's actually go ahead and refresh this. And I go over here to Burp Suite and I go back to intercept and I turn my intercept on. And let's go ahead and let's say that I refresh this again. If I go over here, once I do this over here, it should be able to go ahead and capture it. So let's go ahead. Let's see if I go to another website, let's see if it captures it. So we're seeing a few things right here. Let's see. Let me go ahead and turn this off and let me go ahead and reopen Firefox. Maybe by going ahead and having it come back on, it'll go ahead and have it with that stuff there so that we can go ahead and kind of find it. let's see, let's go 127.0.0.1. Let's go there. Go ahead and change that security once again. Let's go here to brute force. So here we kind of see that with what I'm kind of doing here a little bit, the first thing that came on, it did kind of capture right here, right? Again, we could drop, we could forward, we could be able to go ahead and do anything like that. You see right here, I'm going to go ahead and click drop for these. And then right here, if we go ahead and put in this information, it should be able to capture it. Or let's say if I go to google.com. So right here, we see I try to be able to go to google.com, it's able to capture it. Now, it may not be capturing what I'm doing on DVWA right now because DVWA is doing it on its own. So it's not, as Justin kind of mentioned this before in the previous thing, right? It's not actually going out on our network card, right? It's not going out in our adapter and reaching out. It's doing it internally because this is being hosted by our own machine. So that might be why for DVWA, doing it this way instead of in the Burp Suite browser, it doesn't seem to be capturing it. But once we go ahead and actually reach out, so right here, when on this tab, I try to go to google.com, we see that Burp Suite was able to kind of capture that, right? We see right here, it tells us where is it going to, right? So we can see this kind of reaching out to Google and it's trying to be able to go ahead and get some information and stuff. And so we can kind of do that as well. So we could, in fact, be able to go ahead and work with other browsers. And then, of course, if we just want to be able to do it real quick and easy, we could just open up the browser itself that Burp Suite has and be able to go ahead and go there, right? So there's those two different ways we can be able to work with it. So it could be that because of the Burp Suite browser that it has on its own, it was getting that error, right? Let's go ahead and turn this off. And that's why it wasn't really quite getting that combination that we saw, right? But yeah, if we go ahead and do it through a regular browser and we're able to go ahead and do that, then it should be able to go ahead and kind of show us that, hey, yeah, that can get through, rather than getting that we're having this error. So it seems like there's an error with the browser there that's happening. Let's see, Henry says, what about port 8080 instead of 42001? Well, port 8080 is the proxy, right? So here, when we're doing it in this one, this port that we're using right here is to connect specifically to our web interface for DVWA, right? So if we go ahead and go to port 8080, for example, this is trying to connect to, as we can see right here, our Burp Suite proxy, right? So yeah, so we can maybe go ahead and see that. I believe that John, who I think you were the one who said that you had the password, right, of admin and password that worked. So yeah, I believe that's correct. But we're going to see then. It does depend on kind of what's happening if our stuff is working correctly, which it seems right here inside of the browser that's happening for Burp Suite, that it's giving me an error at the moment. But yeah, we can be able to go ahead and send it to the intruder as we saw, to be able to go ahead and kind of automate this. We could send it to the repeater, do it more manually ourselves. And then once we go ahead and see that we get a 200 response, right? So once this comes back with a 200, we're seeing that it's able to actually get a valid response back. You sent it something and it's coming back with a valid website. All right, John says, I might have had to relaunch DVWA from terminal to circumvent that error. Let's try that. So let's go ahead. Let's see if we can be able to go ahead and DVWA stop. We'll go ahead and go DVWA start. All right, let's go ahead and let's see. I believe. Let's go ahead and hit OK for that. Let's go here. And we're going to go ahead and try this again. So at the moment, it still seems like our browser for inside of Burp Suite wasn't working. Let's try opening it up again, brand new. Let's try this again. So we've opened it up once again, brand new after we restarted the service. We switched it to low. We're going to our brute force. And yeah, so it still seems like there's an error there. I'll try and look into it why we are getting that error right now with the Burp Suite web browser. But that's the gist of how we're able to get it to work, right? And what we're looking for to see if we get a valid response there. So with that, we're going to go ahead and take a look at what's the next slide, right? So before we get into our server side vulnerabilities that Justin's going to go ahead and go over with us, let's take a look at our client side vulnerabilities, right? So we want to remember, we kind of expressed this on Monday, right? Whenever we're doing a connection, most modern connections nowadays takes the approach of client and a server, right? So we have whoever is initiating the communication, whoever's starting that talk, right, that discussion, they're the clients. Whoever they're connecting to, that's the server, right? Regardless of what the actual like specification or hardware is, it's whoever starts the communication, they're referred to as the clients. Whoever they are connecting to is the server. So here, excuse me, here when we're talking about client-side vulnerabilities, we're talking about what type of problems can happen with the information that our clients are able to see, that our clients are able to have access to, right? So anything that is loaded up and being maintained on the client side. So we kind of mentioned that right here, right? Client-side vulnerabilities refer to security incidents and breaches that occur on the customer or the user's computer system, rather than anything that's happening on the server side, the company side, right? Or what happens in between the two. So if it's not happening on the server, if it's not an issue with the information or the data or the software on the server side, then we refer to it as a client-side vulnerability. I would say most people think of web security as solely having to deal with attacks that are happening on the server side, right? When the user's web browser can also be targeted. But here are some examples of client side. So we're going to see that one of the biggest is known as cross-site scripting, or for short, we may refer to this as XSS, right? So cross, we'll refer to that in shorthand by the X, because it's crossing, right? And then site scripting, so XSS. So this occurs when an attacker uses a web application to send malicious code to a user. So for example, they may have uploaded this malicious code into the website, right? So then now anybody that goes to the website, when they see this information, something's going to happen, right? And so now it's not happening technically on the server side, right? That code isn't running on the server. That code is what is being loaded up on the client's website when they have their browser visiting, and that code is now executing on the client side, which makes it a client vulnerability, right? So they're sending this malicious code to the user, usually in the form of some type of arbitrary JavaScript that runs in the browser, right? Now, JavaScript can perform a lot of things, which is why it's kind of one of the de facto things in web development, right? So we could be able to have it do stuff like redirect the user to another site. Maybe it'll start running a keylogger, so we can be able to gain information like their passwords or their credentials, or maybe even more things like credit card information or social security numbers, right? And there's a lot more that we can be able to have this do, right? So we say, for example, here is something that we can be able to do, right? We have it that we are specifying in JavaScript that we are starting a particular script, right? So here, this is our beginning of this tag, so the beginning of our script, and here's the end tag for that, so the end of our script. And what are we having it do? Simply going ahead and creating an alert that says hello world, right? Let's go ahead, let's see if I can copy this. If I start up a new tab and I were to paste this inside, let's see if we can be able to find an example of this that kind of shows that. So here's showing a few different other ones. I was trying to see if we can have one that was a little bit more interactive. Let's see. This is a nice little online compiler that I like to use from time to time, Online GDB. I'm going to go right here. Let's say that we go ahead and switch this language over to, let's see, I believe one of the options should be HTML. There you go. And let's go ahead and paste this into here. So we're having it script alert hello world script, right? So we're just putting this as part of the HTML code that would be ran by a website, right? And if I click run here, let's see if it does it. Sometimes the online compiler works well and sometimes it doesn't, but if we were to have this as part of a thing, let's go ahead and leave that. Let's actually try it here. Let's see if I were to go ahead. let's actually try and create a document. I call this test.html. Now let's go ahead and let's open this up. Let's see. Let's open it up with mousepad. All right, I'm going to go ahead and go something like this. Let's paste that into there. Let's see. Let's go ahead and paste it into here. There we go. And now we should be able to go ahead and paste it into here. So let me go ahead and let me save that. And let's see, if I try and open this up now with Firefox. So I'll work on that, but we'll see then if we go ahead and take a look at that. Typically something like this, we'll be able to go ahead and get an alert box to be able to go ahead and pop up. It's not really much of one, and it's not really going to do a whole lot here because we're really just saying like, hey, just show this message right here with hello world, right? But it is enough to be able to go ahead and show the beginnings of what we can do with this type of stuff, right? If we can be able to go ahead and get an unintended script to run and do actions that we wanted to, then let's say if you go to something like Reddit, where people can be able to post whatever they want, right? If they didn't take protections against this, then somebody could be able to post or comment or do something where they're going to add in something like this script. And then anytime somebody goes to view that comment or view that post or whatever it is, that script would run and then have it do whatever they want, right? So that's kind of the main threat there and why we want to protect against cross-site scripting, because then the unintended effect is when somebody goes to visit a website, you're running this script that somebody else wrote. And again, we can be able to have it do a lot of things, right? Like redirecting them to another site. There might be a malicious site, right? Or it might be a fake of that site that then asks them to re-log in or something, right? I might go ahead and start up a keylogger or any other number of things. So then we see right here, there's really 3 different ways that cross-site scripting can happen, right? So the first is reflected cross-site scripting. We say this is the most common type of cross-site scripting. What happens here is that script that we're saying that they can be able to post, right? That they can be able to somehow be able to get into the website. This can be done anytime that you're trying to be able to go ahead and add something to a website. Maybe again, maybe it's a comment, maybe it's a post that they're adding to a message board, right? Whatever the case is, we refer to this as the injected script, right? So it's reflected off of the web server, hence the name reflected cross-site scripting, right? Because it's there on the web server. It's not being executed, it's not being run, but the moment we connect to that web server to be able to display that page, it's now showing us the script, right? And so it's running it when it gets to our browser. Something like an error message or a search result or any other response that includes some or all of the input sent to the server as part of the request can happen, right? So that actually goes into what we were dealing with our DVA, right? DVWA. When we took a look at that, we're seeing right here, we put this information here, for example, admin, and we're putting in our password here, right? And we see that it's being reflected back to us here. So that's more or less what we're seeing, right? Here it's saying, hey, here's the username, and it's showing us what we typed in, right? Here's the password, and it's showing us what we typed in. So what can happen is with our reflected cross-site scripting, we can type in something, right? Something into these forms, into these text fields. And then it's going to try and run it. It's going to try and execute it when it goes ahead and passes it along as part of the URL, right? And so that's kind of what we're kind of getting at, right? Let's see, if I were to go ahead and do it like that, or maybe we can go ahead and. So that's kind of what's happening with this first part right here, right? We see reflected cross-site scripting. We put some sort of input. We're typing something into the website, and then we're seeing it being sent back to us as part of the URL, as part of the request, right? The next one is stored cross-site scripting. So here the injected scripts are permanently stored on the target servers. This is more like the comment thing, the post thing that we were talking about before, right? So here is stored, something such as a database, maybe a message forum, It'll be the visitor log, a comment field or something like that. And so the victim retrieves that malicious script once they go and request that stored information. So if we see it coming back in the URL, that's reflected. If we see it that it's something like a post or a comment, that's stored, right? And the third is this DOM-based cross-site scripting. So the attack payload is executed as a modification of our document object model or DOM environment in the victim's browser used by the original client-side script so that the client-side code runs in an unexpected manner, right? So there's these three ways we can be able to go ahead and have this happening. Now, why do we call it cross-site scripting? Well, because somebody does it on the website on their end, right? And it's crossing their experience into yours, so to speak, right? So they either got it that, hey, I was able to post it on my end as a comment, it got stored. Now, when you visit it, it's executing on yours, right? Or for like the reflected, I'm able to go ahead and type this into the form, and I'm able to get it, go ahead and bounce back, right? And so stuff like that is happening. We also see then another attack that we want to be aware of is cross-site request forgery, or CSRF. So this is also known as session hijacking. This is an attack that forces an end user to execute unwanted actions on a web application in which they are currently authenticated. So for example, let's say we were able to log into that website, right, for DVWA. Well, part of what's happening when we log in, if we pay attention over here in Burp Suite, right? Let's see, let's go to the repeater. Right here, we get a cookie, right? This cookie is a unique combination, a unique sequence of letters, numbers, and so on. But what is it supposed to represent? Well, it tells us that right here. This is our PHP session ID. So if it sees somebody with this cookie, it assumes it's a specific person because it should be unique to that individual, right? So if somebody is able to find out what my cookie value is, and then they're able to use it themselves, as far as the server is concerned, that session is me, right? So that's what we're kind of talking about over here. This session hijacking is that they're able to now make the server think they're us. They've hijacked our session, that communication we were having with the server. So at that point, we're able to go ahead and they're able to take action as if they were authenticated already as us. So we say, for example, let's say you're currently authenticated to a website that handles bank transactions. If an attacker can get you to click a malicious link that makes your bank website send money to them, it's able to do so because, again, it's using that information, right, to be able to say, hey, I'm authenticated as this person, do this action. And so now the bank thinks that it's really them, and now they're sending money over to them instead of what you wanted to do, right? So these are the two main ideas. We have cross-site scripting and then this request forgery that we want to be aware of. These are client-side vulnerabilities. So right here, we can in fact go over, let's see, back to our DVWA, and we're going to see that, again, we have these two different ways we can be able to go ahead and deal with stuff, right? We have our stored, our reflected, and our DOM type of cross-site scripting. And we also have our CSRF right here that we can be able to go ahead and practice with, right? So let's say, let's go ahead and go right here with stored. Let's see. Let me go back over here. All right, so that is off. Let's actually go ahead and let's try it right here. So I'm gonna go ahead and try back over here inside of our Firefox, so that way you can be able to go ahead and go to that site. So we see again, we're still in low. We want to make sure that we're in low when we're doing this. Let's go right here to stored. And let's see. Might have to restart that. Let's try that. Let me go ahead and close down Firefox and let's try and restart the service. Let's go ahead and do it the long way then. Let's go ahead and stop. Let's go ahead and start it back up. All right, let's go here. Let's change this back to low. And let's see if we can be able to go ahead and view that stored website. All right, so it's not letting me show that right now. Let's see if there's another way that I can be able to go ahead and do this. Let me go ahead and stop sharing here real quick. So we're going to see that with DVWA, when it's working correctly, we should be able to see that we have that extra website right there. Similar to what we'll receive for brute force, it should be able to go ahead and show us a way to be able to go ahead and practice our different cross-site scripting stuff, as well as that request forgery. Let me see if there's a reason why my DVWA isn't working. Hmm. All right, so I want to go ahead and try and see if I can be able to work a little bit more on trying to be able to get my DVWA to be able to work properly. In the meantime, I want to go ahead and pull up a different website that could be able to hopefully let us be able to go ahead and practice out this XSS to be able to go ahead and kind of see what's happening. So let me share my screen again. And then hopefully with your own, I know that John was able to go ahead and get that to work properly, I believe, so that he could be able to log in using our brute force method. So with that, we should be able to go ahead and once we go over this example, you guys should be able to go ahead and be able to do this next exercise. So right here, I simply went ahead and went to this cross-site scripting. So xss-game.appspot. This is sort of a practice way to be able to do it on the web. So if we go right here, we see that this is just to be able to go ahead and kind of try and trigger it right here. So we see right here, it's kind of giving us a web browser simulation, right? And we have this query right here that, hey, if I type in something like literally the word something and I hit search, notice it's coming up right here with query equals something. So in that case, if I see that what I typed into that form, when I hit it again, right? Again, I can be able to try something else like name. If I hit search, we see that it popped up here. In that case, what type of vulnerability is this? So we already kind of know this is a cross-site scripting attack, but we said there was three main categories of cross-site scripting. Of those three, which one is it that if I type something in, I see it kind of in my URL? I see it as part of the request that I'm sending over to the server. All right, Antonino says stored, and John says reflected. So the actual answer is reflected. So stored, we want to think more like posts, more like comments on the website, right? That you can like type in and then submit it and it stays there. When it's more like the URL, that's being reflected back to us, right? So here, if we were to do this, right, if you wanted to be able to play this on your own, I could be able to go ahead and share this with you guys later on our Slack channel, right? If you guys want to try this later on, you'll see that it's going to actually show us the code, so we could toggle that for what is actually being done here in that little simulation for the web browser, right? And we can go ahead and scroll down to see the whole thing that's happening here in HTML and JavaScript. And then there's also hints. So for example, if I were to click show, we see right here, it says to see the source of the application, we can right click on the frame, choose view frame source, and then we can be able to use our develop tools to inspect the network traffic. What are we actually sending over? What's being happening? If I click 2, we see a second hint, what happens when you enter a presentation tag such as H1. So that's kind of giving us, again, that hint, right? So what if we were to try that out? If I were to go ahead and go back up here to that search bar, and if I were to say something like H1, hello, and then close it out. We hit search, notice it displays it. And it's not in regular text like we see right here, right? Where it says, sorry, there were no results for this. It shows it as header 1 or H1, right? So here's where we could be able to kind of do what we were talking about before, right? Where we could say script, and then we could be able to say alert, and then maybe something like hello, right? And then something to close out that script again. Let's try that. And look at that, there it is. So we see that it popped up a little alert box, says, congratulations, you got an alert. And here's the message that we told it to display, hello. So it says, now we can go to the next level. So this was an instance of a reflected cross-site script, right? And we were able to do something that we wanted it to get us to do, rather than something the designers, the people that created the website, intended for this website to do, right? So right now, all I did was get it to say hello to me. But what if I wanted to reach out onto the server and display some other information? What if I knew this, maybe this was a commerce website, and I knew that there was some financial information on there? Maybe I could have it reach onto the server and display that to me instead, right? So that's why we want to be able to try and be able to protect against stuff like this. We see right here, once you're done with a particular level, you can click advance to next level, for example. And so now here's level 2, right? Where it's going to go on to another version of our cross-site scripting attack. So if we go here, let's check out our exercise. All right, let me go ahead and reshare my screen. So hopefully that way it'll stop lagging for me. And let's see. All right, so here we are on the LMS. We've seen an example of our cross-site scripting attack that we were talking about, right? So here, hopefully your DVWA is working well. If not, we'll work with you guys to be able to go ahead and get it up and running. I'll try and see why mine isn't working well right now at the moment. But again, we're going to want to try and work with DVWA. We're going to want to have our security setting to low, right? We're going to go ahead and click on the left-hand side, as we kind of saw, right, that there's those 3 different categories of cross-site scripting attacks, right? If we go back right here, let me go ahead and let's go back again so we can see that. So here on the left-hand side, we see our different cross-site scripting attacks, right? So here we see XSS DOM, XSS reflected, XSS stored, right? So we're going to be working with one of those. Specifically, is saying to, let's look at the XSS reflected, right? And that's going to take us to our cross-site scripting portion of our DVWA website, where we can practice these types of attacks. And we want to exploit the site to make a pop-up occur that's going to say XSS vulnerability, right? So you want to go there, you want to kind of similar to what we just did, where we got an alert popping up saying hello, have one pop up saying this, right? and exploit the site to then cause it to redirect your browser to google.com. So once you get that alert to pop up and display that message, take it a step further. See if you can write a script that can then, once you load that up, right, once you submit that as part of the website, that instead of showing you the regular results you should be seeing, that it redirects you to google.com. Okay. Any questions whatsoever on this exercise? All right. In that case, Justin, if we have the breakout rooms available, let's go ahead and open them up and have fun working on cross-site scripting.
Of it. Did anybody have any issues? Show you something here. Share my screen again. So there's a few resources that we had given you down here on the bottom. One of them was this cheat sheet. Going through this cheat sheet, there's a couple things you could have done in here. Tells you about how you can drop tables. Here's some example of some line comments. If you knew that there was a username field and a password field, you can try injecting some code in there, some sample username and passwords. There's also another thing you could do if you were down here at the bottom. Where is it? There's a, it was up here at the top. Basically, like I was doing those 1 = 1 statements, right? So I was doing 1 = 1. We outputted some this first line, but if the SQL database is vulnerable and has not been configured correctly, you can use a statement like this: 1 - or 1 = 1. And when you do this statement, it would outprint the whole form. It doesn't always work. There's a couple examples out there. There's Red Tiger's Hack Kit. I just found this one today. Simple SQL injection. This one is showing you 2 different fields, right? You cannot do the same sheet, right, on here as you can, because it's disabled by default. But this is just one vulnerability that hackers or testers are looking to see if you actually did not set up to block this sort of injection. Say login incorrect. But we could do admin. This is just one free tool out there that I just was looking up. It's kind of like a game. I'll post this in the chat if you want to play with it. I don't know much about it. I just found it. But I want to show you on here, using this statement, you can use it almost across the board if you want to quickly test. This only has 1 box here for user ID, but if it had user ID and password, or maybe it said first name and surname, you could use this statement in both boxes to output the same list that I got here. What do we have in chat? How noisy is it to run SQL injections? How well does IDS or IDP detect these? So since you're, let's say you're only doing a couple bytes of data back and forth between a client to the server, so you're not really going to be detected. It's not very noisy. The SQL server, if it has any kind of like malware or virus detection software on it, it may detect like false login attempts. It just depends on how that server SQL database is set up. So IDS and IDP should not detect the SQL attacks because it's happening on the SQL database, which could be on any server. It could be on your host PC, like your laptop, or it could be remotely on a server somewhere. So detecting those types of things would be, how do you strengthen or harden your SQL database to prevent it from a possible SQL injection attack? Does that make sense? Okay. Any other questions? I'll post this red tiger thing here in the chat as well. If you use it, let me know how you like it. Again, I just found it after we were in the breakout rooms. Okay, so I want to get through one more thing before we knock off for the evening. I want us to open our labs back up. And we're going to start with my Ubuntu machine. There it is. We're going to the next part, which is command injection. So this is where you can then interact with hopefully getting like a reverse shell, a way of throwing a command type of injection, but command to that server to output some data. So command injection is a vulnerability that occurs when application allows an attacker to interface directly with the underlying server, that system, right? Which the application is running on. In other words, it will enable you to run those commands like you're right there on the system, like you're right there on the host. Exploiting the kind of vulnerability requires the knowledge of underlying operating system. So when we go into know what kind of, like right here, ls-tac-l, that's list. It's a list command for Unix or Linux. There's like the dir command for Windows. So knowing how an operating system works, knowing what commands work on different types of operating systems will really help you with command injections. Explain this type of vulnerability involves finding where the application interprets input from. So which field can you actually put this information in? And such as input text box on the HTTP request, that you can run these command injections and see if they're actually processing, and you can run burp suite at the same time. So when you're off time, if you want to run both applications at the same time to see if your input's actually being thrown over to the server, you can do that. One way to recognize vulnerabilities like these is when an application shows there's an output that looks like an operating system command, like the ping command. There's an example right here. If the web application appears to be feeding your input to the operating system, there may be a command injection vulnerability present. Means you can throw extra commands in here. The example here is ping localhost and, which means also do another thing right after, like no pause. Do this and this at the same time. So here's our example. So let's go over to our lab here, and we're going to go to command injection under DBWA. I'm going to close these other windows out to get them out of the way. So what can we do here? They're saying that we can do ping, right? Let's type ping in, right? Let's do 192.168.1.1, which is usually a server. Let's see what that comes back. Doesn't come back anything. It just says put in the IP address. So let's just try that. 192.168.1.1. Click that. Give it a second. You can see we've got some dots rolling up here on the left. Still thinking. Oh, okay. So we got an input. So just like running this on a terminal or a command prompt, it output the same information. So you may be thinking like, wow, like we can probably do something else with this. So let's type in IP address. So let's just do ping localhost. Didn't come back with anything. Let's just type in localhost. And what I'm doing here is just trying to figure out how the system is working. So if I type in localhost, which your localhost should be 127.0.0.1, which it did. So it pinged it just like you would do a ping command. 4 packets transmitted, 4 received, 0 lost. There's your time in milliseconds it took for the loop. So after that, what else could you do? I'm going to do what the example tells us to do. We're going to ping the localhost because obviously enter your IP address. What this first is going to do is it's going to do a ping command. And then we're saying we're going to ping the localhost and an ls-tacl. And why did I try these first couple things? I tried typing in ping, that didn't work because you can't ping. When I just typed in the IP address, the output says it was running a ping. So when you type anything in this box is running a ping. But we're using double and signs to say, while you're doing that, also let me do this too at the same time. So I'm gonna do an ls-tacl. Let's see what comes up. So you notice the ping happened. Right after the ping was done, here's your ls command. So it actually listed out 3 different things here on whatever area of the computer this was running. So I'm gonna do one more and let you guys run with this. Well, we only have 10 more minutes of class. So we're gonna play with this for another couple minutes, and then I'm gonna let you in your after hours run through this whole lab, and tomorrow we'll quickly go over it. So another thing I'm gonna try is we're gonna do localhost again, and we're gonna do the and, but what's something else we can do? We can type in who am I, right? Who am I comes back with www data. So that's just like running on my system here. Let's go over here. Let's come up a new one. That's just writing this, right? So I'm lab user on here. I'm www data on here. So what's another command you might want to run? You can get real fancy with this. We'll do, let's see, we can do netstat. You can see all the connections to the computer. Just like running a netstat command on your host computer. So that's why command injection is super fun. Okay, you can, and all this is within the website, right? You're not running a lot of data to it. You can see all these different connections going to and from, all the established wait times, what's running on the computer. One of the examples they told you to do is trying to do, I believe it was looking for view open network connections. So that's using the netstat command. View the Etsy password file. So you know Etsy password, right? That's going to be all your users and all your passwords that are unencrypted in the clear. So here's your Etsy password file. So MySQL. So it's there's no password on it. So what I want you guys to do is be able to play around with this, try to find and answer these couple questions. Kind of went through a couple of these with you. We viewed the file. I showed you how to use netstat to look at connections. Try try to find what user's running. That was who am I. So we just did that one. But go ahead and do these, retrieve the home directories on the server, and then answer these last two questions, A and B for 4. What can hackers do? Perform command line access to server, and what measures are taken to prevent this vulnerability? So these things you might have to look up, but we've got all these resources here that will make it super easy for you to go through and play with this. Is there any questions? Let me stop sharing so I can see everybody. Any questions on command injection, cross-site scripting, SQL injection? I know it was a lot, like 3 completely different avenues, but you can use them in a combination with each other as well. No? You just kind of want to run with it and play with it? See a couple of you hacking away right now, so okay. Well, good stuff. Tony, you have anything else for him for this evening?
Nothing really much. Just as a reminder that if you guys are experiencing any difficulties, or if you guys are getting stuck, or if you have any questions, remember that you guys can be able to go ahead and reach out to us, be able to ask, be able to go ahead and message us on Slack, and then we'll try and get back to you as soon as we're able to. I will also point out that Anusha has posted into our chat, since we're almost out of time, right? We're nearing the end of our time today. The link for feedback for tonight's session. So please go ahead and make sure to click on that, give us some feedback. I will also be posting it in the Slack channel in case you guys need that. So that way you guys can go ahead and be able to provide that valuable information for us.
Well, I want to greatly appreciate everyone's time and attention tonight. So have fun with those. We will see you tomorrow night, and we'll hang around here for a couple minutes if anybody has any questions.
I have a quick question.
Go ahead.
Can you hear me?
I can hear
Yep.
you.
So, yeah, I was struggling to access the DVWA. Finally, I was able to get it running. So I missed some of the stuff that we covered. So I was just trying to see for exercise, the previous exercise for what was it, 3? Yeah, for 3B, number 2, navigate to DVWA login page within the burp site browser. I'm not sure how to do that. If you can walk me through real quick.
So if we're on the Ubuntu machine, like what we're doing for the server side, right? It's already been installed, and it's a little bit different than what we were showing for the Kali machine, right? So for here, we can be able to go ahead and start up Firefox.
Yeah.
Once Firefox is installed, it's actually running on the local server that we have. So if we were to go to localhost, we'll notice it takes us to the Apache 2 server that the machine is running. But then we can go /DVWA, and it'll actually take us to the DVWA website that's running on the Ubuntu one, right? We can click log in, and then we see that we are able to access the servers here. Now, we could actually do the exact same thing over here, right? If I were to go ahead and let's say I were to start a new Firefox web browser right here, since our 2 machines, right, our Ubuntu and the Kali machine are running on the same virtual network, right? I could actually be able to access that if I wanted to. So I could be able to go ahead and say over here in Ubuntu, for example, let me go ahead. Let's see. We go here to activities. Let me go back to my terminal. And then over here, if I were to go ahead and type in IPA, we see that this is my IP address for my Ubuntu machine, right? 172.172.31.0.127. So I can say over here, let's go to 172.31.0.127. If I go there, we'll notice that here's that same Apache website, right? That we saw when we went ahead and opened up ours. So I could go right here and I could go /DVWA And if I go there, here's the DVWA website that's running on the Ubuntu server, right? So if I wanted to, for working with Burp Suite, I could actually go ahead, open up Burp Suite right here and do the exact same thing, right? This address we have right here to get the one from our Ubuntu machine, I can be able to go ahead and copy this address and then come here to Burp Suite, go ahead and start it up with the default settings. And then we'll go to the proxy that our Burp Suite software has. And recall one of the settings when we go there, right? So I'm going to click here on proxy. One of the things was to open up the web browser that's connected straight away to our Burp Suite. And then I can just be able to give it that same address, right? And we'll see that it takes us there. And then of course, the password and the username is going to be admin password. And so then once we go ahead and log in, if I type correctly, we should be in, and then we can be able to go ahead and use this. And then we just continue on from there.
Sounds good. Thank you so much, Tony. Appreciate
You're
it.
welcome.
All right. Have a good night, guys.
You too. For everyone else that is still here, if you have any questions, feel free to be able to unmute yourself and be able to ask. You can also be able to go ahead and type it into the chat. That way we can be able to address your concerns. Otherwise, have a wonderful night. We'll see you tomorrow. All right. Have a wonderful night, Justin. Have a wonderful night, Anusha.
Sounds good. See you tomorrow.
I'll see you tomorrow.
See you tomorrow.
All right. So it is now 5:34. There are 21 of us logged in. So that's pretty good. We're going to go ahead and get started. So if we look at our LMS for today, we're going to see that we're going to continue on with our red team, of course, right? So far, when we've gone over our red team concepts, what we've seen so far is we've gone over how to be able to go ahead and do recon, first of all, right? As a matter of fact, let's go ahead and let's see if I can be able to find an image. Let's see. So this is kind of what we're looking at, right? We're kind of looking at this as we kind of see. This is what's known as the hacker methodology, right? So we started with up here in reconnaissance, and we were learning about how before we actually do anything, right? Anytime we're looking to be able to go ahead and gain access, right, to an machine that we are unauthorized for, right? We're trying to gain access to it by doing this kind of concept of hacking it, right? Being able to go ahead and do either penetration testing or do red teaming in general, right? The first thing is reconnaissance. And we saw how to be able to go ahead and do that, right? We saw that there is active reconnaissance and there's passive reconnaissance. And when we were talking about that, we said with passive reconnaissance, it's all about what can we find out without directly going to our target, right? So this is that we're not actually touching their servers. We're not going to their network. We're not going to their resources. If it's something that they own, if it's something that's theirs, we're not touching it when we're doing passive reconnaissance typically, right? Or something to that effect. When it comes to active reconnaissance, now we're going and kind of touching their stuff, right? We're poking the bear, so to speak. And that increases our likelihood that the target finds out of what we're planning to do, right? Because now we're actually engaging with their resources, we're connecting to their servers, we're scanning their network, possibly stuff like that, right? And so then we're doing this just to gain information, right? And so then we're going to see that what happens next is we're then trying to be able to make sense of that, right? So once we get our reconnaissance down, we're going to see, can we be able to go ahead and scan and find vulnerabilities, right? So with getting all this information, the next thing we learned about after recon was about the different types of vulnerabilities that are possible, right? So we talked about client-side vulnerabilities. We talked about server-side vulnerabilities. We talked about vulnerabilities that might be a part of the operating system or might be a part of just social engineering, right? Because we pointed out, even if you were to make the perfect system, if we were to go ahead and make something 100% secure, there's still the human elements, right? There's still the fact that we might be able to go ahead and talk to somebody and convince them to help us out or give us information they shouldn't, or whatever the case is, right? Maybe give us unauthorized access physically to a location that we shouldn't be by simply saying, oh, I forgot my pass. Can you be able to let me in this one time, right? Or something similar. So that's to then gain access, right? So we see then we can be able to see what these vulnerabilities are, and then in trying to use these vulnerabilities, that's what we're doing today, right? We're trying to be able to then exploit them. So when we're exploiting them, if you recall, when we went over these definitions, we said that a vulnerability was a weakness, right? And then an exploit is something that's taking advantage of that weakness, right? Something that's acting upon that weakness. And then we said risk was the likelihood that that actually happens, right? So he said that you can picture it kind of like a percentage. So a risk is the percent chance that somebody actually will exploit that vulnerability. So that's what we're learning about now, right? We're going to see how we can be able to go ahead and do an exploit to be able to gain that access through the vulnerabilities that we've been learning about, right? Now let's see, in the chat, Abel says, I'm curious, it looks like we're almost done with red team, and the only other thing left to cover that is blue team. When is the last day of class? Excellent question. I believe it's either towards the end of September or it might be the beginning of October. I'd have to double check on that to be able to get the actual day, but it's around that time that we're going to see that that'll be our last class day, right? So I'll find that out soon so that way we can be able to know, and we'll let you know when your graduation day will be, right? Let's see, Justin points out a good thing. So we are going to be wrapping up red team soon, right? And then after that, we do have about a month of blue team. And then towards the end, we do have it that we're going to have a career simulation project that you guys will be working on for the last few weeks. So that is correct. And then I believe Justin was able to find out our dates. He says the tentative on our schedule for the last day seems to be September 28th. All right. So that's where we're at right now, right? We're learning about how we can be able to go ahead and take these vulnerabilities that we've seen and how we can exploit them. What can we do to then be able to actually take advantage of them, right? So that's our next spot. Let's see, Joel says, will we have access to our VM lab after graduating? I'm not 100% certain, but if I had to hazard a guess, I would say probably not. But let me double check with that. Let me confirm that and we'll find out for you guys. Okay. Let's see. So we're going to see right here. Where are we going? Well, if we go to our self-learning track, we're going to see then up on the right here, we are going to be going ahead and looking at 1.9, right? So exploitation with Metasploit. So Metasploit is an entire framework that's already kind of been pre-built up with a lot of tools, a lot of exploits available. So that way we can be able to go ahead and kind of see what we can do when we find a vulnerability, right? So we kind of see that right here. When we use Nessus, like we saw how to do last week, right? Nessus was an automatic scanner that can kind of show us what vulnerabilities it was able to auto detect, right? Same thing with Nmap, right? It's able to go ahead and scan. And if we do it right, we can even find out what version of software that we are running. And so therefore, we can do a Google search to find out, hey, are there any vulnerabilities for that version of our software, right? And so when we do these things, we can get a lot of information, right? And so we see right here, after doing some analysis on things like our Windows systems, we can be able to go ahead and find that a lot of the times the vulnerability is just something as simple as it being old software, right? And so there is a vulnerability in that software that did get fixed, it did get patched, or it did get updated, so that way it no longer has it. But if it's running an old version of that Windows system that didn't get updated, right, then it still has that vulnerability. So we point out right here, you've come across an older Windows server that appears to have been forgotten. It seems to be running an older version of Windows, meaning it has been on the network for quite some time. There's a good chance that there's some sensitive information that is on this server. And we are going to see how we can use our tool, Metasploit, to be able to gain access to it, right? So we're going to see that part of our learning objectives with this module tonight, we're going to see how we can be able to take a look at emerging security issues, risks, and vulnerabilities that are happening, right? How we can be able to go ahead and take a look at the different modules inside of Metasploit, and then how we can be able to explain their purpose. And then we're going to see how we can be able to start up what's known as a interpreter session. This is a way of being able to kind of almost do a shell like we saw how to do last week, right? Where we could be able to go ahead and do a bind shell or a reverse shell. But we're going to have it as our interpreter software kind of being the middleman, setting up stuff for us, right? And handling that shell for us. And then we're going to try and see if we can be able to cause malicious payloads. We're going to actually create an exploit using what's known as MSF Venom. This is a module inside of Metasploit as well, right? So anything we do in MSF Venom, we can do in Metasploit. And then this is a way of being able to then create that exploit and then be able to use it to be able to gain that unauthorized access, right? So for example, we said before, when it came to doing our shells, we needed that physical access, right? As Justin put it, let's say that we had Jake Doe as a coworker and they were just down the hall. We'd wait for them to leave their room. We'd go into their office, and then we'd be able to go ahead and start up a bind shell or maybe a reverse shell by having them go ahead and do something like NCAT with a listener, or maybe writing up our Python script that we used last time, right? And being able to go ahead and run that so that we could connect to our computer, giving us access to their machine. And now we're able to go ahead and kind of control their machine. But we're going to see here, one of you guys asked, well, how would I be able to do that? Would I need that physical access every time? And we said doing it that way, yes, right? But ultimately, if we were trying to be able to do something malicious, that's going to be impractical, right? We can't be able to gain access to everybody's machine physically. So that's where we're going to kind of learn how to be able to get around with this MSF Venom, right? We're going to see how can I be able to go ahead and construct sort of like a script or a program that if I can be able to trick them to download it, or if I can install it on their machine somehow and then get it to run, that it will give me that access, right? It'll go ahead and automatically give me that shell. And now I have control of their machine. So that's what we refer to as a payload, right? So we're going to see how we can craft that, how we can be able to form that using known exploits, and then how we can be able to go ahead and use it to be able to then give us that access that we're looking for. So this first activity we're going to see is precisely that, right? We're going to take a look at MSF Venom. So as we mentioned, right, this is a way of being able to go ahead and generate malicious things, malicious items. So you want to be able to kind of be a little bit careful with what you're working on here. If we're doing it in our virtual machines, that's fine, that's good. But if you're going to do it on an actual machine, of course, be careful with what you're doing it to, and you want to make sure that you have full control over it, right? That it's your machine, or you have complete permission from the owner to do it, right? You don't want to just do it randomly on somebody's machine that you didn't have permission to touch. So it is a malicious payload generation program. It can generate payloads, many different types of payloads, right? Including compiled programs, what we call raw programs, and more. Most of these payloads are going to give us a reverse shell, right? As we kind of talked about our shells, that's typically what we're kind of doing most of the time when we're doing hacking, right? If we want to be able to have that physical kind of control over their machine, we're going to want access to their shell. And it's typically, as we pointed out, that bind shells more and more lately, we're able to deal with that through firewalls, right? We're able to have a firewall to be able to prevent things like that. So the more common type of shell that you're going to see is reverse shells. And so that's what's happening right here. Most of the payloads are going to be happening that we're going to be creating through something like MSF Venom are going to be these type of reverse shells, right? Maybe a interpreter shell, which is simply that interpreter is handling everything for us. It's kind of being that middleman, but essentially the style is still going to be that reverse shell, right? Or it's simply going to be a program that's going to automatically run commands for us. It's going to execute those things for us on the target system, right? Now, you can create payloads for all major operating systems and programming languages with MSF Venom, right? The great part of MSF Venom is that it allows you to be able to customize the generated payload, right? So you can be able to go ahead and look at the exploits, see what's available, and then you can kind of customize what you're going to be creating this for, right? Based on the options that are available. So here are some ways that we can be able to go ahead and customize the resulting payloads, right? First is encoding, right? How are we going to go ahead and encode this? So is this going to be encoded for like a Linux machine or a Windows machine or a Mac, right? And then what type of formatting is this going to be? Is this going to be like .msi from Windows, or is it going to be .exe, right? Things like that. So we're going to go ahead and convert things into a particular form, right? There's also obfuscation. So here we're mixing, jumbling, or obscuring some information so that way it doesn't look malicious, right? Even though it is. So this you can kind of picture kind of like a Trojan horse, right? So when it comes to Trojans, obviously, hence the name, they're made to look like something that's legitimate, something that is safe, right? That way it gets past their defenses. And then when they run it, it might even run something that looks like that software, or it maybe even is a version of that software, but it has our malicious software included in it so that when they start that program up, it also starts our malicious code, and then we have that access, right? So we can be able to do that obfuscation. And then there's also encryption that's possible. So this is a process of changing information into a type of secret code, and then later on being able to change it back to its original form, right? We've seen this already in previous modules. Now we're going to see right here, when it comes to our interpreter shell, it comes in two flavors, right? There's staged, and then there's stageless. Both of them have their pros and their cons for why you might use one versus the other. We're going to see here, the main difference we're going to say is that our staged payloads, they tend to be smaller, right? That means they can be included in more types of exploitations, right? So the code is smaller because we're doing this in different stages. You can picture it kind of like a shuttle rocket, right? Or something to go to space, right? Where they have the giant shuttles, the giant engines that they're having for the rocket to be able to fly out into space, and they'll burn it off in stages, right? So they'll have the first stage rocket. Once that's done, they'll kind of let it go and then burn the second stage rocket, and so on and so forth. So that's what our stage payload is doing, right? Each part is only good for a certain portion of what we're trying to attempt, right? And then we're done with it. We move on to the next thing. So it's broken up into small different parts. And since those are small parts, we can be able to go ahead and do different things with them. It's a little bit more flexible, right? But we're going to see that we then have to reach back out to our server, right? Our Metasploit C2 server. C2 is kind of a command and conquer, right? The fact that we're having this, that they're reaching back out to us essentially, right? To communicate and figure out what to do next or to get the next stage. So because they're having to reach out to find out what's the next thing they need to do to execute, this can be able to make it a little bit riskier for getting caught, right? Because now there's more network traffic, so things look a little bit more shady, right? And then we have our stageless payloads. So here, everything that's necessary is included from the very beginning, right? So everything the payload needs to execute is already included in the payload itself. This makes the payload bigger, but it also makes it more reliable because it doesn't have to keep reaching out to us anymore, right? Now, we're going to see right here, we have some commands. We're going to try this out, see if it works, and then be able to move forward. But we're going to see then, we're going to take a look at MSF Venom and just see what's available, right? So the first thing is we're going to try and see if we can be able to take a look at what payloads are available for MSF Venom, right? Then once we find something that's appropriate for our system, we're going to go ahead and attempt to use that exploit, right? We'll be able to customize to where it connects so that way it knows what to do, right? For example, we see right here, we have the following command. It's supposed to be able to generate a bash script, right? So a bash payload that's supposed to do a reverse shell, and then it's supposed to go ahead and connect to here, right? So we're going to see in this case, this script that they're having us test out for this one is going to connect back to ourselves, right? So this is supposed to connect to our local computer. Specifically, it's going to try and connect on port 1234, right? So that's going to be what we're going to try and do, right? So let's go ahead and take a look at that. Let's see if my lab is ready. Let's see in the chat first, though. Let's see. Alex says, Justin, is it possible to set up a virtual network like some of the labs with multiple PCs that we can practice adding to a domain and establishing permissions? Yes, as Justin does answer, there's a way to be able to do it, right? You could be able to go ahead and download hypervisors, something like VirtualBox, right? Or other types of virtual machine programs like that. You can be able to go ahead and establish your own that way. Do be aware that they are resource intensive. So you need to make sure that if you're doing that on your own with your own virtual machine software, that you have enough resources on your computer, right? At least 16 gigabytes of RAM or more, so that way they don't sputter. And you would also want to be able to go ahead and be aware that they take up a lot of hard drive space typically as well, because you're simulating an entire hard drive of, another computer, right? So there are ways to be able to kind of do what we do with our virtual machines on your own as well. All right, let me go ahead and stop sharing this, and let me go ahead and take a look at my virtual machine. Let's see if we have that up and running. I believe that it is. So let me go ahead and get this.
While Tony's doing that, I just want to let everyone know if that is something you're interested in, right? If you're interested in how do you set up a little lab on their off time, I'd be more than happy to take either Saturday or Sunday as the class. Whoever we'll do like a joint class, and we can go over that real quick. I know coming to the end of all this learning, all of your labs, all of your projects, that may be something you're interested in. It's not covered fully in this course, but it is a good mentoring session that we can all go over, because if you're staying in this environment, you're staying within this minefield and this mindset that you're going to want to test out distributions. You're going to want to test out some pieces of software. You want to do it in a safe environment that doesn't affect your main computer, right? You put a lot of time and effort into your gaming rig or your editing rig or whatever you do, and you don't want to have anything conflict with it. So it's something that's fun to do. I enjoy doing it. I've got a couple spare boxes I've set up, but if you like to do that, I'd be more than happy to. And we'll take a poll here in a couple weeks and go over that.
Excellent. Thank you for that. So yeah, so definitely, as Justin pointed out, we could be able to go ahead and be able to help out with that with anybody that's interested. So let's see, let me go ahead and let me share my screen. All right, so once again, if we take a look at this, right, we were in our recon lab. We were first learning how to be able to do reconnaissance, how to be able to gather information. We then moved on from that, and we went into the vulnerabilities lab. Once we started learning about the different types of vulnerabilities, the different weaknesses that were possible that we can be able to quickly learn about, right? So our client vulnerabilities, our server vulnerabilities, and so on. And so now we're in the third lab, right? So if you were to go ahead and click onto the practice labs up near the top, we're going to see that what we should be going to is past the vulnerabilities, right? So we're going to be going over to exploits now. And so here, when we go, you'll notice up at the top, you want to make sure, just like Justin was pointing out, right, in our chat at the beginning of class, you should see that there is a Kali machine, and then there are some Windows machines, right? So if you don't see Kali and then 2 Windows machines, go back to the practice labs and make sure you're going into the right ones, right? So that way we can be able to go ahead and deal with this. So here, we're going to see then, we're dealing with MSF Venom, right? So we can be able to go ahead and go like that. And if I hit enter, we're going to see that it gives us some help, right? It tells us, hey, there's an error. You didn't give us any options. And so it gives us a little bit of information about this, right? So it is recognized as already being on Kali. I believe Kali has MSF Venom typically installed by default. So it should be something that's already there on your Kali machine. You shouldn't be having to download this. And so we see right here, MSF Venom is a Metasploit standalone payload generator. So as we kind of mentioned already, right, it is a part of Metasploit. So Metasploit is an entire framework tool to be able to do a lot of things. And we'll see a little bit more of as we're going through this tonight, right? But MSF Venom is just a standalone portion, a small part of Metasploit, right? So we're going to see right here, it gives us some examples, right? So it shows us the usage of how we can be able to go ahead and use Metasploit. Or in this case, MSF Venom. So right here, we start off with MSF Venom, right? They're using in this example an absolute path, but since we already had this properly installed, we can just simply start with just MSF Venom. We don't have to tell it where is it located. It'll find it in the command path and be able to execute it, right? Then we can be able to provide any options and then any values for variables, right? So then we see that example right here. They start off with MSF Venom. We're going to see that they then go -P, right? And so that's going to be, as we see down here, the payload. So we're specifying what payload we want to use. In other words, which exploit are we trying to customize here, right? So they're saying right here, it's going to be a Windows exploit. Well, what kind? One that's using Meterpreter. Well, what are we establishing? We're establishing a reverse shell that will communicate over TCP, right? And we'll take a look in a little bit how we can find something like that so we know which payload to use, right? So we're specifying this particular payload. We want to be able to use this payload that's meant for Windows. It's going to establish a Meterpreter payload that's doing a reverse shell for us. Then after that, we're setting up our variables and what values do they have to have, right? So we're going to see right here, well, typically, a lot of the times, we're going to need to specify what is the L host. Shell here, who's the attacker? What is their address? That way, once this runs, it knows who to dial home to. Who is it going to call, right? So who is the listening host? And then we'll set this equal to whatever IP address we want to have it dial when it's executed, right? We're going to see next comes -F. Well, again, we look down right here. We're going to see -F is the format. So this is going to go ahead and create the virus or the Trojan or whatever malicious payload we want, right? And this is going to be the outputted format of that file when we create it. So since this is meant for Windows, you'll notice we're specifying the format should be EXE, right? And then finally, we're going to see -O. Well, that is the actual output. So what is the actual file name that we are creating once we're done with this, right? So we're saying -O, the name, the output that we should be creating is a file that we're going to call payload.exe, right? So that's what's happening here with this example. We're saying we're going to use MSF Venom to then reach into its arsenal, right? Its bag of weapons. And we're going to get this one that's for Windows using Meterpreter, creating a reverse shell. We're going to have it then dial back to whatever IP address we have as the L host, the listening host. We're going to have it formatted to be an EXE type program, and we're going to call it payload.exe, right? Now we're going to see a few other options in here as well, right? -L, we'll go ahead and list out our things, right? So we can list out all the modules for a particular type, right? So we could be able to say something like list out everything for the payloads, right? Or list out all the encoders. Or we're going to see right here, NOPS or NOPS, right? These are typically non-operators, right? So stuff to be able to kind of pad things with, we'll see. We're gonna see right here, platforms, architectures or ARCs, encryptions, so on and so forth, right? Formats, or we can be able to say something like all. So what is it that we're trying to list out, right? We already saw -P for our payload, -F for a particular format. We mentioned in our LMS that we could also do encoding, right? So -E for the encoder. And then we could be able to say, this is again, which type of encoding are we trying to be able to use? We could be able to use, as it shows us right here, --list or just a -L and then encoders to see what type of encoding we can do, right? We see then going further, -A for the different architectures, -N for a NOP sled. That's a little bit more advanced, but that's to be able to create some stuff that just kind of pads the program with non-operations, things that aren't going to really change much until we get to a certain part to be able to then execute things. That's usually when we're kind of getting a little bit more advanced in our exploits. And then we can be able to go ahead and see that there's a few more, right? -S for space, -I for iterations, and so on and so forth. And you can see what those are for. That's getting a little bit more advanced than what we want to typically. So let's go ahead and clear this. And let's see, in the chat, Justin, again, goes ahead and points out to us, thankfully, that our L host refers to the IP of our machine, right? So he also points out that there is another thing we're going to see very similar called an R host. And so that's typically going to be the target. So yes, if we see something like L host, we are going to picture that this is the listening host, right? And this is typically going to be us as the attacker, right? So whenever you see that, typically it's what is your IP address? So it knows who is listening for this and where to go back to, right? And then we're going to see if we see something like our host, this is going to be the receiver host, right? So this is typically going to be the target. So who are we targeting? Who is receiving this, right? So when we see those variables, that's what it's referring to typically, right? And then of course, if we see something like an L port or an R port or something similar to that, same thing, right? The listener or the receiver. So let's go ahead and let's try this first of all. The first one, we're going to try and see if we can be able to list out the payloads, right? So according to the help, it told us we can go MSF Venom, right? We could go -L to be able to list, and then we can be able to specify what is it that we want to be able to go ahead and list out, right? So let's go ahead, let's try -L payloads, and let's see how long that takes to be able to go ahead and show us that information. So here we're specifically targeting the different payloads that it has available. Let's see, it says to use retry middleware with Faraday version 2.0.
The typical
installed.
error. Just give it a second. It will go through.
Yep. So part of why it's taking a while is it's going through and gathering all the information, and that can take some time to go ahead and get all those payloads that are available. And there we go. So we see here it's kind of telling us, and it's organized in a certain way, right? So if I scroll up, we're going to see that there are a ton of payloads here, right? So the first thing, we're going to see that this is broken up into two parts, right? The name of the payload, and then a description for us of what is it trying to do, what is happening, right? Now, we're going to see in the name, it's typically going to be broken down into different parts, right? The first part is kind of what is it, the operating system, or what is the machine, the platform that it's intended for, right? So we see right here, these first few are AIX. We see that there are a few for Android. We see that there are a few for Apple iOS, right? And so we see here BSD, a type of operating system, right? If we go a little bit further, CMD, right? So this is going to be probably the command prompt for Windows. And if we go further down, we see that there's a variation of a lot of these, right? So we see there's a ton of these CMD ones. Eventually, if we go far down enough, we'll see some for like Linux, right? We saw some for Java there. And then we're going to see that typically after the operating system, it's going to tell us the type of architecture, or like what are we using, right? So right here, you'll notice that this is for a 64-bit architecture of Linux. So this is more like your more modern versions, right? But we also have some, for example, right here of x86. So if you see something like x86, this is your 32-bit architecture, right? So a little bit older, but still backwards compatible a lot of the time, right? And then finally, the last thing is going to be typically, what is it that we're actually trying to accomplish, right? So here, this is trying to exploit the add user command, right? This one's trying to exploit the chmod command. Here, we're going to see that this one is trying to be able to go ahead and establish a reverse shell using IPv6. Here is going to be probably one that we might use, right? Where we're going to do a reverse shell through just standard TCP, right? And we can see over here a little bit of that description in case we were unsure, right? That, hey, this Linux for 64-bit architecture that's creating a shell that's a reverse shell over TCP. Well, this is just to connect back to the attacker and spawn a command shell, right? So what can we do? Since this is a lot of stuff, right? These are a lot of things. Well, depending on what we're trying to do, right? If you recall, when we went back all the way to our Linux at the beginning of the boot camp, we learned how we can pipe commands over, right? So I can be able to go ahead, let's clear this. And let's put in that same command. I'm going to pipe this over to grep, right? And then all I have to do is just put in what is it that I want to look for. So maybe there's a specific theme I'm looking for, or a specific platform that I'm looking for, right? So let's say I just want Windows. So I can be able to see just the Windows payloads. Well, I could do this. And again, it'll still take some time because it's still going to go through, get all those payloads, right? But then it's going to pipe it over to grep, and then it's going to pull out just the ones that are Windows, right? So we see then here, once it's done, these are all the ones that are just dealing with Windows, right? Now, of course, if we have a little bit more of a specific thing we are looking for, we could, right? So for example, maybe this is what we want, right? So we see right here, this is Windows/shell reverse TCP. And again, we see right here, this is going to connect back to the attacker and spawn a command shell, right? So we can be able to go ahead and do something like that. So that's going to show us where we can be able to find what payloads are available and kind of how we can search through them if we want to, right? If we want for reference later on, John shows in the chat, because that it does take so long every time we run this, he did it once, and then he did a redirect to a file that he can then just be able to grab through that file in the future to be able to kind of figure out what's there. And that can work, right? But keep in mind, if we update MSF Venom, some of those things might change. So you might need to run that again if you do something like that, right? But that would be a good way to be able to kind of have an idea of what payloads are available. So we have our payload, right? And so now the next thing it's doing is let's try to be able to go ahead and do this. So here it's saying we're going to call up MSF Venom. This particular payload we're going to see is working through a command prompt. Here specifically is still with a Unix operating system, so a Unix style thing, right? And it's going to try and be able to set up a reverse bash shell. And then it's going to try and connect to ourselves, right? So it's going to connect to the local host, our own machine, so 127.0.0.1 on port 1234. Now, if we do something like this and then run it, we are going to need to already have something waiting and listening for this, right? So let me go ahead and let's go File. I'm going to go New tab. So you'll notice I have two tabs here, right? And so here, let's go ahead and set up a listener. So I'm going to say NC, our netcat, right? And then I'm going to go LVNP. So if you recall the -L, we are telling it to listen, right? V is verbose. N is we're having it not use the DNS server so that we can go a little bit faster, right? And then P, we're going to specify what port we want it to listen on, right? So we're going to say 1, 2, 3, 4. So now we see that it is listening, right? And so over here, let's try and see if we can be able to run this command and if it will connect to our listener, right? Now, we're able to do it on the same machine because we're having it connect to ourselves, right? So that's why we're setting up the listener on machine and then running this on that machine, right? So we're going to see right here, MSF Venom -P. So we're going to say MSF Venom -P for our payload. And then we're going to go ahead and go cmd/unix/reverse_bash. So cmd unix reverse_bash. And then we're going to fill in this information right here, right? So we need to let it know who is it needing to dial out to. So who is the listener? We're going to set it to ourselves. So L host. And let's see. Let's stick with it the way it's showing right there. So no space. L host equals 127.0.0.1. And then we're going to go ahead and say L port. So as we mentioned, if you see something like L port or R port, it's the same thing as we saw with L host and R host, right? So L port, what port are we listening on? If it was R port, the receiver, the target, what port are we going to try to communicate to them on, right? So here, L port 1234, which is what we were listening on. So L port equals 1234. Let's hit enter and let's see what happens. So here it was listening. Here it's going to go ahead and try to do it. We see we get that same standard error. Let's see if it's able to go ahead and connect. So here it says that there was no encoder specified. It says no platform was selected. So it's going to go ahead and choose the default platform of Unix from the payload. So that was what was already kind of set up for that exploit by default, since we didn't specify a different one. Here, no architecture was selected. So again, the default is the CMD, right? So it's going to say we're sticking with that for the payload. Since no encoder was specified, it does stick with a raw payload, so it's not changing it, right? And so then it says, here's our payload size, 68 bytes, right? And then it has this right here. So I believe if we copy this, what it's doing is it's doing a bash command, right? And then -C right here to be able to execute the following. And so it's encoding it the way that it should, right? It's telling it to then execute the following. What is it going to do? It's going to go here and try to be able to connect over TCP to the IP address that we gave on the port that we gave, and then trying to be able to establish a shell, right? So let's see. Let's go ahead. Let's copy this. And if I were to run this, let's see. Let me actually. Let's see, it says right here, bash redirection error cannot duplicate our thing, file descriptor. Let's see. So I think that it had already done what we were trying to do when we first ran it, because we see right here, it does say that there was a connection that happened. It says that they connected to us from, and of course it was us, and then even tells us the port that was being used. So I think that when we first ran this, it did exactly that. It was able to go ahead and create this, and then it was able to go ahead and establish that connection. We didn't really tell it to do much else besides that. So it was able to go ahead and establish that connection, and that was it. So it was a pretty straightforward thing, not very exciting, but it was able to go ahead and connect, and we can see that evidence right here on our listener. Now, of course, we can be able to go ahead and kind of do more than that, right? What else can we be able to go ahead and do? Well, let's see. We can be able to go ahead and let's take a look at some Python stuff. So I'm going to go back over here. Let's clear this. Let's go back to our MSF Venom. Let's do another list of payloads. And to get a little bit more exciting, let's look at what we can do with Python. So I'm going to go ahead and say grep for Python. So we're going to see here then, there's quite a few different things we can do with Python. We see right here, we see, for example, ping back reverse or a regular shell for a bind shell, right? Here, there's a shell for reverse TCP and so on and so forth, right? Here, we'll notice that this is doing an interactive shell via Python, right? So we kind of see that happening there. Let's see. The example that they would like us to show, we're going to go ahead and try a Meterpreter one. I believe it is this one right here. So we're going to try and be able to set up this Meterpreter reverse shell. So Meterpreter reverse TCP. And then we're going to do similar kind of to what we just did, except for we're going to go ahead and try a different port this time. We're going to try port 4444. So let's go ahead. We're going to say MSF Venom -P for our payloads. We're going to go ahead and use that name. So this is Python /Meterpreter /reverse TCP. So we've established the payload. And then similar to what we just did, we're going to have to do an L host, right? So who are we going to go ahead and call? We're going to still set this to ourselves. And then we're going to see then after that, what are we going to go ahead and do next? We're going to establish our ports next, kind of like what we had already done, right? So L ports equals 4444. And so again, I'm going to have to go here and set up our listener. So that way it's already listening, waiting for this connection, right? So I'm going to say, let's go ahead and listen on port 4444. Now we're going to go ahead and set up this Python Meterpreter reverse shell, connecting to us on port 4444. And so we're going to run that. We see over here, we are listening just like before. We got that little standard error. We're going to then see how it runs through. And then let's see. Was it able to connect? So if we look at this right here, first of all, we'll notice that this is a type of encoding, right? We even see right here that it tells us to get this particular encoder. And if we pay attention, we even see what type it is, right? So this should be familiar to us. As a matter of fact, without even what I've highlighted, just by looking at this, we should be able to tell what type of encoding this is, right? So we see that there's capital letters, there's lowercase letters, there's numbers, right? And then of course, the main thing that can give this away is that at the very end, we're having these equal signs to pad it, right? So this is base 64. So here we're trying to be able to go ahead and run this in Python. And it's telling us to go ahead and do all of this. Let's see. Let me try. Let's go ahead and copy this. And then I'm going to go ahead and say, let's say Python 3. And then I'm going to try and be able to run this. And let's see if that works. I might have to put this into a script. As a matter of fact, let's go ahead and try running that command again up here. Let's try and be able to go ahead and do an -O. Let's see if we can be able to just save it to an output to begin with. So Antonino says, question, why didn't it automatically run the payload? Excellent question, Antonino. So we're going to see that there is a difference between being able to go ahead and run things with MSF Venom and trying to be able to do things like run things in Metasploit, right? So when it comes to MSF Venom, its main goal is to generate the payload, right? Generate the file. It's not meant to necessarily run it, right? Because sometimes when the file we create isn't going to be, let me go ahead and call out to this thing and then connect back, it's going to be actually to wreck things, right? So you're not going to want it to generate that virus or that Trojan and then run it and automatically start wrecking things, right? It's meant to generate the payload, not necessarily to then automatically run it right afterwards, right? So let's see. Let's go ahead. Let's try going output. So I'm going to go -O. And let's say sample payload. Let's see if it's able to go ahead and save it to that. And then if we're able to go ahead and kind of run it from there. Excellent. So Justin does go ahead and point out to us in the chat that when we're running something like MSF console, this is our Metasploit framework, and that is to be able to go ahead and then be able to run them. So again, there's that main difference between Metasploit itself and then something like MSF Venom, right? So this is meant to generate the files we're going to be using, not necessarily generate and run it right afterwards, right? So let's see. I went ahead and I told it with our -O to go ahead and create a file with our thing called sample payload. So it should be saved right here. As a matter of fact, let's go ahead and cat it. So we see that it has that code there now. So we see right here, this was still listening. So we still haven't made that connection, right? So let's see let's go ahead and modify this just a little bit. I'm going to go ahead and, if you recall, to be able to go ahead and write a script that can be ran very nice and easy, right? We can be able to go ahead and do something like our shebang, right? So I could be able to go ahead and say user, I believe it's user bin, and then Python 3. And that way then it'll recognize that this is a Python command and try to be able to run it through that interpreter. And then if we do another ls, we'll notice here, this is still just a regular text file. We see that because of its color. We can also be able to go ahead and do an ls-l, if you recall, a long listing, to be able to see right here that there are no executable permissions for this file, right? So we can be able to go ahead and chmod this. If you recall, we can go +X to be able to go ahead and give it executable permissions and then specify which file is that we want to be able to do that to. So now if I do a ls, we see that this is now executable. So let's see if it'll go ahead and run our stuff. So we said, let's go ahead and run the sample payload. You see right here, that connection has been made, right? So again, we have this connection to us, from us. It even tells us what port is using to make that connection to us. And this was supposed to make an interactive shell. So whereas before, the one we had in our LMS, right? It was able to go ahead and connect, but it didn't really do much, right? Here, we're seeing that it was able to connect and if I do an ls or something else, it should be able to go ahead and be able to connect over here and kind of work with it, right? So let's see. We can get more advanced than that from here, right? So again, what did we do kind of right here? We'll let that run, see if it works. But let's see, if I create a new tab, so we can be able to let those things run in the background and kind of take a look at what we did, right? So we went ahead and created this sample file, right? Here, this is our Python thing to go ahead and do an execution of some command. So exec is a way to be able to run essentially operating systems, terminal or command line instructions. And then we're also then going to import our base 64, right? We're going to import some codecs. We're going to go ahead and then get the following encoding scheme. And then we're saying get all of this. And this is encoded. This is what we wanted to do, right? To be able to go ahead and create that reverse shell. Where is it connecting to? What port is it connecting to? All that information, but it has been encoded in base 64, right? And then it's going ahead and running it through this encoding, running it through our base 64 decoding scheme to then be able to try and execute this command. So he's already starting to see some of that obfuscation that we were talking about, right? Just by looking at this, unless we're able to break down that base 64, right? Which we may not think to do at first, it doesn't look malicious necessarily, right? But let's see, if we were to go ahead and copy this, let's see if you remember one of the tools we showed you guys was CyberChef. So if we go to CyberChef and we paste this in there, let's see if I was able to copy it and if I can be able to go ahead and paste it into CyberChef for us. And then let's see, let's go ahead and get rid of everything here and everything here. And we're going to go from base 64. We see this is everything that it had right there. So this is what it kind of went ahead and put into base 64, right? So we see then it's running through all of these instructions in Python. Specifically, we see right here, this is how it's setting up our communications over the network, right? It's creating a socket, which is our base of all network communications. If you remember when we went over our network stuff, right? And then here's where it's telling us where to connect. So when we built this using MSF Venom, right? We said, hey, connect to this IP address. We use this port, right? And so it's going to go ahead and try to do that. And then if it has a problem, then it'll go ahead and just sleep for a little bit before it tries again, right? And then we see right here, it's going to go ahead and try to receive information and send information. And then it's going to go ahead and do this execution of this. So that's what's happening in this base 64 stuff, right? So let's see. Again, how were we able to do this? We went to MSF Venom, right? We could be able to go ahead and list out our payloads. We looked, so we did a grep for what platform we were trying to use. So we went ahead and said, let's grep for Python. Once we saw one that we wanted to use, right? We then said, okay, let's establish that payload. So we were able to go -P for the payload. And then we were able to specify what we wanted, right? So I believe it was Python. And then let's see. Taking a quick look back at that, it was a interpreter shell. And then we wanted to be a reverse TCP, I believe it was. Yes. So again, we would have found this from doing our listing, right? Then we specified who is it going to call? So who is the listening host? And we said that was going to be us. We then specified what port it was listening on, right? And so we said that was going to be 4444. And then ultimately what we did in the end to make this a little bit easier for us to be able to run is we saved this to a sample file, right? So we said sample payload. And then all we had to do was modify that to run it, or rather than doing it that way, right? I could have, instead of having to run it like this, we could have just said something like Python and then the file name, and it would have ran it with Python, right? But what we did was to be able to make it a little bit more interactive. So that's going to create that file for us. It's creating the payload. And then when we need to, we can execute or run that payload to be able to go ahead and get it to do what we want, right? What we were trying to specify. So we see then right here, let's go ahead and go to our exercise. So here we say we're going to open up a terminal on our Kali system. You're going to create a netcat listener similar to what we did, right? That's going to listen to port 7890. Again, on our Kali system, we're going to have this listener, right? We're going to open up another terminal or a tab like I was doing, right? And you're going to try to be able to see if you can get a bash reverse shell. So you're going to list out your different payloads, look for one that's going to be a Linux or something similar, right? That's going to have a bash reverse shell that can then connect to your Kali system. So we're going to do a similar thing, right? We're going to have it go for the L host. That's going to be 127.0.0.1, right? And then specify this as our port, right? 7890. And then we're going to execute that resulting bash shell payload and then verify that it does indeed connect to our listener, right? And then we're going to go ahead and run shell commands to see if we're able to get it so it's interactive and working, right? Now, as Justin has pointed out in the chat, he says you can always run your netstat-a command to see connections. This can also help to verify that a connection was indeed established and that you have something communicating with your device, right? Any questions so far on how we can list out our payloads, how we can search for our payloads, and then how we can specify how it dials out? Who is it going to be calling? What port is it calling on to be able to go ahead and establish a connection? All right, then in that case, we're going to go ahead and set up the breakout rooms. So that way you guys can be able to go ahead and work on this first activity. As always, if you guys are having difficulties or if you guys are getting stuck, if you're hitting a wall, and we have the poll should be available for you guys to be able to go ahead and fill out. We're going to go ahead and give you a little bit of time to be able to go ahead and respond to that. I do realize that there were a few errors that were happening with this exercise more recently. So let's go ahead and take a look at that. So let me share my screen. So one of the things that was an error was this right here. I think that they were going ahead and with this part, that is an escape character that they were doing. And I do believe we do not need that, right? So if we come over here, we'll see that when we went ahead and follow the commands, it tells us to set the payload to be this right here. So we are using the exploit. The exploit is what's going to actually then be able to use the payload, right? We saw what the payloads could be when we were doing MSF Venom. So here, let's say we search payload, and then what are we going to be searching for? Let's go ahead and do Meterpreter, right? So we're going to search for all the ones that say Meterpreter. And so we see again that these are all payloads, right? Specifically, we see that what we were looking for was x64/Meterpreter/reverse TCP, right? So we see this is close, right? But it doesn't have that slash after Meterpreter. Instead, it has the underscore. So we're going to go ahead and scroll up a little bit. And let's see. Let's see if we're able to find it up here. So here we go. We see that these are going with payload. So these are payloads. These are the Windows payloads. Here it is Meterpreter all on its own. And then we see that slash. And then we're going to go ahead and look for one that's a reverse TCP. So that's this one right here. So they wanted us to go ahead and use this payload. Notice it doesn't have that /, right? Or that slash that was happening right here before this underscore. So I believe that that is an error. So we're going to go ahead and set the payload to be that, but we're going to leave off this slash right here. Once we do that, we do see that if we go ahead and take a look at the info, right? So once we have this particular module open, notice it says here are the basic options. The only two that are required is what port are we setting it to and what our host, so who's our target, right? So we were able to get this from Windows, right? Just like we saw when we were doing the Samba server scan when we were using the auxiliary module. We see right here, we're going to keep it with the default port. And then the rest are no longer required, right? We don't have to provide them, but we can if we want to be able to get more access. So it told us to set the SMB domain, right, to what we would find on our Windows machine. So it happens to be the name that we see there, right? So EC2 amaze L300UG8. So we set that to there. It tells us that it should be that the password is Academy. And then the user, it should be administrator, right? So we can be able to go ahead and say set SMB user to be administrator. And then once we have it, we're supposed to run. But here's where the second error comes into place. So we'll notice that it tries to connect, and then it tells us that it's authenticating, and it tells us it's trying to log in as administrator, but that it fails, right? Why? The login is invalid, and it tells us that's either due to a bad username or the authentication information, which means the password, right? So if we go over here, and let's go ahead and minimize this. If I were to try and log out, right? So if I go here and I sign out, we're able to see what account settings there are, right? So if I go here on the top right, we've pointed this out before, we can be able to go ahead and send over a Control-Alt-Delete to the computer this way. And we see there is FStack, there is administrator, and there is administrator 2. Now by clicking on administrator, if we have the right login and username, I should be able to go ahead and type in Academy and log in, but you'll notice it says the password is incorrect. So I believe that's the second mistake here. For whatever reason, the administrator account does not have the password of Academy like they're trying to have us use, right? And so that's why it's failing when we try to be able to run that exploit, because it's trying to log in and the password is incorrect, right? I'm going to try and see if I can figure out what the password is, so that way we can be able to go ahead and be able to see that done more effectively moving forward. But the only other thing we can do is coming back to FStack, right? We can be able to go ahead and log back into FStack. And then at this point, it would be to use FStack, which if we take a look at that, we can be able to run things as system administrator, right? So we could go, for example, to PowerShell, right click that, run as administrator, and then we can try to see, can we be able to go ahead and change the username, right? So here, the object would be trying to be able to go ahead and change the password for the administrator account to Academy or to something that we can be able to know. So that way, then we can be able to set the proper password here and then run it. Other than that, if you were following the instructions, it should be able to work just fine. The only issue was the fact that it's trying to log in to this account for administrator and failing. Now, if you try to be able to go ahead and say, well, we don't know what the password that's correct for administrator is, let's go ahead and try for FStack. We know what that is. So if we were to go SMB user and set this back to FStack, let's say, and then try to run that, you'll notice that it passes authentication, right? So right here, it says, hey, we're trying to log on to that domain with FStack, and it's able to get to that server, logs into that, works with FStack. But what fails is that it doesn't have access, right? Here it says access denied. So we need that administrator access, right? We need that administrator account because FStack doesn't have enough privileges. So it's not able to go ahead and actually do it. So that's why we kind of are failing there. But other than that, if you're able to get to this part, right, if you're able to go ahead and follow these instructions, then it should work very fine, right? We should at that point see that we get this command right here where it says interpreter session 1 opened. And then at that point, we can start issuing commands, right? So it tells us once we get that session opened, we could type in sysinfo, and it should go ahead and give us information about the Windows computer. And then we can type in help to see what commands we can type in to be able to work on that Windows computer, right? So at that point, once we have the correct password and we follow these instructions, it should be able to go ahead and work just fine. Give us that reverse shell, give us access to the computer. So I'll find out what that password is so that way we can be able to see that hopefully before the end of tonight, right? One last thing we have then is this last activity, right? Meterpreter itself. So we say Meterpreter can be thought of as a reverse shell with advanced penetration testing capabilities. Several Metasploit modules, therefore, result in either just a regular reverse shell or this type of interpreter shell. So it's advisable to get comfortable with using them. A interpreter shell provides shell access to the compromised system and post modules that Metasploit provides. You can search the various post modules that can be used with interpreter sessions using the following commands, depending on whether you have a interpreter shell on Windows or Linux, right? So you can say search post/Windows to look for Windows machines, or search post/Linux to look on Linux machines. Now we say, we want you to examine some of those post modules to observe what they can perform. Interpreter sessions provide a lot of functionality. You can drop down into a system shell, either something like cmd.exe for Windows or sh for basic shell in Linux, depending on what operating system our target machine is running. You can migrate the interpreter to another running process. For example, you can migrate it to notepad.exe so that the interpreter lives in a notepad instead of being in its own standalone process. That means when somebody suspects that maybe they've been compromised and they do PS like on Linux to be able to see what processes are running, they'll see that service rather than seeing the interpreter shell, right? So it'll look like it's a legitimate thing that's possibly running. You can even send traffic from your Kali system through a interpreter session in case you have a custom tool in your system that you need to run on the compromised internal network. There's no shortage of actions you can perform if you get a interpreter session. So we say right here, we're going to use the following two tabs to look at how we can do activity 6C, right? So we're going to take a look at how we can establish an interpreter session. We're going to try and see if we can be able to get one up on the Windows system. And then we're going to migrate the interpreter process to another one that's running on Windows, and then try to run a key logger to monitor some keystrokes, right? So let's see if we can be able to go ahead and get that to happen. So let's see. Let's see if we are able to go ahead and change that password. So if you recall, let's go over here. Let's actually check Windows 2 real quick. Let's see what's happening there. And while that's up and loading, let's go ahead and let's see if it works. So yeah, so it didn't take it there either. Let's see, if we're gonna go ahead and sign out on Windows 2. Let's see if this one has it for administrator 2 with that password. Nope. All right, so let's go over here. All right, so Alex says he was able to find a way. He says, let's go to computer management, go to local users and groups. So let's try that. So we're gonna go right here. We're gonna type in computer management right into the search bar. Then he says right here in local users and groups. We're gonna go here to user. We're gonna go ahead and click here on administrator. And then he says we can then change the password from here. So let's see if we can be able to go ahead and do that. Let's see. He says right click on administrator. Excellent. Let's set the password. Let's proceed. Let's go ahead and set this to Academy, just like our LMS was saying. Let's hit OK. It tells us that the password has been set. Let's see if that is recognized. Let's go ahead and sign out and try to sign into the administrator. So we're going to click on the administrator account. Let's try it with a new password. Excellent. So thank you, Alex. He was able to go ahead and tell us how we can be able to go ahead and change that password. We see we were able to go ahead and log in now with that username and password. So let's go over here. Let's go ahead and change that user back to administrator. And if we go ahead and check info, we see that we kept the password with Academy, which we now have switched over. So it actually is Academy, right? We have our user as administrator. We're telling it where to log into. So let's go ahead and run and let's see if it does it. Excellent. So now it did make it past the authentication, right? So we have authenticated. Now that it has the correct username and password, we're in, right? It tells us that it's selecting PowerShell for the target. It's executing that payload that we told it to run. And we see right here, Meterpreter session 1 opened. So excellent. We now have our Meterpreter session. If I were to go ahead and say something like, who am I? It tells us that is an unknown command. Let's try and be able to go ahead and do dir. And we see that it lists out, because this is a Windows machine, right? So dir should work. And it lists out the stuff in the current directory that it is in, right? Let's go ahead, let's do pwd. Let's see if it recognizes print working directory. It tells us we are on the C drive of our Windows machine inside System32. Give me 1 second. I apologize. All right. So we're inside of the System32 directory. We could be able to go ahead and say, let's switch over to the C drive. And now if I go print working directory, let's see. It says can't find the file specified. Maybe I went the wrong way. Let's go ahead and let's try it just like that. All right, let's go ahead and do print working directory. Let's try and let's say users. All right, so we're able to go ahead and see, at least then we're able to get inside to our machine here. Let's see, let's go to this PC. Let's go to the C drive. Let's see if I want to go to users, let's say administrator. This is what I'm going to try and be able to go to. So I want to be able to go C drives and then users administrator like that. Let's see if we can be able to get it to do that. All right, so it is giving you some issues here with being able to go ahead and do this. Let's see, does it recognize ls as a command? Okay, so it does recognize ls as a command because again, while it's Windows, so it was able to recognize our dir, ls is also in PowerShell recognized, right? Let's see if that worked. Okay, so cd.dot is able to go ahead and move us up. So we're able to go ahead and see that we have now moved into the C drive right here. Let's go ahead and try moving into users. So we were able to move into there. Let's go ahead and move into administrator. And so here's administrator stuff, right? So we're able to go ahead and see their music directory, their My Documents directory, and so on and so forth. So we are able to go ahead and move into there. We were able to go ahead and see this. So we see that we have the shell, we are on their machine. We do have sort of this control over it somewhat. And so what are we going to do next? Let's go ahead and let's see if we can be able to move our process rather than looking like a Meterpreter shell. If we can be able to go ahead and run it as Notepad, right? We get it to look like Notepad. So let's see, let's go ahead. Let's do this PS. And let's see if we can find Notepad on here. So we see that, for example, there's already Explorer exe, there's Runtime Broker exe, and so on and so forth. Let's see, can we go? Let's see if it recognizes grep. It may not because it's a Windows machine, but let's see if we can go ahead and get that. Now let's say Notepad. All right, so it does say that no matching processes were found. Let's see, can I be able to say start notepad.exe? Or let's actually just look for, instead of just Notepad, see if it has notepad.exe. All right, so it says that I wasn't able to go ahead and find that. Let's go ahead and scroll up just a little bit. So we do see that right here, we have SMSS, CSRSS, and so on and so forth. So looking through this one by one, it does look like it does not have Notepad running just yet. Let's see. Let's actually go ahead and start it up over here, just so we can kind of see this. So I have Notepad now running up over there. Let's go ahead and try running it again. So now we do see that it is here. So we started up over there. We see that there is a Notepad process now running right here. We're going to see right here, our process ID looks to be 924. So what can we do with this? Well, now that we have this, we can tell the interpreter shell to be able to go ahead and switch over into that process ID, right? So we use this with the command migrate. And so once we type in migrate, we're going to then provide it the process ID that we want to switch on over to, right? So let's go ahead, let's try that. I'm going to type in migrate, and then 924. So you see then we're migrating from our process ID, right, to 924. This is migration completed successfully. So at this point, if we were to go ahead and do PS again, we should be able to go ahead and if we look through this, so if we go ahead and scroll up just a little bit, we should see that there is this notepad, but we shouldn't be able to go ahead and see what we were doing before, right? So for example, let's see. We said ours was 1568. So let's go ahead and scroll up and take a look at that. So you see this right here. Looks like we were having that, right? So we were able to go ahead and switch on over. And do we have that happening over here anymore? We'll notice that if we look through these numbers, there is no longer a 1568, right? So it's no longer looking like we have that process there anymore. Instead, we've kind of hidden ourselves into here, right? Inside of Notepad. And we see right here how it kind of just looks like it's legitimate, right? So again, how did we do that? We just typed in the command, right? PS to see what was our Notepad process. So we'd have to start it up first, right, to get that there. And then find out what is the process ID for that. And then after that, we typed in migrate and then the process ID number. So whatever number we give it, it's trying to migrate on over to that process and then make it kind of be hidden inside of there, right? So we've gone ahead and we've switched over. We've hidden our process as Notepad. And then we're going to go ahead and type in our next command. So let's see. I believe it's keyscan underscore start. So let me go ahead and clear this. So that right there, keyscan underscore start, this is our keylogger, right? Remember, we wanted to be able to go ahead and set up our interpreter shell and then be able to go ahead and do key logging. So that's what we did right here, keyscan underscore start. You'll notice right here it says starting and then our keystroke sniffer. So now if I go over here and I'm going to type in a bunch of things, right? And then we come over here and what are we going to do? We're going to say keyscan underscore dump. And we see exactly what I typed, right? We see I have the word and we even see when I do some shift presses, right? To be able to go ahead and get the capitals upper, so we get uppercase and lowercase. So, and I'm going to type in a bunch of things. And then we see the carriage return from when I hit enter. So we see how we can start that keylogger, and then how can I get that information back when I ask for it, right? So we're able to go ahead and do that with keyscan underscore start, keyscan underscore dump. And when I'm done, if I no longer want to be able to run this, I can say keyscan underscore stop, and I'll go ahead and stop that keylogger. All right, so let's go back to our LMS. Let's click on our exercise, and we're going to see that this is essentially what we're going to be doing here, right? So we're going to see we're going to want you to establish an interpreter session, kind of like what we did, right? Well, now that we know how to be able to set up the correct password, right? Again, how did we do that? We went over here and we looked at computer management, right? So we typed in computer management. We went to the local users and groups. We went into our users. We right-clicked on administrator and set the password, right? So that way we could be able to change it to the password and username that they had given us. And then we were able to follow the command stuff for activity 6B to set up the interpreter session, right? So once we have that interpreter session, inside of there, they tell you, hey, run an LS, a PWD, and a PS to kind of see the different stuff on Windows, right? Drop into the system using the shell command with interpreter. And then within the system shell, do the following, right? Find the current user of that shell, list the current directory, list out any environmental variables, and then exit by typing exit. Then it says enumerate the running Windows services, type background to send this to the interpreter background. Search the following services, right? For that post module, and then use it. Change the session option to the session number that we noted back here when we typed in the background, right? Execute that module and then migrate the interpreter session to run within Notepad, kind of how we demonstrated, right? Bring the interpreter session back to the foreground by typing in the following commands, right? And then switch to the Windows VM, open up Notepad. Within the interpreter session, type PS to figure out what is that Notepad process ID, right? This is again under the PID column instead of PPID. We saw there was 2 columns there. And then type migrate like we just demonstrated with that number, right? And then finally, let's close the notepad.exe process and see if the interpreter shell is still operational. So very similar to what we kind of demonstrated right now. We may not have enough time to be able to go ahead and do this right now. So we're going to say, go ahead and work on activity 6C on your own between now and Wednesday. And then if you have any questions or if there's any problems that you experience with that, we'll address that Wednesday at the beginning of class. So we're getting down to the last few of this. So let me go ahead and stop it there. And are there any questions so far with what we've been doing? Are there any questions that you guys have, any concerns, any comments, anything you guys want to be able to go over? All right, then in that case, let's actually go ahead and I'll say, Justin, let's open up the breakout rooms. Let's go ahead and have it just for about, let's say, 8 minutes. So that way you guys can go ahead and practice this. Now that you guys have been able to go ahead and follow along and you guys are able to see how we can get the password to the information that they gave us, you guys should at least be able to get their interpreter session up and running and kind of mess around with it a little. So let's go ahead and have you guys jump into the breakout rooms, work with that, and we'll see you guys a few minutes before we end for class. So have fun. So for those of you that are already here, you're going to want to be able to go ahead and, if you're able to, if you're safe, if you're not driving, turn on your cameras so that way we can be able to see you guys can be able to see each other, especially when you go into the breakout room so that you guys make it a little easier to be able to work with each other, right? And we're going to be going over career prep. So you guys should be familiar with this by now, right? It's going to be interview questions geared towards the last unit we just went over, right? So stuff dealing with our red teaming. And so in a little bit, Justin will be going ahead and taking over and being able to go ahead and get you prepared for that and get you going. And we're going to go ahead. In the meantime, point out that the career simulation that you guys have turned in from the last time, right, which was our computer systems, right, the system administration type stuff, all dealing with our domain information, that's been graded and you should be able to access and be able to see what that is. If you guys did well, congratulations, right? If you guys didn't do so well, then that's not the end of it, right? As a matter of fact, what we want you to do is look at the feedback, right? Feedback was provided for pretty much everyone, unless you did really outstanding, right? So look at the feedback and then try to be able to go ahead and see what you can do to be able to improve what you originally submitted, right? At the same time, we're going to go ahead and point out that if you have any questions, if there's anything you want to go over, if there's anything related to that as well, reach out to Justin or myself so that we can be able to go ahead and take a look at that with you. And we can be able to go ahead and try and be able to address that, any concerns, any questions you guys have, anything whatsoever. So that way we can be able to kind of bring you up to speed and then help you in being able to go ahead and redo it, fix whatever mistakes you had, or if there was parts that were incomplete, help guide you to be able to go ahead and complete that, and then resubmit it so that we guys can be able to go ahead and get a better score. Because the whole point is not to just say, hey, you didn't do so well. Oh, well, let's move on, right? The whole point is to be able to help you guys to learn this stuff. So if you guys have some issues with what you submitted, right? If you got bad feedback, if you didn't do so well, then definitely reach out, talk to us so that we can be able to go ahead and be able to help you fix that and resubmit it. That way you can learn it, right? With that, it is 5:33. We're almost to 15 people. So let's go ahead, let's get started. And I'm going to go ahead and pass it over to Justin so that you can be able to go ahead and get us going with our career prep for today.
Thanks, Tony. See, we got something in the chat here already. I'll let Tony answer that for anything on reworking the assignments.
So for that, with the working the assignments, if you go to where you submitted it, right, you should be able to go ahead and see that there is a score and then there is a feedback, right? And essentially the score is, was it passing or did it not pass, right? Was it something that was good enough that we thought it was, hey, this is good. It may not have been perfect. So if you look at the feedback, you'll still have some feedback, right? But it was good enough that, yeah, this is passable. This is something that if we were to go ahead and have it as an actual document, most everyone should be able to go ahead and use it and be able to get by and be able to complete the tasks that we were having you guys work on, right? Now, there might be some snags, there might be some stuff where people might get confused, but by and large, if you pass, then that means that the document you created, it works, right? But if you have to rework it and resubmit it, then you would have gotten a failing grade on the assignment. So if you go and you look at where you turned it in and you see that it says failing, that's where we want you to rework it and resubmit it. If it says passing, you're good, right? Now you could, of course, if you still want to be able to rework it, retool it, address the areas for feedback that we gave you and resubmit it, you can. But as far as this boot camp is going to go, it's not going to improve your grade or anything like that, right? All it will do is just go ahead and kind of help you for your own benefit if you want to be able to go and address those concerns, right? Any other questions? Let's see, Pam says who passed. If I go and list everybody that passed, that'll kind of out everybody that didn't pass, right? So I don't want to have to do that to everybody. Instead, just again, if you go and you log into where you turned it in, you should be able to see right there whether it says passed or failed, right? Or I would say that there are some individuals that may already know based on what they submitted that maybe they didn't submit everything that they needed, right? Or there's parts missing. Maybe they skipped over a few of the steps that they were supposed to deal with, right? Then in that case, chances are you probably didn't pass it, right? Cam says, are we talking about the pen test problem or the run book? This one that we're talking about right now is for the run book, right? The pen test problem, that's not going to be until later because that's the end of red team, right? So today we're going to be focusing on career prep for the rest of our class. And that's going to be our interview questions, kind of familiarizing ourselves with what people might ask during an interview with the topics that we've learned in red team. And then tomorrow we'll go ahead and kind of have you guys get started on the pen test problem, right? So that's not until tomorrow. That's going to be how we're going to close and wrap up our red team. Any other excellent questions? All right.
Great. All right. So now this shouldn't be new. We already went through one iteration of some career prep. So this is just building upon what we did the last time. So you've learned more, you've had more experience in a few more areas within cybersecurity. Now you get to reformulate some better questions, some more in-depth questions, some more technical questions. And when you formulate those questions, you get the answers to, right? And when career prep, you always want to go into any interview with trying to anticipate what that either what the manager that's trying to hire, what that hiring manager or even what the possible company is going to ask you. You just kind of like prepare yourself, like, okay, this is probably those types of questions that they may ask me. So let me jot some stuff down. Let me ask myself some questions, and then let me make sure that it's kind of fluid coming, and my responses coming out of my mouth. Like, let's make sure it's pretty fluid. Now, it's not unheard of for you to write down some questions, have some notes with you, go in with a notebook, have some stuff written down. Interviews may be done virtually. I've probably gone through almost all of my interviews for my current job were all done virtually. They would ask questions, and if there was something I was like kind of thinking about too hard, they'd be like, it's okay, we can go back to it. But I would write down that question so that during the interview process, if there's a little gap in time in discussions or just like free flowing discussion, that I could then, look up maybe the answer to that question. Maybe it jogged my memory a little bit and further down the interview that, oh, it just popped in. That's what they actually wanted. So as we go through this portion of the career prep, we're going to keep demonstrating our skills of the knowledge that you've gained so far through this boot camp, and maybe some of that research that you've done outside of class to help you better prepare yourself for those anticipated questions. So just like before, we're going to break you up into some small groups. We have some sample questions right here, but we also want you to come up with maybe one or two additional questions that you may want to put down on your sheet. You and your partner or your group, I think will be split up in either 2 to 3 person groups. You may have a separate question you may want to ask, right? So you may want to ask the person you're interviewing that question. It's not so much that question you need for you to ask, for you to answer yourself. You might want to, just so you have something written down on your notebook. But think of another question outside of these that you may want to ask that interviewer. Keep that mindset of like, you're the boss, you're trying to interview, or you may be a hiring manager. You're looking to get and vet somebody for a certain position. So make another question up that they kind of like an icebreaker. Sometimes it's something very easy to like soothe the vibes going into that interview, so you're not like so tense, because some of these interviews can be really tense, especially when you get out of one interview, you feel like you did really bad, you're jumping into another interview and you're just like, man, I don't know how it's going to go. So remember, as you're interviewing your interviewee, do some of those icebreakers. Make sure they feel calm, make sure they feel okay, and make sure you and them are both comfortable, because that's how these interviews should be, like free flowing, right? It shouldn't be real like stuck up the whole time. You should be really free flowing with it, very comfortable. You should know your information, and the more information you know and the more comfortable you are with preparing yourself, the better you will be on getting through the interview. So I'll give you a real world example. My current job that I just picked up, I had got through over 8.5 hours of interviews over 2 days. And I was just burnt out. I was the same questions over and over again. And finally, when I got to this interview, I was just so chilled and relaxed. I was just like, you know what, if it's going to happen, it's going to happen. And just went through the whole thing and ended up working out for me. So maybe I was just burnt out. Maybe I was just used to hearing the same questions over and over again. But this last one actually panned out for me. So the questions you're going to ask, you and your team, interviewer is going to ask your interviewee, what's the difference between a red team and pen testing? So we went over that a few times. What are some tools you can use for passive reconnaissance and active reconnaissance? We spent a good amount of time on these. What is more dangerous, LFI or RFI? You remember that block? If you haven't, you're gonna have some time to research it. What are you you are currently on a pen test company. What are the different phases you would undergo to perform this penetration assessment? So like, what are the steps? How would you start? What do you do in the meantime? How do you end it? We went over all these steps as well. And then walk us up the cyber kill chain. Like, tell us how it works. You know, start from either a point inside that cyber kill chain or start at the bottom and tell us how it escalates. And when you're writing these things, what are some of the most important things to keep in mind when drafting a pen test report? So you can break this up into both of these of, here's some questions for you. And then after you get done this one right here, you can roll right into this one. You know, when they end that penetration assessment, you can then say, okay, well, what's the most important things within that report? What should I know? If I've never looked at a report for, what should I know? And then we've got, so we're going to break you up into groups here, and then we're going to go into the interview as well. So what I want right now is we're going to break you up into groups for about 30 minutes. We're going to go through these questions. And like I said before, make up, develop a question that may not be within this context right here that you can ask during that interview. Everyone should have like something different. So it just kind of like keeps expanding that memory, because you're going to know these, but you may want to get that one that there's going to be a far left field question out there. Let's see, which one did I have? It was on a C2 beacon, when it gets deployed, what is the port number? And I was like, I have no idea what the heck that is. I believe it was port 8585. See, I completely forgot, but I'll look it up because now I just jogged my memory again. But you'll get a question like that. You know, somebody would come in there and be like, oh, what's port 443? Oh, what's port 80? You'd be like, oh, I know those. And they'd be like, what's port quad 4? You're like, I don't know. Like, that's what we use for like Mimikatz and, you know, creating payloads and stuff like that. I mean, so you may get somebody that's interviewing you that like just wants to show their stuff. And yeah, so don't let that stump you. Just be like, I don't know that. I'll let you know. I've worked with that and I'll give it right back to you. Any questions? All right, so it's a minute 45. We're going to give you till we'll give you the top of the hour. That's 15 minutes. So we'll give you a minute 15 to knock out these questions, and then we're going to come back or make sure everyone's good to go, and then we'll break you back out into the interview portion. We're going to split you back up into different teams than you are right now for the interview portion. Sound good? All right. Tony, if the rooms are open, let's go ahead and launch them. How's everyone feeling from those grilled questions that you were giving each other for those interviews? Are you feeling more comfortable now than you did before? Got some thumbs up, head nods.
What about having you and Tony role play?
That'd be fun.
So we could
But, you
sit
know, if
back
he
and
brings
watch
up
you
any
guys
kind
go
of-
at it.
If he brings up any kind of coding or anything like that, I'm done.
Oh, make sure you put that on there, Tony.
I would say thank you. This interview, I appreciate your time, but this isn't the job for me. I had an interview with a company. I was really looking forward to this company because it's 100% remote, really decent pay, and the company finally came through. I had already picked up this job that I'm at now, and this is a hybrid job, so I'm only in the office 1 day a week. So I finally get the interview with this other company. Wife was like, "Why are you going to do that?" I'm like, "Well, I'm going to see what this one's going to offer me compared to the other one." So I interview with the guy. Guy really seems like he liked me, and he gives me this this kind of like project to do, and it was a file. I'm like, I don't even know what the heck this file is. You know, it's probably like malware. He's probably like reverse, TCP and right in my computer. I'm like, ah. So I loaded this into offline VM. And I started diving through it, and it was just a bunch of logs. I'm like, this is really interesting. So I'm diving through these logs, and he wanted me to explain what was going on in these logs and give him like a little analysis. And so I'm like looking through these logs. I don't have it on this MacBook. Maybe I'll try to, I'm not supposed to, maybe I'll try to pull it over and see if I can show you what it is. But parsing through these logs, didn't know what it was, a weird file type, couldn't even read them. So I figured out you had to change it to like a certain file type for you to be able to read it. So I'm reading through these logs. I'm like, this is just something just talking back and forth between each other. Took a couple days, took like a week or so to actually finish going through everything, and finally responded back to the company. And they never responded back to me. I couldn't figure out why. Like, they never gave me a time frame to respond back. They never gave me, hey, look at this today and give it back to me tomorrow. But I sent this big long email to them. Glad I'm not working for the company, because if that's how they are, I wouldn't want to do it. But going back to what the logs were showing, they were showing OCSP, I think is what it's called. And what that's doing is it's servers just reaching out saying, "Hello, are you there?" And it responds back with, "Yeah, I'm here, I'm still alive." And it would go to another one, "Hello, are you there?" "Yes, I'm alive." And it comes back. And it was one server reaching out to, like, kind of like what a DNS server does, like making sure something's alive and comes back, making sure. And it was going, looking at the time frame, was going like every 30 minutes, every couple hours a day. So it was just pinging stuff, but it wasn't using a ping command. It was just like you could see the text in it saying hello. It was just making an acknowledgement and kicking it back. So I did that little analysis, and that seems like that's what that company was doing. It would have been super boring for me. Like, I couldn't do that. Like, I'm glad I got a taste of it before I actually took the job, because if that's what it was, I would be balder than I am now. I just wouldn't have done it. Like, but I know in some, let's say more on coding side, software development, and there's been interviews that have happened where somebody would say, "Hey, like, here's my problem. How would you fix it?" And they would give you the actual problem, and you would tell them how to fix it, and you would never hear back from them. So my suggestion, and I would hate for that never to happen, but my suggestion to everybody, if anybody ever comes to you with a problem, give them a hypothetical way you would solve it, and don't solve their issues for them. Because sometimes people just want free, if you're really good, they just want a free answer. And they may try to go through the hiring process just to get you to talk to them, and then they bounce you. Heard it happen to two kind of colleagues, not friends, but two colleagues, that they were interviewing for a software development job, and both times they're like, "Look at all this code, tell me what's wrong with it and fix it." And he fixed their problems for them. But go ahead, Ryan, I see your hand up.
So I was just curious, if when you were applying for, I mean, for this job and maybe your, previous one or ones, maybe this can maybe go to Tony as well, as like when you guys applied, did you guys try to apply in like the area that you live in, like say LA, Los Angeles? Do you apply in like California or Los Angeles specifically, or did you just broad blast out, the demographic across the whole US?
LinkedIn was really good for me. LinkedIn Premium. And then I just looked at remote jobs. So it doesn't matter where it was, didn't matter what time zone it was in. I was looking at all full remote jobs just to get my my resume out there.
Okay.
And it seemed like when you get your resume out there, it starts spiraling. And then if you find a job that your resume doesn't fit, you always want to tailor your resume to that job.
Okay.
Yes, sometimes like a plain resume with a bunch of stuff on it may be attractive, but if you want these, LinkedIn does it really well where it will scan your resume. If you don't have the keywords in there, then it will just kick it out. It won't even push you through the process. So read that job posting, look at the keywords in there, see if you can add some like girth to the bottom of the resume or somewhere in there that will touch on those points. Like it says Python scripting, attended the cybersecurity boot camp with 3 weeks of Python, and touched on, and then you can put some other words in there like C+ and bash scripting and all this other stuff. Some of those keywords will actually pop your resume up.
Okay.
Yeah, so just read the job listing and that posting, and then write your resume to that. If you have a good resume that beats around the bush, like look at something that can actually, you can add some more fidelity to it to make it even stand out even more.
And then when you said on LinkedIn, it's been very good to you. Now, is it LinkedIn where like recruiters or people are searching you out? Or
Yeah, it was both. It was both. I
Okay.
put in a lot of applications, and then also I got a lot of recruiters looking back out. Just adding either keywords, adding what do they call them? There's another section there. It's like resources or skills, adding all those skills to your previous jobs, right? Having those jobs in there, and you have like leadership, you have word processing, you have database management, adding all those skills in there will just show if somebody's looking for somebody that's got leadership experience and they know how to type on a keyboard,
Okay.
that's two of those skills that they're looking for. It might put you higher up on the list. There's some free tests that you can take on LinkedIn for like Python and all these other things, but I don't know. It's supposed to make you look more reputable because you actually have like your LinkedIn certification in Python and cybersecurity and whatever networking. But like somebody can easily flub that, and they can have ChatGPT on the side and ask all the questions. And if you get 100% right, they'll give you the badge. But you have to do it in a time frame. But if everyone's doing that, it makes everyone look the same. So I never
Right.
used any of those things. I got frustrated with the first two I did, and I said, I don't have time for this. So
Awesome. Thank you, Justin.
yeah. Tony, do you have anything else for your experiences?
From my experience, I went through the boot camp as well. I believe I mentioned this way near the beginning of our time together. So back in around the beginning of essentially what happened with COVID, right? In 2020, I went through the boot camp myself, and so it was actually on the West Coast here, also with Caltech, that they were doing the boot camp, and so when I first went ahead and got through everything, got all the information that you guys are getting and stuff like that, it was through firsthand experience, similar to what you guys are doing. And then when I saw that there was a job position opening up, I went ahead and applied for it. And to kind of answer what Ryan was asking of, did I specify, I wanted to be able to be West Coast, because that's what I had gone through as well. It was more that I knew that the entire company was kind of national, right? It could be anywhere on any like time zone. And so that's what I let them know. I said, hey, just give me a heads up beforehand on like when I would have to be available to see if it matched my schedule, but I'd be willing to do any time zone. So I didn't say, it had to only be on the West Coast or something like that. I was open to being able to go ahead and work any time zone as long as I was able to be free on the days they needed me. So that was the first thing I'd kind of let them know was that, hey, if you need me and I'm available, I'm willing to work. It doesn't matter what time zone it was. And then, of course, as Justin was pointing out, one big thing that they kind of let us know as well, anytime you're applying to a job, you might feel the need to, well, my skills are already there, my education is already listed, all this other stuff. And so you might just use one resume for a bunch of different jobs, right? But as Justin pointed out, you want to tailor make your resume, right? You want to be able to go ahead and kind of modify it, change it. Doesn't have to be by much, but you want to use, like you were saying, those keywords to be able to make sure that, hey, whatever lingo, whatever language the company is using to describe or to talk about different things that they're expecting, use those same keywords, right? Use that same type of language and modify just slightly your resume so that way it's targeted towards that, right? And that way, it does help you be able to go ahead and kind of get through the first few hurdles, especially because nowadays there are so many people that are applying to jobs. They actually use a type of like automatic filter, right? To be able to go ahead and say, hey, if they don't mention this, or if they don't have this type of education, we're not even going to bother looking at those resumes, right? So you want to be able to go ahead and look at what are the requirements, what language are they using, what things do they repeat over and over and over again when you're looking at that job description, right? And try and include those into your resume. And also, I've also heard cover letters, right? Most of us may not write a cover letter, but that could also make a big difference as well, right? Making sure that, hey, when you submit and you're turning in your stuff, go ahead and for a few brief like weeks or whatever that you're applying to a certain type of job position, tailor your LinkedIn profile, tailor your resume, have a cover letter, and all of those things can make a very big difference, right? And there's now, as Justin was pointing out, chat GPT, right? AI is a big thing that's happening. It's kind of like taking off right now. There are AI specifically that can help you kind of do that, right? To be able to go ahead and kind of, hey, here's the way that they're talking about the job position. So you supply that to it. It'll go ahead and kind of pick it apart and say, oh, then these are the keywords you should have in your resume. And it'll help you to kind of tailor your resume to that, right? Or to be able to go ahead and form a cover letter that'll discuss what skills and information you have that you mentioned in your resume that then ties into those skills and stuff that they're looking for that job. So you can be able to write a cover letter that's kind of tailor made for that as well. So at this point in age, it isn't overwhelmingly difficult to be able to go ahead and take some time to go ahead and kind of tailor it just a little bit so that way it's geared towards that specific position with that particular job. And then you're able to go ahead and have a higher percentage, right? Anything helps that's going to kind of get you past and get your foot in the door so that way they can actually have human eyes look at your resume and then be able to talk to you. Go ahead, Robbie.
I was just kind of curious. You mentioned some things, Justin, that are talking about things to avoid, maybe the interview process or things like that. But that kind of made me think of a question. Are there any positions out there for like entry level that you think we as people entering this field would learn the most from and that maybe we should gravitate towards? Yeah, whether that's a network operations center or like long term, what initial job would make us learn the most that would make us more successful throughout their career. I know everyone in this boot camp wants to get hired, but big picture, I think it's probably important to think about like the skills and the knowledge. And yeah, so any thoughts on that?
Yeah, so everyone's gonna be different, right? So some of you may be really strong in the coding side of it. Some of you may be strong in the research side of it. Some of you may be strong in, hey, you went through the pen testing side and you really like Mimikatz and building payloads and stuff like that. So it's all gonna be where you, what effort you put into what area that you want to be good at. It may be an area that you're not good at and then you just want to pull out effort into it to be better at it. There's no right or wrong way to it. I can't say like, is it better to go entry level position to another position? Both a SOC job, right, on a security operations center, and even a like NOSC job doing the network operations center. Still, that's like the foundation, right? That you're knowing the foundation of network, you're knowing what you're working with. You've got a network of logs that are being pushed in there. Going through this course now, you'll see, hey, that's what a log is. That's what a log looks like. And we kind of touch on all these different areas. But if that interests you, right, look at doing some like network plus and do some security plus on the side and see if that is really gaining your interest, because you may be more of a network security person or you may be like, I want to do the research, I want to learn about the adversaries, and I want to go into the threat hunting or threat analyst role. Threat hunting is a little bit different. So threat analyst is just researching, knowing the adversary, and providing those detailed reports, analyze them back to either a team or a supervisor or whatnot. Threat hunting is kind of the same thing, but you're actually using the adversarial information, you're actually hunting for the threats on a network. Or if you find that there's a new vulnerability out there, you're like, okay, let me look on my network and see if it's there. Let me hunt for it. And after you get there, like, do you want to go to the red team? Do you want to do vulnerability management? But it's not saying that you can't run right into a jump right into like a cyber threat analyst or even threat hunter job. You don't have to start at a SOC job. I've never done a SOC job. I would love to do one. I jumped the scale and went right to a cyber threat analyst job because that's where I was put. I just had to jump in, feet first and try to figure it all out. For me, the fire hose effect and constantly learning about it, constantly listening to it, constantly watching YouTube videos, constantly, reading books. I got another one here that I just bought, you can't even see it. Linux Basic for Hackers. So it's like
Yeah, I bought that too.
I'm constantly reading books. I'm constantly looking at stuff. And it's kind of like you're flooding the mind and you're hoping that osmosis is pushing the stuff into your brain. That's what works for me. It doesn't work for everybody that way. You may be one that you have to read stuff. You can't watch it on a screen. So it just depends on what you want to do. There's no good or bad entry level job. It's just getting your foot in the door, taking what you get, and then run with it from there. That's the best advice I can give anybody is take what you can get, right? And then work from there. Use it as a stepping stone. Use it as like, hey, here's some professional training I'm getting. Here's some exposure and experience that you need to add to that resume to maybe get that next job. I mean, I think that's the best thing I could tell anybody at this point. And networking. Networking is another big thing. Network via LinkedIn, network via, your classmates here, because everyone might be getting jobs in different parts of the world in different areas, and you may want to reach out to them. They may work for government jobs, they may work for private sector, they may work for a local government, that now somebody, who's who in the zoo, somebody from across the world that can maybe help you with something.
Thank you.
Anyone else? Yes, Henry.
Just kind of my curiosity, but are certain, let's say, beginner cybersecurity jobs or certain specific fields, let's say like you mentioned SOC analyst versus a NOC analyst, are certain positions more focused on or allows you to work remotely? I figure, let's say like a SOC analyst might be more remote than a NOC analyst, right? Since they have to be there to physically plug in the network cables and whatnot, or versus a kind of like what you're doing. Was that
Cyber threat intel, yeah. So
yeah, cyber threat analysts, yeah.
Yeah, so you see a lot of remote SOC jobs because all a SOC has to do, the company or entity that is looking for the person, they're going to send you out a laptop and you're going to have a VPN into their network and you're going to have everything there. You're going to load into a dashboard. We're going to go through some of the stuff next week. Load into a dashboard and start logging it out. If you want to play around this weekend, there's tools like letsdefend.io. It's a free tool, and you can go like SOC fundamentals. I've been going through that one. It just lets you mock being on a SOC job, and you look at a platform and you're answering some questions. And next week you're gonna get into it on Monday too. So yes, those are remote jobs. Cyber threat analysts are sometimes remote jobs.
So would pen
Uh,
testers be more on site since they have to be, I mean, like, would you be able to pen test from let's say remotely?
So you may be able to, let's say you can always a pen test, right? You start from the outside. Let's see what it looks like from the outside looking in. Let's see what we can penetrate. Let's see where all of our endpoints are. And after that, then you have to go into the network and do the rest. So yes, there's ways where somebody could send you VPN information to VPN into a box with admin credentials, and then let you have full room of the network and then start your pen test on the inside. But keep in mind, like that's harder because you're running all the horsepower off of your computer. All your tools are here, and then you're going remotely across a pipe. So depending on how that pipe is, internet pipe, it can really pinch, and you may not have the resources. But when you're on-prem, then you'll have your server and all your tools right there. Caveat that you could do the penetration test fully remotely, but you may have a team go out and install stuff on that network to get you up and running.
Mhm.
So that's the other end of the spectrum.
Okay, thanks. Oh, actually, just one last question. So, as far as like blue team versus red team being more of the penetration or, testing the network or trying to compromise a network, where the blue team just defends it. Would the blue team be would more jobs on the blue team be remote versus the red team requiring them to be kind of like on site to test their network, or can they do
I
that
think it all
remotely?
just depends on the job and the atmosphere. I couldn't say yes or no.
Okay.
Yeah, I mean, blue team is like a SOC job, that can be remote. Red team could also be remote if let's say you're working for McDonald's, right? Your blue team for McDonald's network and your red team for McDonald's network, and they both could be remote. They've got VPN access, they can get into the network. They may have tools set up on their network already. So yes, they both can be remote. Yes, they could both be on-prem. Just depends on where you're at.
Okay, cool. Thank you.
Anyone else? All right, so let's get into some of these questions we were asking. We're asking some really good questions. I'd like for a volunteer to, here we go, this one. We had our assigned questions right here that the school gave us. Does anybody want to give me either in the chat room or you can unmute yourself another question that you asked? Because we had these 5 right here, and then we had the 6th one. Remember, we asked you to create another question that could have been, okay, there you go. How do you secure your network at home? Really good. What kind of responses were you looking for? Were you looking for like, how do you use different authentication methods? What kind of encryption do you use for your Wi-Fi? Like, do you lock your router up so nobody can steal it? What are we talking about?
I was talking about maybe looking for if you utilize another firewall, and
Okay.
then yeah, or maybe what type of antivirus are you using? Are you using encrypted Wi-Fi? Are you using a VPN? Maybe are you utilizing something like free open source like Wazoo and doing like SIM where you're looking at your logs and everything and just stuff like that.
Excellent. A really good question that wouldn't maybe I like that one because it gives the interviewer something to think about. Like, what does this person do at home, right? And I say, like, somebody asked me, like, besides hanging out with your kids and your family and doing work, what else do you do? And I'm like, well, I research, hacktivist groups and bad guys, and I play a little video games here and there when I have time. So
Exactly. That's why I asked what Henry hit the nail on the head. If
yeah,
you're
just
going
need
for
to practice what you
cybersecurity
preach.
role, how important is it to
Absolutely.
you, and do you practice at home?
And most of you will get into that niche where you're going to start playing with gear, trying to buy cheap gear, trying to set up virtual machines. I'm hoping to rack mount 2 of my other computers here this weekend. Just so I have extra toys to play with, because yes, there Wazoo's that new sim that's free. I want to play with that one. I want to see what I can get done on that one, where you put some clients out to different computers. Both Linux and Windows PCs. So yeah, practicing what you preach is real big. They want to see that you're invested. They want to see that. One of the questions I also got was, what do you do for the cybersecurity community? Like, how do you contribute back? And I'm like, well, I kind of joined a couple meetup groups, but I haven't had time to join them in our region, just because I'm busy with other stuff. They want to know, like, you have a GitHub page or a GitLab page? Are you helping people modify their code and enhance it? That's a big question. They want it because it's like such a community driven area. They want to know how, if you're really in it to win it, you're going to be sharing everything, because you want everybody to win. Because this is a big game of cat and mouse. That's all cybersecurity is. It's whack-a-mole. As soon as you knock one thing down, another one pops back up. And you have to be wanting to chase that, day in and day out, in the evenings, scrolling through your phone while you're in line, getting ready to go on a roller coaster. That's the kind of stuff, if you live and breathe it. That's why there's a little bit of a burnout too. But some people really live and breathe it, and you're going to get questions like that. How do you do this at your home? How do you do you play on labs and stuff in the evening on your off time? And practicing what you preach. Excellent. What other ones? Get at least one more.
I had one.
Okay, go, Robbie.
This is just kind of a random question that I came up and threw at my group mates in the breakout room. But the question was, what initially drew you to this field, and where do you think cybersecurity will be in 10 years, technologically?
Excellent. Nice wide open question. Plenty of answers. There's no wrong answer to it. I like it. Excellent question. All right. So what was the difference between red team and pen testing? You can either give me your response or somebody else, or your interviewer's response. Anyone? There we go. Pen testing is routine health checkup for your computer systems to find weaknesses. A doctor, the tester, examines the system to find any issues, advises how it gets better. Red team, it's more like a surprise exercise, or fake enemy of the red team tries to break in your systems. Performing a real attack, it's full scale drill, test, improve security responses. Very good on both. Another thing you need to add in there too is pen testing is shorter, right? Shorter time frame. Red teaming can go on to weeks, months, years. Is usually can be in-house, right? The red team can be in-house. It doesn't need to be farmed out. Not every company has a red team. Not every network has their own, but red teaming usually where your people are trying to test against your own network, versus a pen test is, hey, here's a small scope. Let's see what we can get into, shorter time frame. So we were looking for at least 3 different things. We've got, we got to get 2 things in each of these. Adding that third one in there. There's multiple different three answers for these. Anyone have anything else you want to add to this one, or can we go to the next one? All right, let's go to the next one. So what are some of the tools that we use for passive reconnaissance? What are some of those passive reconnaissance tools? So passive meaning that you're running the tools and it's not really squawking out, it's not really making a lot of noise, a little bit harder to detect. You know, it's
I have a couple. Oh, John has them too.
they're using passive tools like Shodan, Google Dorks, NSLookup, Archive. Yep. So what other kind of passive tools did we go through? That's going into the what we call social networking or social engineering, right? Doing that research, using those open source tools. Whois is a really good one, Shodan, NSLookup. Any other ones you want to add in there? Anyone? Robbie, did you have some?
Yeah, I believe it's called Moldego.
Okay. And what does that do?
It essentially allows you, it's like a OSINT tool. And it allows you to, or at least I believe, like see everyone's different profile and all the different pictures that anyone is linked to on the internet. Be able to find like what websites those pictures are posted and a lot of background information.
Okay. Recon NG, Harvester. Great. Yeah, these tools that we specifically went over, that's what we're looking for. These other ones are excellent because there's a lot of open source stuff out there. If you go and get, you can find so many tools people have made, and they should tell you how passive they are, right? So active reconnaissance, that's stuff that's actually doing something. It's going to make a little noise on the network. It's going to ask for some feedback from devices. It's going to, actively talk to something else. So what kind of tools were we using there? We used one that was really loud, or could be really loud. And you can even make it louder. It's usually the first step of any active network scan, pen tests. There we go, Nmap. Yep, Nmap, Burp Suite. Burp Suite was awesome because we can sit there and we can inject ourselves in between, you and the client, you and the server, and manipulate the stuff. Nessus, yep, will show us all of our vulnerabilities that are on the network or an application. Nikto, Dirbuster. Dirbuster is awesome if you want to try to look up directories within a certain location. The DNS enumeration tool, Maltego, we just brought that one up again. So is Wireshark considered active or passive? So Wireshark is 100% it's passive because you're using pre-captured files, PCAP files, packet capture files. So you're using Wireshark to look at a PCAP that's off the network. So you may have a network tap put in that is recording network traffic and capturing it and putting it over into a file so that you can look at later. So Wireshark can be done completely offline and completely passive.
Hey, Justin.
Yes.
Yes, that's it. Yeah, I was thinking Wireshark was also passive, thinking that you have to pre-capture, the files and look at it. But doesn't Wireshark also listen into actively, and then you capture the files?
Yeah, you can. Let me look that up real quick. Let's. There we
while
go.
Justin is looking that up, I would say that for the most part, most of what Wireshark does, we can picture it almost like fishing, right? You have a stream, that's going to be your Wi-Fi network. And what we're kind of doing with Wireshark is putting a net out across the stream. Whatever comes our way, we're capturing it, right? If we're doing active reconnaissance, you're going to the source and you're kind of poking the bear, right? Now, there are ways we can kind of do that with Wireshark, but for the most part, we're just, hey, setting up our net, whatever comes our way, we're capturing it, right? And so you're not really touching the source. And so if you're not touching the source, you're not actively doing reconnaissance.
And here was a good example right here. You know, it's active only if you turn on DNS resolving during the capture of those files. So normally it's not done that way. It's going to be 9 times out of 10, it's going to be done in the passive form. Can you use some of these tools for active reconnaissance? Yes, but Wireshark, for all intents and purposes, is going to be used for a passive reconnaissance tool. You can manipulate a lot of these applications. You'll find a lot of that. Here we go. LFI or RFI? What was that? Who just like completely just spun around their chair? They know what it was. There we go. There we go. Some honest people out there. So remote file inclusion and local file inclusion. Someone would explain the difference between both of those. It's a good review.
Or you could even start off with explaining what they have in common. They're both a type of file inclusion attack. So what does that mean?
Go ahead, John.
I could take a shot at it, but honestly, I was kind of spun around by it too. So it's just like what I could sort of figure out in the 10 minutes we spent on it. And I'm not sure if it's accurate. So please feel free to correct me if it's incorrect. But basically, I was
off the screen.
Sorry?
You can read it off the screen if you want.
Yeah, I guess so. Well, I guess remote file inclusion is a type of vulnerability most often found in the suited PHP running web portals. But when I looked at them, I thought that remote file inclusion, the main difference between the two was that in the local file inclusion, like you'd have to upload a file to run it on the host server, that's the target. And then the remote one, the server, if it was vulnerable, you could have it reach out and run the script that's on the server that the attacker would control. And I had assumed that that meant because the server was reaching out and you're not trying to put stuff through a port to upload it, like that could potentially bypass other security measures because it's like maybe in your detection would see the server reaching out as not an issue because it's one of their systems.
Yeah, right there it says, you know, remote file inclusion attacks, hackers take the merits of the dynamic file, including commands. Versus local file inclusion is the attacker has to upload it.
So yeah, to pretty much recapitulate with what John was saying, you hit the nail on the head with that, John. One is, are we putting it so that way we're having it do something when we have this file inclusion with something that they already have as a file on the server itself? Or like you said, are we having it reach out to a file that we have, something that's off of the server, and saying, hey, reach out over here and run that, right? That's the only real difference between these two different types of attacks. We're still making use of the fact that, hey, the way that it's built up, the way that PHP is running, it's referring to a file. We're then manipulating which file is it trying to be able to access. And then the difference between these two is, are we manipulating it so it accesses something that it already has on itself, or are we reaching out to somewhere else and accessing a different file?
And Tony, which one would you say is more is worse, which is more dangerous, as it says?
I would say probably the remotes, because like you were pointing out, we have more control over the remotes. We could have something totally malicious and it's not going to be able to detect that necessarily, right? If we try to put a malicious file on the server, depending on their defenses, depending on the software they have up and running, it might be able to detect that, right? Might be able to look at it and say, oh, the signature that this file has is malicious. don't keep it on the file, right? Or quarantine it or destroy it or whatever the case is. They don't have that level of control when we're hosting it, when we're holding it on our server, right? The only thing that they might be able to do is, hey, don't trust it if it's coming from an outside source, don't run it, right? But they have to do proper sanitization in order for that to happen. So if it's vulnerable, if it wasn't configured correctly and it's able to run something on a remote host, then we can be able to have the most malicious thing possible. And it's not going to know about that until well after it's already ran it.
Excellent. So you're running a pen test on a company. What is the different phases that you will undergo to perform this assessment? So what's the first step you would go through? Planning and scoping. Yep. So that's your planning, your reconnaissance phase, whether it's open source, whether it's reconnaissance on the network. And then what's your second step? We're actually going into, yeah, so that's your planning scope, your scope, non-scope, your charter, legalities, risk. That's all during that planning / profiling stage, that reconnaissance phase, right? Getting all the information we can. And then we go into the next phase, which is what? We got our scope. We can then start scanning, right?
So John in the chat says identifying vulnerabilities. That's kind of also leads into that, right? That's another way we can kind of word it.
After that scanning, you're going to identify those. You have that knowledge, right? And you'll see certain applications, PHP servers, Apache servers, whatnot, running on that system. And already in your brain, you're like, oh, there's a vulnerability there. I know I've saw something here. So that stage is going through right there. When your scanning is done, you're going through what? Your analysis, or your vulnerability analysis stage. So looking at what we have, let's do that vulnerability analysis. Let's see what is actually vulnerable. What is the highest vulnerable application services endpoints on that network? Then what do you do after that? You attack it. Okay, that's your exploitation stage. And the last one, reporting. Yep. That leads us to the last one right here, with some of the most important things that you were asked about the pen test report. Or some of those most valuable things need to be going into that report. How the test is completed, correct? Thorough, understandable, recommendations to all the stakeholders. Any security flaws, pointing them in the direction of better security procedures, a well-written penetration test report adds value to the relationship. Absolutely. Yeah, fully. Let's see, I don't know if it was covered. So your attack path, that also needs to be covered. How you got there, what steps you took to get you from point A to point B. After you scan the network, you saw that PHP server. How did you attack it, right? That's also a way of making sure you can test yourself, keep yourself in check of being in scope. Because you're like, oh, I saw it was here, but it was a different IP address, and the IP address wasn't in scope, but I attacked it anyways. Well, that's where you went outside your boundary box there. Great. And then who wants to walk me through the cyber kill chain? How many steps are there? How many phases? Let's ask
If
that.
I may, before,
Yeah, go ahead.
I want to emphasize that one other thing that's also very important beyond just stating, hey, these are what we did, right? These are the things we did for our attack vector to get in. And then these are our recommendations to how to be able to better secure things. What did you do to close the doors that you opened? Right? That's always going to be a big major thing. Hey, I went ahead and I attacked this way. I opened the doors. I was able to get a foothold. I was able to do this, that, and the other thing. Okay, once you were done and you did your penetration test, what did you do to close those doors, right? What cleanup? Exactly, Antonino. What did you do to kind of close them, clean up, and make sure that you didn't leave them open and exposed for actual malicious actors to then come in after you and do something, right? So that's also a very big and important thing, because what if you did a penetration test and then a week or two, or maybe even just a few days after you did your penetration test, they got attacked by an actual hacker in the exact same manner? They could turn around and legally say, well, you left this open, you left this vulnerable or something, right? But if you're able to show, if you're able to demonstrate, you're able to show in your report, hey, this is what I did to then close those things, and that way it wasn't left vulnerable, then you're covering yourself as well, right? So you want to make sure that, hey, while we did get in this way, we made sure to then be able to go ahead and clean up like this, so that way you weren't left exposed. You didn't have an issue after we were done, right? So that's a
Yeah.
very big important thing that you need to specify as well.
Absolutely. And defining, it happens all the time with me. Your penetration test is for that block in time in life, right? It's for those couple days, that couple weeks. That's what you've seen at that portion, right? Same thing goes with even during a hunt mission, when you're looking for stuff on a network. You're covering your tracks for that time frame. After that, something could have changed. You could have left all the doors shut, walked out the door, packed up your stuff and left, and another door could have opened like that and somebody got in. It's just the way it is. But you're covered on that time frame, that block of time that was in your scope. So keep that in mind too. All right, so we got 7 stages, correct? Developed by Lockheed Martin, which includes reconnaissance, weaponization, delivery, exploitation, installation, command and control C2, and actions on objectives. Did we hit all of them? Boop, doop, doop. I think we did. Yes, that was right out of the textbook. Anyone want to expand on cyber kill chain? Is there anything else we left out? No? Okay. So we discussed all the questions. We went through that. We're now more comfortable with interviewing. We've got more questions, possible questions that you can add to your notebook there, right? Your handy dandy notebook of all the good stuff. Make sure you have your big crown out and write those things down, because when you do get into an interview, at least you have some stuff to go off of. Have some stuff to prep you with. Thinking of the questions maybe asked, thinking of, going into more of a coding job, you're going to look for questions about how you write code, different types of code. Which one did you learn on? Which one do you feel comfortable with? Would you be okay with learning, if you're going in to be a Python programmer, hey, what if we give you some C# stuff? Will you be okay with that? Stuff like that. Let's see. We're going to now, we've got no more questions on this. We're going to introduce you to the next step.
Well, while he's pulling that up, this next step, keep in mind, we're going to be having you guys have time in class tomorrow to be able to go ahead and work on this. But we're going to go ahead and kind of bring it to your attention and kind of let you know a first look at it tonight, right? So that you guys are aware of what's happening, what's going to be going on. Tomorrow's mainly going to be geared towards, hey, if you have any questions or if there's any difficulties in trying to be able to get started with it, to let us know. That way we are here for you. If there's any help that you might need to be able to go ahead and get started on this, or to be able to have the VMs up and running and so on, we can be able to address that. But you will have time to work on this tomorrow. That's when we're really going to go ahead and have you guys get started on it. But we're going to introduce it here.
Yeah, so you we'll have a whole 3 hours tomorrow for you just to jump into it. Tony and I will be here if you have any questions. You'll be working on it with your within a group. So you've got plenty of time, and if there's any questions at all, we're here for the whole time for you. Unlike the last time where we gave it to you and gave kind of like an assignment to start doing over the weekend, we have time built in the class now to get started on it. So congratulations, you all are now level 1 security analysts and have assigned to shadow the in-house offensive security team. The offensive security team validates internal security controls to see whether they are effective for protecting the Simply development organization. The offensive security team also provides services to external clients to validate their security controls. One of your clients is Simply Learn. So here are your responsibilities of the team. You're going to support planning to include development of test objectives, data requirements, configurations, and schedules. You're going to conduct a vulnerability assessment, network or device penetration test, and other engagements. Provide documentation, labeled vulnerabilities, and active exploitation of client-owned network hardware and software. You know, this is a good typical what a job posting will look like. You may have some experience in a couple of these, but if you're hitting like at least one on every line, go ahead and apply for that job. You communicate the technical with technical and executive clients. So remember, technical clients, you can get down to the nitty-gritty. Executive clients, you might have to step it up a level, right? You know, cybersecurity for dummies versus like, let's get down and nerd out with the stuff. Regarding the results of data collection, analysis, task, and client environments. So, you know, I say that in kind of a funny way, but like your executive clients are like those bosses, they're going to come like, what do I need to fix? And you give them a list of stuff and how much is it going to cost? You know, that's always some of those responses, you know, and they're going to start pointing to the IT guy that just got hired out of high school. Like, I thought he was fixing this stuff. Well, yeah. Together with the team, collaborating on sharing recommendations and findings, including presentations, and addressing client questions and concerns. So every time you put something in that pen test report, remember, or even a threat hunting report, remember that there's going to be a question that follows up, right? If we put that in there, make another notebook of how those responses are going to be, or a word pad, whatever. Make sure you have a response for it, because that is going to come back. And if you can do that response as you're putting it in there, then you're good to go. Because if not, you're going to have to do some more research on the back end when you're off the network, and you may not have that stuff fresh in your mind. Research new threats, vulnerabilities, security technologies, and countermeasures to provide mitigations and remediation recommendations. Everything we've done over the last couple of weeks. Here's the qualifications. Hopefully somebody in your group is good on Windows, Linux, or Unix. Same thing. Understanding the network or device penetration methodology, familiarity with the tools we used, framework, have some kind of dabble in one of these scripting and programming languages, verbal and written, clear, concise, at the appropriate level communication. So don't go to the executive meeting and just nerd out. They're just going to be like falling asleep and just way over their head. So make sure you speak to the environment, to the group that's there. Focused adherence and safety and security requirements, and commitment to making security better. So after all that, under your, should be over here to the left-hand side. Yes, there it is. So you should be able to download this, your problem here. I think I had it open. We've got it. It's 5 pages long. It's not very big. Let me.
So while he's pulling that up, as you saw, to access the document that's going to give you the majority of the details of what you're going to do, you're going to see that, of course, instead of going to the self-learning, right, on our LMS, you're going to go to the assessment track portion of it. We're going to go ahead and click on that penetration test problem. And then there, as you saw in the very bottom of the description, which we just ran over, there's the link to this document right here. So once you go ahead and get that document, it'll ask you to copy it. Once you get your own copy, you can be able to go ahead and then follow the instructions that we're going to kind of briefly go over right here to be able to go ahead and see what it is that we're having you work on for this scenario.
So here's your course end project for red team. So in this career simulation, you will use your newfound knowledge and vulnerabilities assessment, just like, yep. So we just talked about that. Learning objectives. Your deliverable for this career simulation should demonstrate your understanding of the following learning objectives. So exhibit that ethical hacking protocol, so that white hat protocol, to evaluate security and identify vulnerabilities in the target network systems and their infrastructure. You're going to do the scanning with the tools. You're going to configure those tools to perform the offensive techniques, right? So that's making those payloads. Hint, hint. You're going to use Metasploit. You're going to establish some interpreter sessions. You're going to look for ways to get privilege escalation and make some lateral movement. And you're going to use that pass the hash technique to get some of those flaws in the NTLM authentication. Interpersonal skills, work well with others, group approach, use your ears, listen well, speak clearly, write down clear and concise notes so anybody can understand your steps, your thought process and everything. Respond positively and constructive to all feedback, whether the person is right or wrong, that should be in there. Reach agreements that promote mutual goals and interests. So some more problem solving stuff here. So here's your scenario. Simplilearn has reviewed your team's report and is satisfied with the results. Hot dog, because your team did such a great job, they want you to follow up penetration test. That's what I'm talking about. You've done a good job. You've established that rapport, that relationship, and they want you back with an isolated portion of their network. And this is very common. You're going to go out there and you're going to maybe do a real big part of their network, and they're going to love what you do, and they're going to say, I'm going to have you come back, and I want you to focus on this one spot. I want you to tell me everything there is about this one spot. And having that smaller portion will allow you to get a lot more fidelity, really dive into maybe setting up some devices to capture packets. So you can do use Wireshark, maybe set up some extra nodes to collect different things. So it was not a part of the original engagement. So do another isolated portion now. However, the isolated portion of the network has a small number of systems, so it doesn't make sense for your whole entire team to be involved with follow-up. Very common as well. You'd have maybe 5 or 10 people go out for a large network. You may need 2 or 3 to go out with a smaller one. Instead, your team has been assigned to complete the penetration test for this isolated network on your own. So they're soloing everyone out as you've proven yourself ready to handle this type of engagement. So here's your rules of engagement. We're giving you a set of IP addresses. You don't need to do any social networking or social engineering. You are allowed to work with your classmates, and everything you need to complete this test system is already there. There's no reason to download any other kind of tools. So everything should be on the VMs. So remember, some of those applications don't work. You may have to sudo s into them to get them working. If you come across any tools that you cannot get to work that you want to work, let us know. That goes with having to remap some stuff, like we did with like I had done with John the Ripper, because it wasn't in the right folder. So if you have to redo any of the paths, or something's not working, please let us know right away. So you're going to use course 6, capture the flag machine, to complete these challenges.
Now, real quick, before we move on from there, that means we're not using the recon lab, right? We're not using the vulnerability labs, or even the more recent one that we were doing for privilege escalation, right? If you go and you look in your virtual labs section, there should be one strictly for what we have listed as capture the flag. That's the one you're going to be using, that environment.
All the way to the right. It's all the way to the right. It says CTF on it.
Mm-hmm.
So here's some challenges here for you. I'm not going to go through all of these because if you want to, you can start on this now. We are going to work on this tomorrow. So I would encourage everyone to download this, at least have it, look at it, launch your lab. You know, we've got a few more minutes left of class. Launch the lab, make sure everything's working with it. And then tomorrow, when you come in, we can quickly open up this document again, launch the labs, make sure everything's working, and then we'll be here standing by for after we push you in your groups for any kind of technical assistance that you may need.
And do keep in mind that this report you guys will be writing about how you completed each of the challenges. While you can be able to refer back to the notes, you can be able to use things like Google if you want to be able to go ahead and kind of like, oh, I don't remember what the authentication code is. If I'm looking at, like, let's say the event viewer or something, right? For stuff like that, that's fine. But you still need to be able to go ahead and individually complete each of these challenges and turn in your own individual work, right? So you need to make sure that whatever you guys get turned in, it's not just like, let's say, one shared file amongst everybody, right? That's not going to show us that, oh, if John turned this in, that Robbie, for example, was able to go ahead and accomplish all of these as well to demonstrate that he knows how to be able to go ahead and do this red team stuff. So do keep that in mind. You guys should be able to go ahead and individually complete these and turn in your own different and separate reports, right?
Absolutely. Any questions? When will the reports be due? Excellent idea. So we've got, Tony and I haven't really fully went over that, but we've got all day tomorrow, right? All class tomorrow. You've been introduced to it now. So if tomorrow is not a day of work for you and you want to kind of work on some of this ahead of time, you have the option to do that. I'm thinking, and then you have the whole weekend. So I don't know, Tony, what do you think? A week? I think by the time they get done going through all these challenges, you should just be up to writing your report. And I think that usually takes a week or two to write a report to get back to the customer. So if we want to be realistic, I would think a week after we're done tomorrow night. So say Friday by midnight next week. So what is that? Whatever Friday
Probably
midnight.
just slightly over 1 week. So let's go with that. Friday end of day. So like Justin said, midnight, right?
So that's the 4th. So you have till the 4th at midnight to submit it. Will course 7 unlocked for us? Yes, so we will get the next course unlocked. So it should be unlocked by tomorrow. So blue team should be unlocked by tomorrow. Any other excellent questions or comments or anything else you would like us to discuss before you jump into this fun exercise?
All right, then before you guys start leaving, in the chat, Anusha has already posted our link to our feedback for tonight's session. Please go ahead, take some time, click on that link. I've also already posted it into our main Slack channel so that way you guys can be able to go ahead and give us some feedback, let us know how we're doing. That way, if we need a course correct, we can do so. And yeah, with that, if you have any questions or anything that you guys have a concern that you guys want to have addressed, feel free to stick around a little bit longer. Justin and I will stick around to be able to address that. Otherwise, if you have no questions and you guys are pretty much, you guys have understood everything we've talked about so far, have a wonderful night. We'll see you guys tomorrow to go more in depth about exactly what's going to be entailing for this last part of Red Team.
Competency checkpoints, make sure you've got them all done.
Definitely. Make sure
Thank you
guys have
so
done.
much. Thank you so much, Tony and Justin. Thank you all for your participation. As Tony told, the survey link is in the chat box. Make sure you give your valuable feedbacks and rate the session. Thank you.
Have a good night.
Good night, everyone. Take care.
So I had a quick question.
Mhm.
Um, obviously, as we progress through this boot camp, we're getting ready to enter the workforce in this field, and we're building our CV, and hopefully for all of us, building like a repository with like proof of skills. I'm assuming that we could put this on there as well, this particular pen test, and if not, I want to ask you about potentially putting a different.
Absolutely. Like any kind of labs you do, you attended Caltech Cybersecurity Boot Camp, you did penetration tests, you did coding, you did, bash scripting, all that stuff is like experience, right? It doesn't matter if it's you playing with a lab online through somebody, there's lots of free labs out there. Pico CTF, there's some parts of Hack the Box and Try Hack Me are free. Offsec Security, Offensive Security, who makes Kali Linux. They also have their own Proving Grounds, which has a free portion. You can access so many labs per day that's free. So all that stuff like is good stuff to put on your as far as experience, because like sometimes all people do is go to CTF tournaments, right? And that's where they have their fun and their experience, because some of that stuff is really, really hard.
Yeah. What was that
Yeah.
last one you mentioned? The last example? I believe it was
Offensive Security, Offset.
yeah. I'm just gonna write that down.
So that's the developers who made Kali.
Yeah, offset. Okay. And also I was wondering, I know I asked you before about the legality of like maybe pen testing your own data, right? And Tony, I think you elaborated on, said like as long as it's your data, you're not committing any issue there. And I wanted to know if that applies to devices as well, and if it's something that would be worth putting on your CV if, let's say, you were to pen test your own vehicle or something like that.
It's your own property. You can do whatever you want with it. I mean, you can buy, like if you have old devices, right? You can try wireless pen testing them. You can there's so many things you could do. Yeah, if you're using your own network and stuff like that, you can do whatever you want.
What I would say
Even-
makes a
Okay.
difference is how you go ahead and communicate what exactly it was that you did and what did you kind of like find out from that, right? So you can look online where there's tons of blogs or other like walkthroughs where they'll say like, hey, this is what we were trying to do. These are the steps that I took. And then if you have something similar, like Justin was mentioning, there's a lot of free boxes out there you can try to hack, right? So there's a lot of people that have already said, well, I went ahead and I downloaded this, I installed it on my virtual machine, I got it up and running. And then I went and these were the steps that I did to hack it, right? So if you were to do something like that with a device that you have of your own, again, the communication, showing that report, this demonstrating to them that like, hey, this is what I was able to initially do when I was looking over, finding out information about it, finding out how it could be possibly vulnerable. And then this is what I did to actually get in and be able to start attacking it, right? And so knowing how to form those reports and effectively communicate that's going to be key, because then they have an example now of, hey, if I hire this person for blue team or for red team or whatever the case is, they can effectively write a report and communicate what did they do, right?
Okay. Because I know apparently one of the newer versions of Metasploit actually has a module dedicated to exploits for automobiles. And I know that the head units are usually utilizing the CAD protocol, but what I don't understand is where the CAD protocol has access to the actual, like maybe the servers of Mazda, for instance, is the vehicle I'm looking to do this on is a 2019. So yeah, it sounds exciting, but I also just wanted to double check if I'm not gonna accidentally maybe step in the wrong direction here,
So if it's local, if it's your thing, like you're not. Let's say you have a Wi-Fi hotspot on your car, right? And you want to try to use that Wi-Fi hotspot to do some wireless pen testing, it's your device, it's your vehicle. If there's a way that you would be connecting that vehicle via outside channels, like it's going out and has a public IP address and is running through, say, Tesla, right? Tesla runs on Tesla network. You're not going to really pen test your Tesla because you're going through Tesla's network, because then you get into that whole legality of you're going to try to get through their network to get to your car, if that makes sense.
Okay, so maybe
But
I shouldn't touch the
for
CAD
instance-
protocol then.
For instance, Fords, right? You can plug in a USB device to Fords to get into the sync computer system. So that's how you can upload the new software to it. So there's a way that you could get into the system like that, or your OBD2 port on the car, getting into the vehicle that way. That kind of stuff, completely legal because it's your own. But when you, when you try to just think about how it's mapped out, and you can do research on how your audio system's made into built in the vehicle, where the wiring goes, like how does it communicate, like all that stuff should be almost open to where you can find something that tells you how the system runs, and then you can make your decision on your own whether is it spicy or not to actually try it, or just work on online labs that are a little bit
Yeah,
easier.
no, for sure. I was actually just genuinely curious on what type of data is there. So, but yeah, it might not be fruitful, but
Configuration files, probably, if your whole car is running off that system that's in the center console, like could be when the car turns on, when the lights come on, the timer for the lights to go on and off, stuff like that.
yeah. Okay, cool. Thanks. That was my question. Appreciate it. Thanks for class, guys.
No worries. Have a good night.
See you tomorrow.
Those two individuals weren't there all night, so just boot them out.
Yeah. See you tonight. Sorry. See you tomorrow.
See you
All right,
tomorrow.
see you
Have a
tomorrow.
wonderful night,
Thank you.
guys. Almost 20 people that are logged in. So we're going to go ahead and begin. So let me go ahead and share my screen, and we'll go ahead and take a look at what are we going to be discussing for today. So we're going to see that we're now towards the end of our stuff with Red Team, right? So we're going to go ahead and see that we've pretty much covered the entire sort of track that we have as the way that hackers would go about, or red teamers would go about trying to be able to go ahead and gain access to a machine, right? We started off with at the very beginning, right? If we see right here, if we follow our learning, self-learning track that we have here in our LMS, we started with network scanning, gathering information. That was our recon, right? We talked about both passive and active recon. Then we went into figuring out about the vulnerabilities. So we saw how there was web vulnerabilities, both client side and server side. Then we started learning about how we could be able to exploit those things, right? So we talked about social engineering, OS exploitation, using Metasploit to be able to go ahead and exploit our stuff, and so on. Then we talked about how after the fact, once we've gained access, right? Once we got a foothold into a machine, we could do privilege escalation and lateral movement to be able to move into other machines, or to be able to move into other accounts that have more permissions, more authority, right? And so now we're getting towards the end, which is once we've done all that, we've done our post exploitation, everything like that. The whole point of Red Team, right? The whole point of any penetration test is to then be able to go ahead and present it back to the people that have hired you. And so you got to make a report where you're able to go ahead and disclose all your findings, exactly how did you do it, what errors or what vulnerabilities were you able to exploit, what were the steps you took, right? All those kinds of things. So that's what modern exploitation and reporting is going to be concerning, right? So if we go to our Red Team section, we're now in 1.14, right? So let's go ahead and maximize that. And so we're going to see then, as it tells us, congratulations, at this point, we've completed how we can be able to do exploitation, right? We've taken a look at all those things and we've kind of seen the entire step-by-step thing that we have to do, right? We start off with being able to go ahead and gather information about our target. How are they weak? Then trying to exploit that, then trying to be able to move around or gain more permissions. And then finally, once we're done, now we are entering into where we write up our reports discussing it, right? So we're going to go right here and see that a big part of this, a big part of Red Team is the report writing process, right? Understanding exactly how are we going to report this? How are we going to be describing what we were doing? What are the step-by-step actions, right? So that way others can be able to know exactly what was occurring, right? What defenses were there? How were we able to circumvent those defenses, and so on and so forth, right? So our learning objectives, we're going to see that we're going to learn how we can explain, again, our security issues, our risks, our vulnerabilities, right? Explain how our exploitation is performed within our modern environments. And then finally, for tonight, so we can get an idea of the type of reports and what's in them and how to be able to go ahead and write them, we're going to analyze some penetration reports and then explain their purpose, right? So the first thing we want to take a look at is while we are doing our red teaming or when we are doing penetration testing, what type of defenses are there going to be, right? Because so far we've been looking at our machines that we have here in our VMs, and they are purposely vulnerable, right? We purposely left them in with some type of weakness that we can be able to exploit. It did take us a little bit of time for some of the stuff, right? It's like for the Windows machine to be able to go ahead and find out what was it weak with, and then be able to set up the exploit correctly so that we can be able to get that reverse shell. But not everything is going to be like that, right? There are going to be times where we may be caught, where we're trying to be able to do something and the blue team defenders realize what's going on and then they're able to stop us, right? Or something to that effect, right? Where what we're doing is causing a lot of noise. And so essentially our actions are able to go ahead and be detected. And so then what happens as a result of that? So that's kind of what we're talking about right here. We need to understand exactly what type of defenses are there going to be so that if we were to try a penetration test or if we were to be doing red teaming, that we know exactly what to expect and then how to try and circumvent that or how to try and be more stealthy so that way the blue team may not detect us, right? Because if it's possible, if we can do it, that means that others can do it. Others that are probably going to be more malicious than us as the red team or as a hired penetration tester, right? And so that's what we want to be able to figure out is, hey, can this be done? Can they be able to gain access? If so, what way might they go about doing it so that way we can let these people know, right? We can let that blue team know, and that way they can properly defend for it. So that way, hopefully it doesn't occur in the future. So we're going to see right here, most of our modern computing environments will usually have defenses that you'll come across again and again, right, throughout our offensive security professional careers. Now, these defenses can include basic stuff that we might expect, like antivirus software, right? So a lot of the times, if you're trying to be able to go ahead and use known malware to try and maybe in a phishing campaign to be able to help you gain you access to a machine, right? If it's well known, then chances are that antivirus software is going to catch it and it's not going to let them use it, right? So therefore, it's going to stop you from being able to gain that access because they're not going to be able to activate your script because it's inside of known malware, right? Stuff like that. There's of course also firewalls. We discussed firewalls at length, and we know that they filter out connections, right? We can be able to set up firewall rules so we can be able to say, hey, if this is an untrusted IP address, then don't let that communication continue, right? It'll just drop those packets. And so that doesn't allow us to communicate with that machine. And then of course, there's also what we call EDR software or endpoint detection and response. Now, depending on the type of engagements, right? So whether we're doing a penetration test or something like just a regular red team, you may be expected to work around those, right? So if it's part of a red team, depending on how they have it set up, depending on how well they want you to be able to kind of test their defenses, it could be that they'll go ahead and already let you get an inside track, right? Hey, if somebody were to get into our network and get by the firewall, get by these other stuff, what can they have access to? What can they be able to do, right? But if it's more like a penetration test, you may not be able to have that benefit, right? It may be just, hey, if somebody just were to be able to get regular public access from the internet to us, how could they be able to possibly circumvent our firewall? How could they be able to get past these defenses and so on and so forth, right? So depending on that type of engagement is whether or not we might have to anticipate these blue team defenses and try and get around them. So we say then our antivirus software, again, this is the most basic kind of protection. There's the most people are familiar with this, right? Most people nowadays, when we get a computer, we're familiar that you probably should be running antivirus protection to make sure you're not having any malicious software being installed, right? Or at least any known malicious software. Now, typically, the way that this works is what's known as signature based, right? What does that mean? Well, if you recall, when we were talking about hashes way back towards the beginning of our boot camp, right? We said that a hash is a particular value that we can take of just about anything, right? We can be able to go ahead and pass a file through it. We can be able to pass text through it. We can pass almost anything we want through a hashing algorithm, and it'll give us a specific value, right? Now, we said that hashing is not only used for passwords, as we saw when we were discussing how we can be able to get compromised credentials, right? Last week. Hashes can be also used for data integrity. We said that we can take a hash of a file, and we go ahead and give us a value for that file. And then if that file is changed, even by 1 bit, right? If it's just one thing that's different, if we ran it through the hashing algorithm, it'll give us a completely different hash value. And so we're able to go ahead and say, if I have the known hash value of some software, and then when I download it, and I go ahead and check the hash value of that software, if I do not get the same value, I know it was modified or changed in some way, shape, or form, right? That's typically something similar to what's happening here when we're talking about an antivirus signature-based defense. What's happening is if we have known malware, we'll typically go ahead and there's parts of it that we can be able to pass through something like a hashing algorithm, and it'll give us a value, right? And that value is known. And so therefore, when we're using antivirus software, typically it can do something similar to that, right? It can be able to run through those softwares that you're running, be able to pass them through that value, be able to get that signature, and then compare it and say, hey, does this give us this known value for malware? And if it does, then we've found out that you haven't been infected, right? Based on that signature. So we can be able to say that it's a unique identifier, right? It's a unique way of being able to go ahead and take a look at some software and be able to know what kind of software it is, right? And so we have these values. That's why every so often you have to update your antivirus, right? Because it's downloading these signatures, these values of that malicious software. So that way it knows what to compare what it finds when it scans your computer, right? I can compare it to those values and see, is it one of these known values? If it is, then it's malware, right? It's malicious software. So we see then right here, it tells us that antivirus works exactly in this manner, right? Scanning the file and then checking that file after it scans it, after it runs it through that algorithm to see, does it match any of these known signatures, right? So does it have these signatures matching with that file? Now, if there is a match, our antivirus is going to mark it as malicious, and then it's going to go ahead and try and remove it from the system or quarantine it or do something in response to that, right? Now, we're also going to see, because this is the most common defense, this is also going to be the easiest to bypass, right? All we got to do if it's using a signature-based defense is just somehow change our software so that way its signature is no longer matching. It's no longer one that is known, right? So we see that right here. It's only going to go ahead and recognize something as malicious if it's matching a known signature. So if we can be able to change how our software looks, if we can be able to change its signature, it's not going to be recognized by that antivirus, right? And so how can we do that? Well, we can make it look benign through what we call obfuscation, right? This is possibly like a Trojan virus, right? Trying to hide it inside of what seems to be legitimate software, right? Or we could do something like encryption. That's what a more prevalent, more common since 2017, a type of malware known as polymorphic malware uses, right? It actually encrypts part of itself so that way, every time that it's ran, it follows through with a new encryption value, a new encryption algorithm to be able to go ahead and change what it's looking at when it's at rest, right? It's never going to be in the same mode twice because of that encryption. And so therefore, its signature is never going to match to what it was before, right? So if we can be able to use encryption, we can use obfuscation, we can hide it inside of benign software or something that looks benign, then it's not going to have that known signature that the antivirus is looking for, right? And so therefore, it won't get marked as malicious. Now, in addition to this, antivirus software only works on files that are located on its own system, right? Most modern exploitation is actually fileless, meaning that the exploitation happens completely in memory, right? So you're running this thing in memory, and so therefore it's able to get exploited because of what's happening in the memory. Whereas our antivirus is only scanning the hard drive, right? It's only scanning the files when they're at rest. It's not scanning necessarily what's in memory, right? And so that negates the antivirus software's functionality. Now, we pointed out firewalls are another defense, right? And so therefore, most organizations, most of us know that having a firewall is kind of necessary or is very well formed, right? When you're trying to be able to have your security beefed up. And most of our routers, home routers and so on and so forth, kind of come in built in by default with a router that has a firewall, right? So that firewall is implemented there at that level. Now we can have more firewalls, right? We can be able to have a software firewall on our machine. We can be able to go ahead and have another network firewall attached somewhere to our network and so on and so forth. But usually we have some type of firewall somewhere on our network, right? So modern firewalls inspect any inbound and outbound traffic. And then what it's doing is based on its firewall rules, it's either allowing that traffic to go through and pass, or it's going to shut it down and drop it, right? And so therefore that communication is not being allowed to happen. So we say then, this means that any unencrypted network connection will be subject to inspection, which can stop your attempts to gain access to an organization's network. Now, of course, the best way around this is to just make your network connections appear legitimate, right? Make them look just like any other external network activity. That means instead of just showing or sending packets that have just your malicious and code or your malicious packets, right? You can try and hide it as if it were ordinary web traffic. So that way, when the firewall looks at it, it looks like if it's a normal HTTP GET request or something similar, right? So you kind of see this right here, that we can be able to use HTTP or even HTTPS, which is supposed to be secure, right? We can be able to use these payloads as long as we have a valid SSL certificate, right? And so on and so forth. And that way it looks like legitimate web traffic. Now we talked about SSL certificates back a little bit before, right? And saw how we could be able to even create SSL certificates of our own when we went ahead and we're running that script to be able to go ahead and self-sign, right? But we're gonna see that most of the time when we're doing something like Metasploits, because Metasploits is a known framework, right? Any signatures, any SSL certificates that Metasploits provides is going to be well known. And so therefore it's easy to detect, right? So chances are, if we're going to be going about this way of trying to be able to obfuscate our network information, our packets that we're sending over, right? To get past that firewall, we're probably going to want to be able to go ahead and form our own custom SSL certificates and sign them in a different manner than what Metasploit would provide to try and be able to circumvent that, right? Again, the whole concept is these things are well known. And if they are well known, they're easily recognizable, they're easily detectable. And so if we're trying to get past these defenses, we got to kind of go a little bit out of our way to be able to go ahead and make it unrecognizable to what is well known, right? And then finally, we get to our EDR, or again, EDR stands for Endpoint Detection and Response Software. This is the latest type of security solution. It is either implemented at most organizations or nowadays, because they're starting to realize with all the latest hacks that have happened over the previous years, right? They're starting to get in the process of being implemented. Now, we're going to see that our EDR solutions look at known signatures, similar to our antivirus, right? But they also monitor the activity on the system itself. So it's not just scanning the files, it's not just looking at the stuff when they're at rest and saying, can we recognize this as known malware? But it's also saying, let's look and see, what is this program actually doing? For example, if it's supposedly Word, right? Microsoft Word, just a regular word processor, but we notice that, hey, it keeps making a connection, a network connection where it's calling out to a certain IP address every so often, again and again and again. When we're not doing something like an update, it's not connecting to Microsoft's servers, right? We're not trying to be able to download some clip art or something like that. We're just using the software while we're just typing a report, and it's making this connection over and over and over again. That's suspicious. That activity is something that a word processor wouldn't be doing, right? And so therefore it can mark that as something that is suspicious, something that's possibly malware, and for further evaluation, right? So we see then EDR solutions are aware of common hacker tactics, their techniques and procedures. Those together, tactics, techniques, and procedures are known as TTPs. It's also can access our SAM database, right? That we can be able to go ahead and dump the LSAS, how we can establish our command and control or C2 of a system. And these can also be able to detect any changing registry values, right? These are all different things that these type of softwares have been built up to be able to recognize and more. It also monitors any known exploit methods that are within software, such as we've gone over, right, this past few weeks, process injection, process hollowing, shellcode execution, and so on and so forth, right? So trying to be able to, as we run a process, inject some code into it and get it to do what we want rather than what the software was supposed to do, or trying to be able to go ahead and get a reverse code, a reverse shell or a bind shell going up and running, right? So that's that shellcode execution and so on and so forth. However, as we've pointed out, and we will continue to point out time and time again, we point out that it's not impossible to work around, right? Nothing is 100% secure. You can never make anything that is digital and connected to a network or the internet 100% that it's secured. You cannot break into it, right? There's always going to be weaknesses. There's always going to be ways to get around it. Sometimes you have to be a little bit more clever than others, but there's always going to be a way, right? So we point out that as this software becomes more and more widely used, of course, the hackers, the people that are trying to be malicious actors, right? They're going to find more and more ways to be able to bypass them. So as EDR bypasses are currently being performed, and they will become more prevalent in the future, right? Now, there are, of course, more kinds of defenses as well, such as application safe lifting. We can be able to go ahead and when it comes to safe listing, picture this kind of like our firewall rules, right? We could be able to go in and we said when we're dealing with our firewalls that we can set by default, hey, block everything unless one of these rules allows it, right? And then we can be able to have as part of our rules, hey, if it's this IP address, we trust it. And so therefore allow that network connection, right? But if it's not on that list of trusted IP addresses, then it's going to block it by default. That's kind of what's happening with this application safe listing, right? We can be able to go ahead and when it comes to safe listing stuff, say, hey, if it's on this list of known good softwares, then go ahead and let that application run. But if it's not on this list, any other type of software application we try to run, shut it down, right? Don't let it actually succeed in running. So we can do stuff like that. There's email security solutions and security information and event management. So this is going to be a big one as well as we get into blue team, right? So we call this a SIEM, security information and event management, SIEM. And of course, we'll go ahead and discuss more of these defenses and so on and so forth as we get into blue team. Now, before I pass it over to Justin, so he can be able to go over a few of these tools, a few of these defenses, right? A few of the types of EDR softwares that are out there, I will quickly go ahead and point out one thing that can be able to help us out with a lot of stuff, and it's a very good blue team defense. And so we need to be aware of this when we're doing red team and penetration testing, is this website right here, VirusTotal, right? So virustotal.com, we see right here, you can be able to go ahead and upload a file. You can give it a URL, right? Or you can do a search in general for different things. So for example, you can search a particular hash, a particular domain, an IP address, and so on and so forth. And it can be able to tell you based on what you're providing, whether or not something is recognized as being malicious, right? So for example, let's go ahead and try the website we've been using all this time, right? Test php.vulnweb.com. So if I put that into the search, it's going to give back with some results like this. So here it says at least 10 detected files are embedded in this domain, but it's saying that 0 out of 88, and it tells us what those 88 companies are, right? So these are 88 different security, when it comes to cybersecurity companies, right? So for example, we see right here, this company is known as Emerging Threats, and they're run by EMSI Soft, so MC Soft, right? For example, we also have right here, Alien Vaults, right? Bitdefender, and so on and so forth, right? And they're all saying, all 88 of these are saying, we've checked this website out and it's clean. Or as we see, we get down to here, maybe they haven't actually checked this out yet, right? So then these haven't checked it out, but for all the ones above, where we see this green check mark, it's saying, yeah, that's good, right? We don't have this issue with them. So we are able to go ahead and kind of see what these security vendors are saying about that particular thing. And so therefore, what score does it come up with, right? If we have a file that we're unsure about before running it, we can be able to go ahead and put it into here, right? We can be able to run it into antivirus total, and virus total will be able to go ahead and tell us, is this recognized by these companies as malware, and so on and so forth. So this is the kind of defenses that we're talking about, right? These are the kind of things we want to be aware of as we're going over it, right? With that, are there any questions before I go ahead and pass it over to Justin so that he can show you a little bit more in depth about some of these EDR softwares or other forms of defenses that Blue Team will be working with? All right, Justin, go ahead.
Thanks, Tony. Yeah, it was a good lead into one of the tools. I was going to bring up Virus Total, and because we had started talking about here in the beginning, we started talking about these known signature-based defenses, right? So what is a signature? It could be a file name, it could be a hash, it could be a multitude of different signatures that will identify that specific process or that specific file. So on Virus Total, I use this every single day. It's an awesome application. You can use the free version, or you can sign up and get a little bit more fidelity, a little bit more tool sets inside of Virus Total. But from the top looking down, the basic free version is really all most people need. So you can search via URLs, IPs, addresses, domain, hashes. I'll show you, here's a list of free hashes. I just did a Google search for some virus share, just some hashes here. So I'm just going to copy a hash out. So this hash could be an item. It could be a zip file. It could be a Word document. We don't know yet. So I'm just going to copy that. I'm going to place it here into Virus Total. So another good thing is if you don't know the difference between an MD5 hash, a SHA-256 hash, a SHA-512 hash, if you just copy the hash into Virus Total, it will then kick back what hash value it is. And I'll show you that here right now. I'm gonna enter that in here. This is a pretty bad one. So you can see right now that this hash, let's go to details real quick. Here is the MD5 hash because that's what I looked up. I was looking for examples to show you of MD5 hashes. So here's the MD5 hash, but here's other signatures that could also be on that system. It's a SHA-1, SHA-256, and this goes as in complexity of that hash. So what is this file? It's an HTML file. You can see when it was submitted. You can see who it was submitted or some of the file names it could have been. So this is specifically virus share, but here's some other, there's a rich text file and a .bz2 file. So these are other names that are also associated with that same hash. What else can I show you on here? So shows you also where it's detected. So you may be asking, okay, that's a pretty big number. 50 of the 59 sources say this is bad. If I am looking up so
Your
what
audio
it
seems to have cut out there.
is that working now?
It's working now, but for
Hold on,
about
let me-
a few seconds there, it cut out.
Let me see if my where is it? My mic.
Let me do this microphone. Is that a little bit better? Let me use my MacBook microphone.
That sounds good.
Okay. So when you run these hashes, whatever this could be, so we did a hash here. It comes back to a HTML page. It's saying that whatever's posted by this hash could be a Trojan, could be a JavaScript dropper, could be a VBS, which is Microsoft Visual Basic script. So this is just getting you kind of an idea of, you can make your analysis saying, okay, this hash HTML is most likely a virus, Trojan, or other. That's how you would identify this one. Let's see, you can type in google.com, obviously 88 resources, nothing's bad on that, and so forth. Virus Total is really good. You can put in domains in here. I'll show you that one too. So if you use domain tools, you can also type in google.com. Why I'm showing you this is because, no, I'm not a robot. Bicycle. Is if you're looking up through VirusTotal here and you're looking at your details, a lot of this information here, your DNS records, your quad A's, all this is coming from domain tools. So it's right here for you as well. So if you want to quickly look up a domain, because there are domains out there, even domain IP addresses that will host items that should not be on there. They could host malware, they could host dark web items. Looking in domain tools, you can at least do some research on that website, that domain. And if you throw that domain also in VirusTotal, it can give you kind of a history on, google.com, when it was created, the list of IP addresses that were used, and so forth. And this is just some extra fidelity to give to you guys on how you can use those two tools. Other tools, some EDR examples of EDR tools. You're running EDR tools on like almost every system. So every system that's hooked to a domain, you should have some kind of EDR solution. There's lots of solutions out there through like CrowdStrike, FireEye, ESET has one called Protect, Palo Alto. You may see those out there, and they'll have some kind of dashboard that's usually kind of good looking. You can easily look into it, launch it. If you're a blue team member, you're going to sit there and see what's kind of looking at your network. On the red team and pen test side, knowing an EDR solution that may be implemented more on the red team side, that you'll know how you can get around that tool. You know what signatures that tool is implementing on the system. So if it's a specific application, if it's a specific file, you may be able to, like we created some payloads. So you may be able to create that same payload, but now it has a different signature, different hash, and be able to use that to test your network. So it could still be a bad C2 beacon, a command control beacon that was created, but since it doesn't match the current signature, you can get around it. As far as how they're installed, usually they're installed via script. So whenever the user account's created, it then installs on the workstation or client. You can then add additional EDR tools like on far endpoint devices. So there are some web connected cameras and printers that run a native Linux operating system where you can also throw those EDR clients. And it's a simple script command line, and it launches it and just plays right in the background. So that's a little bit on EDR. And we also talked about some signatures. What else did I have up here? We haven't gone in the Bloodhound yet. That's next. Any questions on EDR tools? VirusTotal, domain tools. VirusTotal and domain tools can be used on both the blue team and red team. So you're going to use that no matter what you do. You're going to use it all the time. What hash did you use to make your your mic silent? I don't know. We could try another one. Yeah, okay. I'm trying to think if there's anything else I want to show on there. And everyone understands the signature-based defenses or signatures, correct? It could be a file type, could be a hash, it could be a website, it could be a domain. Yeah, I think that's maybe some of the top EDR tools out there. Microsoft has their own Trellix. You'll see a lot out there in the field. Fortinet's having some issues. If you've been looking at the news lately, they're constantly getting some their endpoint tools and their firewalls are getting kind of hacked. They should sign that. I've never used sign that. Broadcom, never used that one. BlackBerry, Malwarebytes. Malwarebytes is awesome. You have that software for your computers. You can get for free. It's decent. I haven't used it in years. The Windows firewall does pretty good. Cisco Secure Endpoint, Sophos. You see that a lot out in the industrial side. You'll see a lot of people using those. So you can pretty much look up EDR tools. McAfee is another one, Fortinet, Cisco, CrowdStrike. All these companies, big companies, have their own version of it. You may see multiple versions of it in an environment as well. Okay. That's all I got for that one. Next, we'll be going into Windows domain exploitation. I'll kick it back over to Tony if you want to go over that one, or do you want me to go over that one?
I could be able to go ahead and introduce it, and then you could be able to go ahead and show them Bloodhound and stuff like that for them.
Sounds
So, yeah, definitely. So as we can be able to see right there on Justin's screen, we see with our domain exploitation, this is going back to what we were able to do with Windows, right? With Windows, we were able to go ahead and create a domain controller. That was the server that was recognized for what we were trying to do with creating user accounts, with being able to go ahead and allowing them to be able to sign in, setting up those group policies, all those kinds of stuff, right? Now, the reason that was wonderful for us and that was powerful was because that allowed one centralized location to deal with creating these accounts, right? We said that made it so that way across an entire organization, if we had that domain available, then we could be able to go ahead, go to any machine that was logged into that domain and be able to access it, be able to go ahead and sign in with the account that we had for that domain, instead of having to create an account on every individual device that we wanted them to be able to have access to, right? Now, because of these things, that also makes it very, very much a target for hackers, right? Because now, rather than having to go and look for accounts on a specific device, they know, can I be able to get the accounts that are on that domain server, right? That domain controller. If we can access that, now we have access to all the devices that are logged into this domain, because now we can be able to use that login information for the domain, right? So we point out that organizations with a large number of Windows systems and users, they use these domain controllers to manage it typically, to make it easier, right? To make one centralized location. And so a domain is a security boundary that controls all of these environments, right? All these different devices. As we pointed out, it includes the accounts, it includes groups, authentication, authorization, password policies, and so on and so forth, right? Now, we point out that this means when we sign into this domain, when we're logging onto a device, when we sign into this domain, that the settings that we have for that particular user are going to be passed down from that domain to the domain device, right? And the device controller, that server, is the one that has all that information, is responsible for all of that. And so since it's the location, it's the source of where this information is coming from, and this access and the authority and everything else, right? That's what's going to make it a juicy target, right? So we point out that domain controllers are the crown jewel of any domain environment. If we're able to compromise that server, right, that domain controller, then we own everything on the domain, which means any device connected to it, right? So most penetration tests make it a priority to try and see if they can gain access. Can they compromise the domain controller? Now, like any offensive security engagement, Windows domain exploitation includes reconnaissance, right? We need to be able to do some recon, find out information. For example, does this organization, is it one that actually uses a domain controller, or is it too small of an organization to do so, right? Then we do scanning to get an idea of their network, right? Once we know that, hey, this organization does have a domain controller there, well, let's do some scanning to get an idea of their network to figure out which device on their internal network is likely that server, or is it just something else? Is it just another device, right? Another desktop computer, for example, right? Then once we realize which device it is on their network, then we come to the exploitation, trying to be able to go ahead and compromise that device, right? Trying to compromise the domain controller. Then once we gain access, once we got a foothold, trying to do privilege escalation until we get system access, right? That system administrator. Or maybe we're not able to get it right away, but we're able to get access to a desktop that's on their network. And then once we've done that, right, we can use lateral movement to try and see, can we move from that device to another one, to another one, to another one, and then finally to that domain controller, right? However, the topic of Windows domain exploitation has its own tactics, tools, and procedures, its own TTPs, right? There are 2 tools that are instrumental when it comes to trying to compromise a domain. And so these 2 tools we see are listed here as Bloodhound. Its purpose is to map out attack paths within that Windows domain. And then Rubius, it abuses functionality within our Kerberos authentication to be able to facilitate Windows domain exploitation, right? Now, Windows is aware of this, right? Microsoft is aware of the fact that we can be able to do this to compromise the security of its domain controllers. So it's constantly trying to improve its defenses against this type of exploitation, which requires offensive security personnel to continue to keep up with the latest of what's happening in the real world that's trying to be able to take advantage of their vulnerabilities to exploit this, to gain access to this. So with that, I'm going to pass it back over to Justin so that he can be able to go ahead and show us, for example, Bloodhound, what it is, and then how we might be able to possibly use it to do this type of exploitation.
So SANS has an awesome write-up on Bloodhound, how to install it, how it's used. So it's a really cool application. And sometimes you may have Bloodhound just installed on like a container inside a hunt network, or if you're running it on your red team on a business, you may run it on a container or a workstation so that it's got full access to everything on the network. So what can Bloodhound do? It's going to collect all the Active Directory information from Windows. It's a really in-depth tool. It's going to show you where everything is on the network. And just like I said a couple days ago, where if you're on the computer, you've got somebody that installed something, you've got a good admin that's been on the computer, and he or she is done with installing the application, fixing whatever on your computer, that they log out and they actually reboot the computer, that clears all those cache credentials. That's one way of securing that device that you're on. And Bloodhound will actually see who's logged into those devices, when they were logged in, and if there's still domain credentials that are cached on each of those boxes. Not a lot of people know that. The bad guy knows that, and that's what they like to know, that these cache credentials are out there, and if I get a foothold inside that network, I might be able to get other credentials from another box. They may not need to get on a domain controller to get access to it. They may get onto a box that has domain admin credentials because maybe your IT administrator doesn't use their personal account, their user account. They're using a domain account. They're using an admin account that may have domain credentials or access. And having that authority will then own the network, right? So this is what it looks like when you log in. Can everyone see that? Let me see if I can make it a little better. View. That should be a little better. They have it running here on a Ubuntu server. You launch it just by doing your /bloodhound. So this is what it looks like when you actually log in. So you have all your domains, you have all the members of each of the different workstations. And if you've got multiple domains, multiple domain controllers, you have lines going out to different individuals, different accounts, and then you'll be able to map those directly to where they're logged in. when you click on any of these icons, it will give you some extra information of the domain it's attached to, the name of the person or the name of the computer. That's normally what it would look like when you're doing a hunt, or excuse me, not a hunt, a penetration test, or a site assessment is what sometimes it's called. Us in the military, we call them assessments. We call, it's a hunt mission or assess mission. Assess mission is going to be something that you're going to pen test. You've got your box that they've given to you, you've got your scope, and you're going to go do this pen test. 9 times out of 10 that on a pen test, again, it's a shorter period of time. You're not going to be there for hours and days and weeks and months and years. It's usually like a week or two. You're going to get some domain admin credentials that you can run within Bloodhound and these applications to get greater fidelity. Unlike where an adversary is going to try to get in and get what they can get, you generally go from the outside looking in. You can't see anything. You find some way via a phishing experiment to see if you can get some credentials. After that, you're going to get in and you're going to be inside the network running these tools as an admin. But you can see GPOs on here. You can see all these are workstations. These are individuals. The yellow, you can see like 3 people right here. These are groups. So you can drag and move all this stuff in whatever direction you want just to make it look better. And this helps you do your analysis on what the network looks like, who is it connected to. You can see like RDP connections right here, member of this group, RDP and back to this computer. So at that point, you can start pinpointing who has an open RDP connection, maybe who shouldn't have one. This is also where you can find individuals using RDP connections that they shouldn't. And it really gets that fidelity is there that you can say, oh, well, it's going to this IP address. And you're like, where is that? They may be RDPing to an offsite location that they shouldn't be. Or you'll see somebody RDPing back into the network from their home, from like a remote account to their workstation, and they shouldn't be doing that. So that's Bloodhound. Bloodhound's really cool. You can set up Bloodhound. Let's say you create a little network at your house. You got a couple of virtual machines, Windows virtual machines. You make a domain controller, make some admin accounts. You can then make you can just run Bloodhound like this on a small container or on a Ubuntu or another Linux distro and just run the application. Most of these applications all have a free trial or home use trial that you can get a key or a license for just for home use. Thank you, Henry. Yes, RDP is Remote Desktop Protocol, which is what on Windows? 3389 is the port. Another signature-based thing there. Let's see what else. They're just showing more information of how you can search through the data if you're looking to pull something out. Next thing I want to show you was, what was it? Rubius. Go away. So Rubius, you can look it up right here on GitHub or GitLab. And I'm hoping they have an example of it right here. Yeah, so this is where you can start seeing the hash technique. So there's a hash out there. You can use this for curb roasting, where you can invoke a command to trick the computer to pass a hash from a workstation or a server to a workstation and grab it. And it's all text-based. You can, again, this is another application that you can pull the Git repository and run it on a Linux machine. And the write-up here is, it's pretty in-depth, it's very good. You may have to take some time if this is something you're really interested in. Just know that there is 2 applications we're talking about here. Both are for Windows, but you can run them in Linux, but they're to scan and attack, look at stuff that's happening on a Windows network, if that makes sense. You can run these both within a container on Windows as well if you needed to. Let's see. There we go. So this is what it looks like. They're saying you run this on the C prompt, Rubius. You're exploiting. Here's the service name. And here's your base 64 encoded hash right there. The last time it was used, when it was changed, you even have a date time group of when it should be changed. So at least you know if you've grabbed this hash, it will work good until this date if it's not changed before then. Let's see, there's the user. There's even the checksum there as well, MD5 hash. So it's pretty in depth. You may have like 1 or 2 people on your team that will be real big into using Rubius. We've had this conversation earlier in the class. You know, when you're on this pen test, you're on this hunt, what are you doing, right? Is the same person doing the same thing over and over again? Sometimes yes. Sometimes it's also splitting up the techniques and the tools so that I did this last time, you're going to do it this time, just to get better experience and knowledge all the way around. I think those are only 2 tools we were talking about. Yes. Any questions on those 2 tools? Besides on a pen test and a red team, they use them almost daily. Not see anything in chat either. Okay, I'll kick it back over to you, Tony.
All right. So we're going to see then, let me go ahead and share my screen, that our second to last section for today, and so the last one is going to be the one that takes the most, right? In this second to last one, we're going to talk about cloud computing exploitation. So far, all the type of exploitations that we've been doing, we've been assuming that you've been able to go ahead and access an actual device, right? Something that's actually physically there on their networks, and that we're trying to be able to go ahead and be able to gain that unauthorized access. But what if, similar to what we've been doing for our own class, right? What if their device isn't necessarily one that's physically there for them, right? What if they're running this virtually through the cloud or something similar, right? So if they're running their stuff in the cloud, well, then that's where cloud computing comes into play. And we need to be able to understand how cloud computing works, at least in a little bit. How is it different than our regular devices, to be able to go ahead and exploit those as well. So if they're running their stuff, if they're running their software, or if they're running their machine through the cloud as a service, then how can we be able to exploit those, right? So we see more and more environments are moving towards cloud computing, right? We're seeing this everywhere. We saw this especially in the past decade with video streaming services, right? It used to be you had to be able to have a device, you had to be able to go ahead and get something like a Blu-ray or a DVD, be able to play that video, and then they went to streaming, right? So now you don't need that anymore. You don't need that Blu-ray device. You don't need the other thing. You stream it from them through the cloud, right? Now they're also trying to do it with video games, right? More and more, especially Microsoft. They have that you can be able to do cloud gaming, right? Where you don't need to buy a console, you don't need to be able to have that hardware. You can be able to go ahead and just sign up for the service, and it's all done through the cloud. And so the same thing is happening with our typical everyday computers, right? So more and more, as we gain more advancements in our speed for our networks, right, for our internet, and our capabilities for the devices that we can be able to do things through for cloud services, right? All of that is adding up that more and more. Why am I going to buy more devices and then have to worry about their maintenance and upkeep and then their security and all that other stuff when I can be able to just rent cloud computing from somewhere like Amazon or Microsoft, right? And they are the ones that now have to deal with that upkeep. They are the ones that have to worry about being able to go ahead and do the updates, about having to be able to go ahead and maintain things, right? And so on and so forth. And so that kind of helps out with a lot of the day-to-day costs, right? A lot of the stuff that they have to worry about there, including security, right? I don't have to worry about security for my devices if I'm doing it as a cloud computing environment, because whoever I'm getting that cloud computing environment from, they're the ones that have to then be able to also be responsible for securing those devices, right? So that means that only having knowledge of on-premises exploitation is no longer sufficient, right? We got to be able to know how these things in the cloud can be exploited, so that way we could also be able to go ahead and defend against them, right? So testing cloud infrastructure is now a more and more important part of penetration testing and red teaming, right? We got to be able to see if we understand how to exploit them, so that way we can be able to go ahead and test those defenses, right? Make sure that they're being properly secured, so that way we can be able to go ahead and let them know if it's not, and how we were able to get into it, right? So cloud exploitation requires an understanding of various cloud environments and the various services that they offer within them. Now, there are three main cloud providers. Now, of course, there's a lot more than just these three, right? But these are the big three. These are the ones that are going to be having the majority of people that, hey, if you need cloud computing, you're going to go to one of these, right? So in your cybersecurity career, you'll see that the first one we're going to address is AWS, or what is known as Amazon Web Services. Now, this holds a large part of the market, right? It's a lot of the market share of cloud computing, and its services are used by a large number of organizations worldwide. And in some cases, it's also even used by government entities, right? The next one we're going to point out is Microsoft Azure. This controls a large share of the global cloud computing space as well. And it's typically used by private entities and government entities. And then we're going to see the third one we're going to point out. And so that kind of rounds out the big three. This is the cloud, Google Cloud Platform, or GCP. Now, it's not as large as the other two, but it is, because it's Google, right? Still used by select organizations. Now, regardless of which of these platforms that are being used, there are common concepts that exist across all of them, right? So similar to what we kind of saw when we're exploiting on-premises devices, right? Whether it was Linux, or whether it was Windows, or whether it was Mac, there's concepts that are similar to all of them, right? Networking concepts, for example, of being able to scan and checking a port to see if it's open. Can we be able to access that port? Can we be able to send information there? Can we be able to exploit it? That was true regardless of what operating system it was, right? Similar thing here. Regardless of our cloud computing platform, there are going to be some common things to all of them that we can be able to use for exploitation. So what are some of these concepts? Well, the first one is virtual servers, right? These can be thought of as regular servers, only they're being hosted in the cloud. Now, virtual servers can share vulnerabilities, so they can be able to have some of the same weaknesses as on-premises servers, such as a vulnerable OS running that server, maybe an unpatched vulnerability. So maybe they're running a software or a service that should have been patched and it isn't, right? Maybe it's just a simple thing as a weak password, right? Maybe they only have 6 characters when they really should be having more than 8, right? Something like that. So these same ways of being able to go ahead and access our regular servers can still be done for a virtual server, right? The other thing is our security groups. This can be thought of as host-based firewalls. Security groups dictate what can and can't access the various ports that are there for a virtual server. Next, access keys. This is to allow programmatic access to the cloud environment. Compromising an access key allows you to interact with that cloud environment, right? So it's pretty much, how do we access that cloud? How do we gain entry into that environment? If we're able to gain that access key, now we can log into that environment and we can start doing whatever we want with it, right? But this requires knowledge of a scripting language such as Python or PowerShell and so on. And then finally, there's storage, right? Every single one of these is going to have some form of storage where sensitive data can be stored, right? We're going to see, for example, in AWS, S3 buckets are an example of this, right? It's where is it storing that data for that environment. And so therefore, if we can be able to access this, if we can be able to go ahead and gain access to their storage, we can be able to then lift that sensitive data and be able to do stuff with it, right? We can either, one, if it's passwords, that can give us access to their different accounts, right? Or if it's something a little bit more sensitive, like maybe it's information, maybe let's say financial information for that business, then maybe we can be able to use it to then do whatever we want with that financial information, right? Or it could be that maybe we're going to do some ransomware. That's pretty common nowadays, right? Where we're able to gain access to sensitive information of an organization, and rather than doing something else with it, we encrypt it for ransomware, right? Saying, hey, if you want to be able to have access to your sensitive data, pay us so much and we'll give you the encryption key. Otherwise, you're locked out of it permanently, right? So again, these are different key areas that, just like our on-premises environments, they're common to all of our cloud environments. And so we can be able to target these areas. We can be able to try and be able to gain entry or try to compromise it through these different parts. Now, cloud computing is still in its infancy as far as how advanced it's getting, how much people are using it. And so therefore, it's barely starting to become really a viable target, right? One that malicious actors really want to be able to go towards. So we are in even more our infancy of seeing this type of cloud computing exploitation, right? That means that there's going to be new vulnerabilities, new attack paths, new ways that we can be able to go ahead and exploit or compromise these environments as we go along. So this is going to be something that, as we move forward, we're going to have to kind of keep on informing ourselves, right? As Justin and as you know, Sean, when we first started the bootcamp, have pointed out in the past, when it comes to cybersecurity, it is always going to be a thing of constant learning, right? Of constantly taking a look at what's happening, what's being done, what's being used, what are new exploits, what are new weaknesses. And that's what we're kind of pointing out right here, right? With cloud computing is such a new field, something that's just barely becoming more and more widely used, that we can only show so much right now, but know that moving forward, this is going to be something that we're going to have to stay on top of, right? There's always going to be new ways, new vulnerabilities, new ways of attack that are going to be coming out for this, just because of, we don't know that yet because it's in its infancy, it's brand new. But moving forward, they're going to be discovered, and that we have to be prepared for that, right? So we're going to see that in a little bit, when Justin is ready, he's going to go ahead and show us a few of the different things that we should be aware of, or a few different areas that we can be able to go ahead and kind of take a look at this cloud computing, the type of exploitations, the type of software that might be used that's similar to the ones we saw already, right? For EDR, for example, but how this would be more geared towards the cloud rather than on premises. And then once we've gone through that, we'll get into our last section with, finally, now that we see how we can be able to go ahead and kind of piece all these things together, how we can be able to go ahead and perform that penetration test or do a red team for an organization, the most important part, writing up the report at the end, right? So that way we can be able to go ahead and demonstrate to Blue Team or to the organization that hired us for that penetration test, what are they weak in, how we were able to compromise them or exploit them, and then what should they do to kind of beef up their security, right? So that's the most important part when it comes to that report writing. So with that, I'm going to go ahead and pass it over to Justin, so that way if he has anything to show you for that cloud computing, he can be able to go ahead and show you those tools and show you that information.
Like anybody in cyber, we always have a lot of notes. If you just saw me, I just moved back on my wall over here. I've got like all my documentation for every course I've ever taken. I got tons of notes. So AWS bucket scanning, there's a lot of tools out there. I don't have the exact one that I've played with, but here's another one I just found. GitHub and GitLab, there's lots of people with a lot of knowledge out there. And why reinvent the wheel when somebody's already created something? And good thing about Git is it's all open source, meaning somebody's created, you can see the source code, you can see what's going on, and you can take that and then you can branch it off, you can fork it off, and you can modify it the way you want it to do, right? You may not like how they're outputting their files, you may want it to do in a different way. So this S3 scanner, if anybody uses AWS and the way the buckets are, public facing, private, secure, you can use this free tool right here, S3 scanner, and you would scan and you would point it to a file, and the output, the name's text file, and this is everything it would output. Now this is an example that they're using, but you may want to scan a certain AWS directory or an IP address for the AWS. And when you point it there, you can essentially see how many buckets are even open. Buckets meaning those pages, because that's what Amazon uses as their file structure. They call them buckets. So, bucket exists is one, bucket does not exist. And there should be like bucket exists, but there's no access. So you can at least detect if there's anything there. Azure is the same similar way, and Google Cloud has their own version of scanning their bucket. So let's see if I can do a GCP scanning example. That may not be it. That's on their platform, they have it. But you can do this all right from the command prompt. There's tools out there. You probably have to look through Git to find one. Just depending on what your strong suit is. I know a couple of you had asked, should we even try getting any kind of certificates in cloud computing? I say yes, because it is an avenue. Not saying you need all three, but right now, whichever one you like better, if you're more of an Azure person, AWS, or you may be more into the Google Cloud. There's a lot of good that can come out of understanding how each of these platforms operate. Some of these certificates don't even cost anything. A couple times a year, Google will put on, usually around the holidays, a kind of like a jump start on all their certifications. You sign up with a free account, you can get done as much as you can in 30 days. Whatever you get completed in those 30 days, you get those certificates. But if you want to continue, you would then be jumped right into the subscription fee. But again, they're not going to take any of them away from you. They've got a cloud one, they've got GCP fundamentals and so many other ones. But something to think about if you've got time, if you would like to do something like that. Yeah, that's all I have for cloud computing, because it's always evolving. Each platform has their own kind of SIM dashboard set up to protect their platform. Like I just showed you here on this Google one, they've got their own dashboard set up that you can help set up or configure the way the security is on GCP. Azure has the same similar settings panel. And then AWS has a lot of default stuff, and then you can modify it with config files. What else? Yeah. The last thing is report writing. So you've done everything on your network, right? You've gone through, you've done your pen tests, you've been recording your information along the way, and you're like, okay, now I've got to put everything together and have it make sense. Explain how we got to point A to point B. This attack path right here is real big. So they gave us a scope, right? They gave us, you're allowed to access these servers, this IP range, this subdomain. That's all you have access to. So you're gonna have to write out how we discovered that printer, right? It may have been through a leaked credential, whatever. However you got to discovering anything, that's how you're gonna have to find those. One of the let's say example, my last mission I was on, we found a bunch of the cameras in the warehouses were all open. They all had default credentials. During our Nmap scan, we saw, oh, look at all these weird, I think they were Hike Vision, and there's another camera brand out there that was very common and cheap. We looked at a couple cameras. We put up those IP addresses. We went to the IP address. We saw that they were a camera. We looked up the default credentials. Default credentials were admin or admin password. And we typed them in. we saw the camera, we took a screenshot to show that we actually were able to penetrate that, to view it. And then we had to write up how we did it. Mmap to identify an IP address, which was labeled as a hike vision camera, which then was labeled to us going to Google and finding what the default credentials were, going back to the website, typing them in, and we accessed it. So the suggestion remediation would be, after you install something, change the password. That's all written out in those reports. So I just went into that, what the vulnerability exploitation details were. So when you discover these things, when you're doing your mmap scans, you're finding these devices, and you may have seen something on a regular research. You're looking at cybersecurity news, and you're like, oh, there's a new vulnerability in a Node.js server. There's a new vulnerability in an Apache server. And then you see these things on those networks during your scans and through your penetration test, or during your red team actions. Then you bring these items to light. So then you can place this information into the report form. And then you'll line out all these specific things, like what's a vulnerability, how likely is it? We've got CVE scores. Did we ever look those up? Let's do CVE for.
So I know we did briefly mention them, but we didn't go into detail about the CVE scores. I think that in Blue Team, we'll probably go a lot more into detail, but it's definitely something that they should know.
Right, so I just put in CVE for hike vision camera. Here's all the CVEs here. So it's there's your vulnerability, here's the year, here's the number. And if any of those cameras this was related to, we would then copy and paste these, or just make a link. Could be in a spreadsheet or whatnot, depends on how you want to do your report. There's no right or wrong way to do the reports, as you will go and do some report research here shortly. I don't want to spoil the fun, because I was going to pull up a report, but we are going to let you all go through and do some password configuration file issue on these specific version of cameras with these firmwares. So that was back in 2017. That's a little bit outdated, but there's only one for this year. And that's when they're using the SAN cluster. So there's an ability to obtain the admin password. Says it right there. Then after, so impact on that camera would be somebody can steal the camera. So depending on if that camera's segregated on the network, it may not be a big impact to the network. Maybe they can just spy on, we took a screenshot of one of the guys running around with a forklift with a drum on the front of it and spinning in circles and seeing how long it would take before the barrel would fall off. We thought it was really funny because we caught him doing that. So we did a screenshot and sent it back. That was one of the things we put in the report. Like one of the remediation was like maybe give people more forklift training so that they wouldn't be driving around recklessly in the middle of the warehouse. But you can kind of have fun with these things too, depending on who your customer is, but what the impact is on that vulnerability. So your front page on these documents, as you're going to see here, you're going to have where what the customer was, right? Let's say it's a specific company, and then it's going to say the dates there, who actually did the penetration test, list of users that accessed the network. Then your executive summary says, here's what we found. This is what we saw over the course of X days, X weeks. And then you're going to go into the different attack paths that went on, vulnerabilities that you found on the network, impacts, and then listing out all those tools that were used. And some of those tools may be covered in earlier in those attack paths and vulnerabilities, and how those vulnerabilities were discovered because of those tools that were used. So you're just going to line that all out so that the customer knows what you used. Some tools, some of those tools aren't free and open source. So Another thing is, as the professional, you're going to go in there and say, like, yes, anybody can get access to these tools, but it takes a lot of user experience, a lot of training to be very proficient in these tools, because you will see customers out there be like, oh, well, our IT folks can do this. You're just running Bloodhound and Rubius, and you're just throwing some new EDR tools on some of these boxes. We're going to do it next time by ourselves. They don't, and we emphasize on, that's awesome. If you have the tools, the knowledge, the training, the experience to know what you're looking at and know what you're looking for, then of course you can do that. Not saying you can't right now. In the future, you probably could. So that's why we throw those tools out there, because there may be some companies that want to implement those things. The report is why the organization decided to have the engagement happen in the first place. So they wanted you to come out there and do the engagement with them. They wanted you to come out there and dive into their network and see what was going on. So they're looking for this report. So you want to be very thorough. You don't want to leave out any details, and you want to make sure that they are happy with what you did, because, God forbid that you do all this stuff and they're like, thanks for being out here. It doesn't look like you did much. You kind of wasted our time. You don't want that to happen. You want them to be happy with the report. You want them to, have that engagement with you again for, what? We just upgraded our system. We want you guys to come back out and do the same thing you just did. Can you do it again for me? That's the kind of engagement in the cyber community, in this realm, you want. You don't want to burn bridges. You want to establish those good relationships, establish those good handshakes, because when something happens, you want them to come back and say, we want your help, because that's what you're out there for. Penetration tests and red teaming are good things. It's good people doing good things on reputable networks to try to find gaps and vulnerabilities. So our exercise that we will kick you all out for the next 30 minutes or so, we want you to review some sample penetration test reports. We've got I believe we have a link that we will send to you. Another one is, I'm sharing my screen, so let's see. You can look up just like penetration test reports. I'll give you this one in the chat, but this isn't the only one. There's tons of them out there. So what we want you to do, and then Tony, you can expand too if we've got something additional for them. We want you to review the reports. We want you to grab a report or two within your group and come back to us in 30 minutes and explain what was in the report, how it was formatted, and maybe something you like or didn't like on the report. And let's see what else. Maybe something you learned or saw was interesting within that report. Could be a vulnerability that they found, could be how they used an attack method, maybe a specific tool that they used that you didn't realize it would return those type of results. Let me type that out just so we have it in here. So I said review reports, feedback on something you liked or was interesting. Something you learned. And was that it? I think that was it. Oh, how it was formatted. Did you like it or not? All right. Anything else, Tony? Did I miss anything?
No, I think that pretty much covers it.
Cool. You can run out in the breakout rooms. We're gonna do pretty large breakout rooms for this one. Oh, we already got them done. Cool, awesome. And there they're off.
All right, I'll go ahead and jump into the staff room.
The audit scope covered the Nitro key storage firmware available. It's also available on GitHub and the Nitro key app. So the audit team identified 10 vulnerabilities and 4 general weaknesses, but none of these were deemed critical. 4 of them were tagged as high severity, as they could potentially compromise the Nitro key threat model used for the audit. I can go over some of the vulnerabilities. The OTP commands could be used without authorization. OTP could be unlocked by replacing the smart card. The security bit was bound to firmware updates. An admin check could be bypassed by resetting the smart card. And it also included the team's recommendations for each identified vulnerability. So my critique of the report.
Think we might have lost you on audio. Did anybody else hear him? Okay.
However, the report might be challenging to understand for readers with limited knowledge of cybersecurity due to its technical language, as I said previously, and use of a lot of jargon. I wouldn't say jargon, I'll say abbreviations and a lot of terminology. A lot of audiences may not know the definition of a lot of the terms. It would also have been useful to have at least a section summarizing the overall impact of vulnerabilities on the system security. It was missing that, and a clear explanation of the Nitro key threat model. And that was the first report. Do I have time for the second one? Oh, okay.
Yeah, go
Well,
ahead.
the second one we looked at is called Bishop Fox Assessment Report. In this report, the report details a security assessment of the Winston privacy device. Again, the firmware version 1.5.4, performed by Bishop Fox. During their research, the team identified a total of 7 findings with varying degrees of risk severity, 1 being critical, 4 being high, 1 medium, and 1 informational. The most critical vulnerabilities involve command injection, which allows system commands to be executed on the device. They also found that the device's API lacked included insecure hardware access controls and an undocumented SSH service. Recommendations were provided for each finding, unlike the other report, typically involving the enforcement of stricter security measures. My critique of the report was the format of the report is clear and professional, just like the first report, starting with an overview and providing detailed descriptions of each identified issue. It follows a logical structure, which was easy to follow. It presented the problem, the details, and how it was discovered, and recommended actions to resolve it. However, the readability of the report could be improved with more visual aids in this one. I guess the lack of cybersecurity knowledge at my end was hard for me to visualize what they were actually talking about, such as diagrams or flowcharts of some sort, to at least visually depict the vulnerabilities and how they could be exploited. Additionally, while the report does provide like URLs, uniform resources, locators for the further reading, it would be helpful to offer more immediate bite-sized explanations of the technical terms. Report is who you're writing it to. and who's the audience. So I couldn't really figure out with the first report. I think it was really technical, so it was geared towards maybe your peers and maybe your CISO or something like that, someone higher up at that level. The second report was more geared to, like, I would say, your executives who just need a bullet-sized format of what's going on in layman's terms.
Yeah, and you got to think also some of these reports that are out there, they may have been the first report or they may be a consecutive or ongoing report. So it may have been like really detailed the first time and then they've expanded on, like, the acronym soup is still out there and you may not know all those acronyms, but it might have been covered in the previous report. Reports are supposed to be standalone. They're supposed to be able to, at any point, be able to pick up the report and start going through it and understand everything. But it may have not been in that same aspect. They may have just not covered everything like they did in previous reports. But thank you for sharing. Does anybody else want to share a report or two that they went over? Go ahead, John.
Hey guys, I'll share my screen and give you an idea of the report that we looked at. Okay, so we looked at this report prepared by FireEye for Accelerion, which was scoped to just one application that they do. They're a file transfer company. I'll kind of do a quick overview and I'll tell you what we liked and didn't like about it. So in general, it was really all organized. There's an executive summary that sort of talks about what it was they did. And then underneath that summary, there's like a little more broad summary that goes in a little more depth than the executive summary. Then they talk about their project scope, which in this case, it was a really small project scope. It was just to verify 2 patches that had been put in place in response to 2 different attacks that had happened over the course of previous 2 years. And then here, I thought it was really nice. They, under the technical details, they listed a timeline of everything that happened to sort of help put the report and pen testing execution within a greater context. So here, just really briefly, you can see like the first time they realized there was an exploit was here in 2020. And then a year later, there was another separate one. And then after they kind of did that, they very soon realized that they should hire a third-party company to do an assessment, seeing as their first patch didn't prevent a second attack. And then here it says like what the kind of objective completed was, which they verified the 2 patches, and they also found a couple of additional things. And then here it talks about sort of their methodology, like what they reviewed, a summary of the details of how the attack was carried out in December and in January, some commonalities between both attacks. And then they listed indicators of compromise to help detect future exploits of these 2 previous methodologies, or attack paths, I guess is the proper term, both in December and for January. And then here it talks about how they validated this company's patch remediation and methodology they used, and then their methodology for testing for additional vulnerabilities. And then it kind of summarizes what they found here, and then et cetera, that's the end. So overall, we thought it was a super well-written and easy to read report, even though it was geared towards more technically inclined readers. The way that they put it, it's like, assuming that you are in the field of cybersecurity, even us who have only been in this course for so long, were able to pick up a lot of things that they did. And we identified some of the different tools that they used were tools that we used in the class, such as Burp Suite and methodologies like cross-site scripting they use in command line injection. So we were able to kind of follow along with what they did. And things that we learned here, sorry, there's a fly. We learned that in the timeline, Joel noticed that as these exploits happened, they started one way to mitigate that they decided to do that might have been a good idea to do in the beginning, possibly, was to increase the frequency of their detection. So here, part of their mitigation was to increase frequency here from once per day to once per hour. And then after they got exploited again, they increased that frequency to every 10 minutes. And Joel's observation was maybe doing that initially would have helped them catch both of these earlier and maybe respond more quickly than over the course of 2 years. And then another thing that we learned was I thought it was really interesting to see them list out the IOCs like this, because I've heard of IOCs discussed, but I've never seen like exactly what it would look like to kind of present those indicators to a client. And I could see through this presentation, like these are all things they could set up watches for and schedule lookouts on their systems from different standpoints to see if that system was compromised by these attacks. Yeah, overall, we really liked it. I guess if there was anything to improve, maybe a glossary for terms that maybe not be as common, like internal terms, just to make sure whoever's reading this could follow along with everything.
Yeah, this is really interesting, having them call out the temporary directories. So that could be another signature you may want to add to your either your antivirus software or your EDR on the machine. Even logging, like anytime a temp directory is created, modified, or added to, deleted, that may be something you may want to signal a log being printed for, because that just could be an attack path for that individual, that group that uses, we got DF as one of them, .out, .scr, just something to think about. As you're seeing these, it may help you then re-engage a new customer. Like there's avenues that you may have not looked at. There's avenues that may go on the next time you go on that engagement, saying, hey, we're going to really focus on these temporary directories. It could be a new technique for an adversary that's attacking the fuel and oil and gas industry. They constantly go in the temp directories because they're not always secure and no one's ever looking there. So that's good stuff. I really appreciate you sharing that report with us.
Yeah, no worries. Thanks.
Anyone else? All right, I want to show you a couple. I'll show you one of the reports that I pulled up. Let me share my screen. This one. So one of the reports I pulled up was this one from Bytes Pen Testing. So it was really cool that this is an 87-page report. Some may be longer, some may be shorter. Client was obviously screened out. Excuse me. So the client was removed for multitude of reasons. Where's my camera? Move that up there. So in this report, we got our first one. There was all the hosts that were vulnerable. All of them that had vulnerabilities to them. So it's pretty cool that this one came out through just these, it's 9 or 10 hosts here. They put the IP addresses in, and then the pages that these hosts have vulnerabilities on. There's your definitions. You guys were asking about this earlier. It'd be nice to have some kind of definitions in here. This one did. So the introduction was the pen test is to help the administrator of the company secure the network. Although the report contains technical terms, it has been written so that non-technical initiated reader has basic knowledge of computing would understand this. So they said, like layman's terms, we're going to put this out there for you, and kind of redefine some of those definitions of how they used them. These definitions may not be the correct ones, but it's how in this report they're used. motivation of the attacker, intro. Let's go into, okay, so here's your summary. So on this IP address, there's nothing critical. There was too high, too medium, and too low. They give a synopsis, description, is possible to obtain default community names of the SNMP server. Some places SNMP is not enabled because you can scan the network and start seeing those devices. By default, a lot of people will disable those, but SNMP, like if you think plug and play back in the day, if you plug in your, like I've got a Sonos system at my house with those internet connected speakers, SNMP is enabled by default. So whenever you go into Windows and you browse network, you will see all the different Sonos speakers in the house. Yes, you can kind of go into the configuration of those speakers and disable it. I really don't care, but I turn off SNMP like on my network attached storage devices because I don't want that shared, right? I don't want somebody coming and connecting with my guest Wi-Fi and being able to click on network and see my shared devices in the house. So this agent, SNMP agent, was enabled, and they said you can get default names from it. There's your risk factors. So they did this by almost every IP address that came up in the report. So, talked about the low ones. So this one's like one of those like bluff reports. We did the scan on your network. Here's all the IP addresses that we found stuff on, and they broke down with all the CVEs, the what they saw, some technical information, and then they gave a solution to, like, hey, this is what we would do to fix it. Because when you go out as a pen tester or a red teamer, you may not be the ones able to touch that network. You may be scanning it, you may be doing all of your reconnaissance on the network, but you're not the one there to fix the network. You're there to provide them the report with the information so that the ITs can go back with your suggestions, your company's suggestions, your team's suggestions to remediate those gaps on their network. So this is a pretty cool report. I like how it was just bluff to the point. You can go down to the IP address, from the first page here. If you want to say, well, I'm gonna look at page, this IP address here, 168.0.251. I know that this is a system, maybe it's a NetApp, maybe it's a server. I'm gonna go right to page 62 and start looking at it. So straight to the point with this one. Every pen test report is different, as you've all seen that. We've gone through 4 of them right now. I did want to bring up one thing on VirusTotal. So remember, if you are uploading anything to VirusTotal, you may see a signature on a system, okay? It may be a hash, it may be a file, and it's just more for awareness. If you upload a file to VirusTotal, it's now in VirusTotal. It's seen everywhere. Anytime everyone else tries to look at that same file, like one we just saw was XD, I think it was. Now XD is going to be in VirusTotal forever. There are some adversaries out there that like to put files out there to see if they're even detected. So they may put a file on a system, it could be called XD in the temporary directory, and they're watching VirusTotal to see if they were ever discovered. So you uploading XD as a possible file, it comes back clean, nobody's ever looked at it before. That adversary may be watching VirusTotal because this is open source. You don't need to pay for it. It may trigger them to, oh, okay, well, I was caught there. I'm going to move my tactics to a different area. Just something to think about. Just something like to kind of kind of digest a little bit of, should you use it in that way? Yes, you can. But just keep in mind that as an intelligence standpoint on it, the adversary may be watching to see if one of their new tactics and techniques, if they were actually discovered. Does that make sense? That kind of a not a way of encouraging you not to use it, just another situational awareness of while you're using this tool, keep in mind that adversary uses the same tool. Just like everything else we're using. Just like Mimikatz, just like everything else we've used in this course. And I'm glad that the last report that we brought up, that you saw a lot of the same tools and techniques discussed in that report. We also discussed in this class, showing you that you're still on the right path of learning the right things that are covered in these reports from like real world experiences. Should VNC server clients not be used nowadays, or is it still considered safe? I don't see any issues with VNC server clients. I don't see any issues with RDP as long as they are allowed on the network. Most of the time there may not be a reason for remote desktoping to another client, only for like IT administrators will do it because they want to remote into something and change a configuration. But 9 times out of 10, everyone's got like laptops and you're just logging in locally. Usually you would only be using VNC and RDP to go to remotely to a server or like a jump box to get to another server or workstation for configuration. But I personally discourage it because like get out on your feet, go ahead and walk to the other building and log in locally, just in case something happens, that connection goes down, you have to walk there anyways to log back into that workstation. You can do it. It's all within the policy of that company. So if the company allows it, great. There's nothing wrong with using it, and there's nothing wrong with denying it and making those admins actually walk over and see their equipment, make sure it's working, make sure you can clean any dust off the filters and whatnot while they're over there as well. Any other great questions? There's a question for Tony in there. If I don't know if you answered it, Tony, or you want to answer it for Antonino.
I was typing it up right now. Pretty much I was going to say that when it comes to that aspect, it really is that there's a lot of overlap between the different positions, right? Because you could be able to go ahead and be part of an office that's coming up with these procedures or these policies, but then who's enforcing them, right? Who's the one who's making sure that, hey, if we say that you had to be able to go ahead and change your password every so often, that that's actually happening, right? Are we making that an automatic thing, that it's going to go ahead and be part of the software, that every so often it expires and then you're being forced to be able to do it? Or is it just being said like, hey, you probably should be able to go ahead and do it every so often, and then it's left up to you to be able to go ahead and do it, right? So within the realm of the GRC analysts or public managers or project managers, a lot of it is going to be overlap between there, right? Where they can be able to go ahead and say like, this is how we want things done, and then it's going to be up to those managers to enforce that, to make sure that it's happening, or to set something in place that's going to make it automatic, right? It really depends on where you're working, how big of a company is it, can they be able to actually have stuff just focused on that, right? Or is it going to be shared, sort of like a shared responsibility, even though technically we may not have, let's say, a project management office or something like that, but that maybe that position still requires that. And then still making sure that somebody somewhere, if this is something that was decided upon, is making sure that it's getting enforced, right? It's not going to be just like one person or just like one area that's making that happen. Go ahead.
I kind of asked that question. I previewed it to, when you're drafting a report of some sort and you stated that a template is usually used, depending what format is being used. Usually when there's a PMO in a business, I was thinking there should be a cybersecurity PMO, where there's a repository of knowledge and help and assistance, where they help you, give you what templates you need, and they kind of help you move forward, whatever knowledge or assistance you may need to draft that report. Is there something similar to that?
So each company is going to be a little bit different, but yeah, if you're in a big company, right, then they're going to have that there. They're going to have that repository of like, this is what we use. This is the standard. These are our templates. This is how you fill it out. And then if you have any questions, that you can be able to go to them and be able to ask them. So yeah, it just really depends on where you're working, how big of a company they are, and whether they have the resources for that. Now, I do know, I don't know if this question was addressed earlier, but I believe Henry had asked, is it possible for a compromised or infected EC2/VM instance from one company to be able to cross-infect another company's VM if they shared the same physical cloud host?
Good question. I believe on the all three of the cloud providers we talked about, they're all still segregated. So is there a way? Possibly. Do I know of a way? No. When we were talking about Azure, I did want to say that I'm looking through my notes here again on buckets and credentials. So we were showing you that one application. You're going to be inside of the network, or there's going to be cache credentials on the system when you're actually scanning those buckets. Publicly scanning a bucket, unless you have a direct path to it, you're not going to see it. You'll have to actually, there's an application that you can download on Linux called AWS, is just the application. You can use that to scan buckets. And there's probably a Git page for it that will allow you to see exactly how that tool works, but it's, I wish I had, I can't get the application on the Mac here, but on a Linux machine, you could definitely look it up. There's one for Azure as well, but I don't have my notes here for Azure. Just trying to give you guys some extra in-depth knowledge on some of this stuff. Any other questions or stuff you want us to, we've still got a little bit more time. If there's anything that we've gone through over the last, this whole module on Red Team that you would like us to relook at, revisit, was there any labs anyone had any issues with that you want us to let you share your screen and we can kind of walk through it and make sure we're all on the same page?
I just had a quick question and sort of an
Mhm.
observation. So during the breakout rooms, I was looking over a couple of different, or we were looking over a couple of different reports. Specifically, we were comparing the NASA report on the intrusion into the Jet Propulsion Lab networks. That was a very verbiage heavy and very in depth, and it seemed like the template for government organizations like that, or their target audiences, they're not C-suite people, right? They're actual like technical professionals. So I guess the observation was that if you're talking to C-suite professionals, it has to be clear and concise and to the point, right? Very similar to a news article, you know? Most people don't read to the bottom, so you want like the major point of the article to be at the top, right? But I found a different report. It was a Tesla penetration report on the Model 3 networks. I just wanted to show you real quick and ask if this is more of a standard template. Let me share my screen.
I don't think there are any standard and templates. Each company may have their own thing, but remember, these reports are for that customer. They're not usually for public release and dissemination. So even though some of these reports have been scrubbed, you kind of like had the owners of the reports, whether the customer or the producer of the report, may scrub out those names of those companies, those units that they were at. So just keep that in mind too, that they're not generally a public report. They scrub them to put them out for public view as examples. CrowdStrike, FireEye, they'll put those reports out. They're big companies. FireEye is now Mandiant, which is Google. Google bought FireEye and they renamed them Mandiant. So, it's kind of like a brag, like, hey, these are kind of reports I get to you. We can get real technical, we can not get technical. So it's kind of like showing the shopping list to different people before they want to actually hire those individuals to come on site. But yeah, feel free to go and share that article you have, Robbie.
Sure. Yeah, it was just another quick observation. I noticed that in this one, let's see, yeah. Can you guys see my screen?
Yeah, we got it.
Yeah, in this one, they chose to pen test 4 different attack vectors, and compared to the NASA report, which is very in depth on the context heavy on the history of the JBL lab and its role with Caltech, and it was kind of like reading a novel. So as opposed to this, where it's just, here's what we did. We attacked 4 different vectors. Here's how we did it. Here were the results. So yeah, that was really my observation, something I want to ask about, like the difference between pen testing for, Homeland Security or NASA or Tesla, right? It seems like they're very different templates. One is more, I guess, direct is the way to put it.
Yeah.
So yeah,
And also this is one from Jessica M. Sargent. So this is a little markdown
Mhm.
that this person had put on here. So it was a summary. Maybe they were on this pen test and they just quickly gathered some information that they want to put down to explain what happened on this pen test. There's nothing wrong about this. They also might have got the information third party, secondhand, and put it out there as well. Or
right.
whatever the
Okay.
customer wants. If a customer would just want something like this, it's not going to benefit them down the road. They want to know like the full scope, what was looked at, because if the second time around that they ask for the same kind of report, but they give the same information back, the next group of pen testers will be like, well, that's what you wanted. There's some IP addresses in there. They ping that local IP address. It's a 192, so it's local. How would they get a local IP address? Maybe the car was connected to Wi-Fi on somebody's network, and that's how they pinged it. Not to say it wasn't a public IP address, because we know Tesla and Ford and Chevy and anything that has a wireless connectivity that you can remotely unlock and lock it will have a public IP address, usually done by cellular, and we may or may not know that IP address. But they just did it via locally. What would be the attack vector if it was from a public IP address, not a local one? That's something that's not covered in here.
Right.
So it's just like, as you're reading this stuff, you're like, yeah, there's some gaps.
Yeah, this wouldn't suffice.
Maybe those gaps,
sounds like.
maybe there weren't any gaps, and it just wasn't divulged in the report.
Yeah, I mean, overall, the conclusion was that they weren't able to penetrate even in all 4 vectors. But yeah, okay, that makes sense. This sounds like it wouldn't suffice for a standard report anyways.
Yeah, I'm
Cool.
thinking on something like somebody trying to pen test a Tesla, right? There's probably numerous amounts of security keys going back and forth that are encrypted, and that's why they couldn't get into it. Probably the same way
Yeah.
with other vehicles as well. They're going to have encrypted tunnels. They're talking back and forth with security keys that may be salted. Yeah, they're going to make them as secure as they can, because if you could easily hack one of those vehicles, obviously
Yeah,
the
right.
manufacturer wants to know that, but it also, like, if that gets out to the general public, they're like, yeah, I may not want to buy this kind of vehicle.
Yeah.
For security reasons.
Right. Yeah. Okay. Thank you.
Excellent feedback. What else can we go over? Because the next 2 days we've got career simulation and career prep. So we've got some research to do, and you kind of be on your own a little bit over Wednesday and Thursday this week. So if there's anything we want to go over, we can try to run through those things now. We're hoping to get the rest of the a grading done, so we can pass that all by Wednesday. That's on our chopping block to get done over the next 48 hours. So all of you have your grades if you don't have them already. And we can also go over those after you get your grades if there's any questions. Not seeing any hands. Was this interesting today? Did we like this? John's got his hand up. Yes, sir.
I don't know if we have time to do this or not, but I had I would love to see like an example for John the Ripper of you know, Tony, how you were saying, or maybe it was you, Justin. I honestly don't remember because there's been so much information about how it can instead of guessing from a list of passwords, sort of decode its best guess. Like, and if we could see an example of that run on just like a single input, and it could be like a simple like a 6-character password, and you could tell it 6 characters or something like that. I'm just really curious about that capability.
Yeah, Tony, do you have your VMs up? I'll talk a couple minutes while we. So that was one of the things that we were gonna have you guys do over the weekend. I don't know if you had taken a password. I think you're asking like just a regular MD5 and how to crack like MD5 hash. Is that what you're asking? Or and we asked a couple things this weekend. Also run back through that old list that you had and see how many of those you could kind of crack as well. Yeah, we can. My virtual machine's just reset on me, so looks like Tony's got something going on there.
So I think what you're asking, John, right, is about the incremental version, the brute forcing without the word list. So yeah, we can be able to go ahead and demonstrate that. I'm gonna have to start up my VMs because they also went ahead and, just like what Justin was mentioning, kind of went down on me. But if we don't provide that word list option, we can be able to have it go into an incremental. And I believe by default, it actually starts off by assuming that the password is 8 characters long. So in a little bit, once my VMs are up, we can be able to go ahead and take a look at that. We can be able to see how we can be able to do that. But typically what ends up happening is you just put in John, you put in the file to the hashes that you want to be able to try and crack. And then if need be, you can be able to specify what format the hash is in. But if you don't provide that word list, then it goes into that incremental attack by default. And then it starts off at a certain size. Like I said, I believe the default is 8 characters in length. And so then we'll go ahead and start trying to do that. But you can specify what character length you want, and it'll go ahead and kind of brute force its way by anticipating every single character combination that is possible, and it'll run through those, right? So give me a moment to get my VMs up, and then we can be able to go ahead and do an example of that. We can take a look at that.
Well, thanks, Tony. Yeah, that's exactly what I was curious about.
Yeah, remember that we're using these off of like a virtual machine in the cloud, and they have a dedicated GPU on them. So even incremental, I'm trying to look up exactly how incremental mode works because I forget. Even if it was like a series of all A's, right? So we don't know how long it would get to all those A's. I don't know if it would go like start with zeros, you know, if it's numeric first, if it's alphanumeric first. Because if it was alphanumeric first, it would probably do all A's, then all A's in the B, then all A's in the C. And by the time you would do A through, you know, A through D or E, right? Your 8 characters, it may take an hour. It could take longer than we may want, just because we don't have the horsepower to make it go faster.
I think I
Or
was
it could go
mostly
really quick.
curious
I
about-
don't know. You know, usually you'll throw word list at it first. You'll throw like, you know, the generic word list, and then you'll do like a bunch of word lists that you may know of common passwords that the company always uses. You may make your own up, like if you're going to like Verizon, right? You may figure out a bunch of Verizon centric passwords and throw them in a list and run those against it as well, before you would say, well, I'm gonna put the password cracker to the test and run it incrementally. And that could take a day or so. So. Anthony, you got your hand raised.
Yes, let's see. In respect to utilizing incremental mode, because you're wanting to brute force, do you still have to set your characters or your parameters? Or is there a way of doing it by just like a predefined mode that includes all characters?
You're saying, how do you set up the command string for it? Let me give you all this and see if you can. So this little tool kind of walks through like how John the Ripper works, how different password modes work. We discussed this, nothing new here. Trying to go down through here and see. You still have to define what kind of format you want. So you're still defining that, it's John, tac, whatever, single, incremental, whatever. Then your format, and then how you're outputting the file. So there's nothing new right there. It's just another, John, tac, incremental, character count n, format equals format, and then they gave it a passwords to crack list.
Okay, it's a last resort.
Yeah, it's kind of like one of those last resorts. Like, you can't figure it out. You're just gonna throw everything at it and see, hope that you can get something. But that's because you're trying to find a password. You don't always need to get the password. That's why we can use Kerberos and use pass the golden ticket, try to capture that golden ticket, and it's called Kerberosting. And you'll use the application we just talked about. Let's see if I have it still up here. That closed out. Yeah, Rubius is what you're going to use to try to capture some of those hashes that went back and forth. You don't necessarily need to use John the Ripper if you're not getting into that Linux system. That's, you can, John the Ripper works for any kind of password. Majority you're taking that password in that shadow file, but you have it up there, Tony? Still working on it?
Yeah, it's come up. So let me go ahead and share my screen, and we'll take a look at what we're doing here. And yeah, it's pretty much exactly like Justin was saying, right? There's only really two parts to it that we're going to see. It's setting it up to let it know that we want to work in incremental mode. And then we can be able to go ahead and set a size. So let's go ahead and do an example. I'm going to go ahead and do, let's see. I'm going to say echo, and let's go ahead and do this as the word that we want to be able to use as our password. And here I'm going to send it over, instead of an MD5, I'm going to send it over here to SHA-256. So SHA-256 gives us this right here, right? So that is our hash that comes from SHA-256. I can be able to go ahead and redirect this into a file. So we're going to go ahead and put this into test.txt. Let's go ahead and let's go into it and modify it so it's just the hash. So I went ahead and got rid of the ending there, made sure it was just the hash value. And so now we can be able to go ahead and get into our John the Ripper, right? We can be able to go ahead and tell it what we want to be able to do. So at that point, it's just really going ahead and doing what we expect, right? We're going to go ahead and type in John. And as a matter of fact, let me actually, since I have to do this from root, right? Because remember that we don't have the proper permissions to run John unless we're our root user. Let's actually go ahead and look at this right here. We're going to go man John, and then we're going to go ahead and look for incremental. So you see right here, there's really three different main ways that we can be able to use this, right? There's single, there's wordless. We've already seen wordless. This is going to be the most common one, and then single comes. And then there's incremental, where it's kind of trying every single possible combination. So as Justin kind of pointed out, if we're doing incremental, it is a last resort, right? We've tried the other two. It hasn't been able to crack the password. And so we're saying, okay, if it wasn't using one of the common passwords, if it wasn't being able to go ahead and crack it these other ways, then let's just throw everything at it, right? Let's throw every single possible combination, see if it's able to find it. And because of that, since it is going through every single possible combination, can it be able to go ahead and eventually get the right password? Yes. But how much time is it going to take, right? That's why it's the last resort, because it will take a lot longer to go through every single possible combination and then find the right one that works that way versus just trying known passwords like with a word list, right? So let's see. Here we go. So here's our incremental mode, right? We're able to go ahead and specify with just this dash incremental. And then we're able to go ahead and specify after that, how big do we want this to be, right? So let's go ahead and quit here. And we're going to go John. We're going to go ahead and go incremental. And then after we've specified that, let's see, we can be able to go ahead and then specify how big. So I believe after that it's incremental and then char count. And then we would set this equal to, and then we can be able to give it a number, right? Now that number is going to be how big do we want to go? So it's kind of telling it when to stop, right? Once we've tried every single possible combination up to this size, if it hasn't found it, if it hasn't been able to crack it, then just stop, right? How long do we want it to keep running for before we go ahead and have it stop? So at this point, we want to be aware that that's there, but we're not going to need it for this example. So I'm just going to go ahead and specify that we're going with John. We're going to go ahead and specify that it's incremental, and then we're going to go ahead and specify its format, right? So I'm going to go ahead and say format equals, and we're going to say raw SHA 256. And I believe that that's what we can do to be able to go ahead and specify that this is going to be our SHA 256 hash, which is what we used, right? And then I'm going to go ahead and pass it over to try and crack our test.txt. And so we see then right here, it ran through it. It took a while, but it was able to do it rather quickly, right? Because this is fairly common. And so we see right here, depending on the algorithm that John is using, right, is how is it going to go through this? And so we see right here, it was able to find it pretty quickly. It took just about 2 seconds, right? We can see that time right here. And it was able to go ahead and figure out that, yeah, this was that password from that hash. So even when it's going through this incremental, it'll probably have it that John, as its algorithm, has a few common passwords that it'll go ahead and try first. And then once it's gone through some common ones that it isn't able to go ahead and work, if it doesn't find that those are able to crack it, then it'll go ahead and start going through every single possible combination that isn't used, right?
You want to try
Just
like a complex password real quick, Tony? Like just throw like, I don't know,
Sure.
like 12 to 16 character complex. See if we can. At 2 seconds, that was pretty quick for those 8 or 9
Yeah.
characters. Just for fun, we got some time. That's what I was just thinking.
All right, what type of combination do we want to put there?
Series of uppercase, lowercase, special characters. You can just bash on the keyboard if you want. That might work too. Anybody have any
Alright, so we
questions
went-
of what he's doing?
So far, we've been able to go ahead and just echo this, right? So I just went ahead and typed in incremental, and as Justin was saying, just kind of alternated between uppercase and lowercase. Then I went back in and added in some numbers there, some numbers for 1337, which is leet speak, right? Usually something that hackers or malicious actors might use. And then I went ahead and passed it up into an MD5, so that way it'll be since we're doing with a longer password size, a simpler hash. So that way it won't take too long, hopefully, to be able to go and crack this. And then we just modified the file so that way it's just the hash value so far. So with that, let's go ahead and try running John. We're going to go ahead and do the exact same thing, except for we're going to change this from our SHA-256 to an MD5, right? So we're going to say, let's run this incrementally. Let's go ahead and run it as a raw MD5, a hash value, and then run it with our test.txt file. And then let's see how's it going. So we see right here, it starts up, and kind of like what we indicated before, right? It tells us, hey, with almost any key that you press, it's going to go ahead and kind of let us know what is it doing, what's its status, right? Or we could go ahead and hit Control C or press Q if we want to stop. So if I hit, for example, enter, we see right here, it's now taken about 21 seconds, right? And it tells us what is it going through right now. So it's running through this combination of from ABUG, so on and so forth, to ABUL, so on and so forth. So it's running through all these combinations, right? And we see that it's running this through, it says fork equals 2. So from when we're using fork in Linux, this is how we're creating processes. So I believe it's trying to be able to go ahead and run this through more than just one process, right? To be able to kind of try and speed things up. So right here, we're going to see that hopefully before it gets to too long, that we'll be able to go ahead and find this. But it might take a while, because if we go and check out our status again, we see we're barely getting into the L's, right? And we see right here, we have it that we're already starting with a capital I, right? Another thing we'll notice right here, we have, looks like 3, 6, 7 characters right here that it started with on that one. Let's see right here, we have 3, this one was 8. So it is going through a variation of them, right? So again, it's just the algorithm that the people that developed John, how are they going about doing this? How are they having it go through and test, right? So part of it could be, again, very common passwords at first, right? So a list of common ones that's still going to run through anyway, whether we've provided a word list or not, and then kind of going incrementally through every single possible combination. So if we go ahead and check again, we see that we're almost at the 2-minute mark. We see that it's already down here, checking this out, right? So because of the fact that this isn't going to be your common everyday password, and because of its size, this probably could take a while to be able to go ahead and do, right?
Hence the reason to use long, complex passwords, so that, you know, individuals that know John the Ripper can't just try to figure out password faster. So while that's still running, is there any other questions or anything we want else to go over? So a couple more minutes. Seeing anything, nothing in chat.
I had a kind of a quick question, if that's all right.
Yeah, sure.
So we've been going over actual reports where a client would give you, the pen tester, the parameters for this report, and they're asking for specific things, or but can you kind of elaborate on the legality of bug bounty programs and more of like the gray area behind that type of pen testing? Like what to do, what not to do, what to avoid, how it works?
So
What type
you've got some gray hats out there that not white hat ethical, but they'll go out and they will try to penetrate, try to test something, and then they'll be like, hey, look what I found. I'll help you fix it. There's legal implications in there, yes. But if you talk about like bug bounties, like a company like Google, a company like Tesla, you know, they're going out and saying, hey, we're going to let you play with the system, let you try to find it. And if you do find the flaw, we're going to pay you for it. You know, that's kind of like a capture the flag. It's kind of like a hacking fest. They kind of give you kind of a open slate, like go find the stuff. And sometimes these people are hired on because they know so much about the code, they know so much about how the system works that they actually benefit by hiring somebody on. It could be as simple as, it's like a job interview. They're doing these bug bounties saying, hey, try to find the stuff in it. Microsoft does it a couple times a year, saying, you know, new application comes out, tell us what's broke on it. they may or not come out and say publicly what was found and what was broke. They might make you sign a non-disclosure agreement, an NDA, and say, hey, whatever you find, it's ours, and everything you did, we own, so that you can't go out and spread it. So that they have you, by the legal bounds of you're not allowed to say what you just did. Does that kind of answer the question a little bit?
Sounds like it's only legal if the company authorizes a bug bounty program beforehand, right?
Yeah, if you want to get like rewarded for money from it, some people go out and say, hey, I found this flaw. Would you like to review the code and what I found? And if you don't, I'll just sell it. Like there are people like that. That's why they're gray hats, because they're not doing it fully ethically. They're just like, oh, well, I was looking at your new software and I was looking back at the code and I saw some flaws, and here I'm showing you what it is. Whether they forcefully did that, but those gray hats will turn to be a black hat and they may sell that stuff, that flaw, that vulnerability on the web, or just share it out with everyone just because they got upset that the company didn't allow them to sell their findings with them. They didn't embrace them for them finding out flaw in their software, their network.
Yeah. Okay. Thank you.
So as you can see, this is going to go on forever, and we won't be here tonight to see this finish, but it'd be interesting that if this was a virtual machine that would stay running for a long time, to see how long it actually did take. There's no even estimate times on how long this is going to take, but
If you had something like a Raspberry Pi, that would be something that you could be able to possibly do, right? You could be able to go ahead and run something like
take a
this.
long
You could
time with
download John
that.
the Ripper. It would take a long time, but you can let it run and see how long it would take, and then see if you could be able to go ahead and find passwords that way. I'm going to go ahead and stop
Absolutely.
sharing my screen right here real quick. And I'm going to go ahead and share this just so that we guys get a little bit more insight to what's happening here, right? So this is a very good example of explaining what's happening behind the scenes when we come to incremental mode. So we see right here, it uses trigraph frequencies to prioritize the order of how it's going to go through and crack it, right? What does this mean? It means that based on the study of typical passwords, right? We're going to see right here, what are the most likely passwords based on studies of what's the size, right? How big that password is, what are the more common letters in a password and something like that. That's what it's going to be kind of going through and attempting to be able to do when we're doing this incrementally. So we're seeing, for example, right here, it's showing us the first 20 passwords that were attempted in this incremental test. So it tried 1 by itself, then 2, then 3, then A, B, C, then 1, 2, 3 all together, then A, B, C, and so on and so forth. So we see it jumping around, right? It skips back and forth between different lengths to see which are the ones that are most likely based on the studies that have done, based on the information that they have. In other words, the statistics of passwords, right? Which one is it likely going to be? And so it's going to go through those most common ones first, right? Now, you could be able to go ahead and configure the files that John has, and you can be able to add to that list. So for example, they said, hey, let's modify this file and add in the password 1234. Try that before anything else, right? At the same time, there's also right here for specifically for incremental, you could go to the configuration files for the John the Ripper, and you could change what's happening during an incremental test, right? So for example, we could be able to specify right here that minimum length that we want to test for. Hey, we could be able to say, hey, start it off, assume that the smallest it could be is 0 characters, or we could say 1 character or 2, whatever. And then what's the maximum length that we're going to go to as well, right? And then the char count is going to be the different variations of characters that we might use, right? So are we going to have just alpha characters? Is it going to be uppercase? Is it going to be lowercase? Are we going to go ahead and allow for numeric characters? Are we going to allow for special characters, and so on and so forth, right? So that's kind of what we're getting at right there. And typically when we're doing these type of things, again, it's with the expectation that it can take a lot longer, that it is something that is a last resort, and that if it was going to be cracked easier, then we would have attempted to do that word list and given something like RockU, right? With that, I believe RockU has over 14 million most common passwords, right? If it's going to be something that we expected to be easy, we would have been able to find it with something like that first, right? So we would have attempted to do it that way. We would have attempted to do it through a single attempt before we try to be able to go ahead and go through this incremental attempt here. All right, any other questions or any other quick things that you would like us to review from our time with Red Team? All right. I will point out that Anusha has already posted the link to our feedback for tonight's session in the chat. I will be posting it to our Slack channel as well. Please make sure you guys go ahead and take the time to be able to go ahead and click on there, fill it out so we can be able to get that feedback. At the same time, if there's any questions that you guys have, if there's anything that you guys would like to review again, because as Justin pointed out, Wednesday, we're going to go back for more career prep, right? So more interview questions, dealing with stuff that we've now learned for part of our Red Team module, right? And then Thursday, we're going to open it up to our career simulation, where we're going to have you guys go ahead and run through gaining access to a box, right? Being able to go ahead and start with Kali as your machine, and how we are able to go ahead and kind of compromise the device, right? And so like you guys were looking at today, right, with our reporting, when it comes to Thursday, we're going to see how you guys are going to be able to go ahead and write up your own report for how you can go through if you were on Red Team or if you were doing a penetration test. So that's what's going to be happening Wednesday and Thursday. And as Justin pointed out, you guys are being more working solo when it comes to those things, right? There's not going to be any new material technically being introduced. So if you have any questions, or if there's anything that you guys would like more experience with, or just anything that you guys would like to review to prepare you for that, feel free to be able to go ahead and ask questions or to reach out to us between now and then so we can be able to help you out, right? Justin went ahead and provided an excellent resource into the chat right now for sample MD5s, if you want to be able to use that to be able to look up with VirusTotal or something similar. If you have any questions with what we've introduced tonight or anything previously, feel free to be able to go ahead and stick around and be able to ask those questions. Otherwise, if you don't have any questions, we're going to go ahead and end it here for tonight. So please fill out that link that Nusha was able to go ahead and provide in the chat. And then stick around if you have questions. Otherwise, have a wonderful evening. We'll see you guys on Wednesday.
Thank you so much, Tony and Justin, for an amazing session. Thank you all for your participation. I'll see you guys on Wednesday. And the survey link is in the chat box. As Tony told, please make sure you give your valuable feedbacks and rate the session. Thank you so much, everyone. Hey, Tony.
Yes.
So the Red Team is ending on Thursday.
Correct.
Okay, got it.
All right. For those of you that are still here, if you have any questions, feel free to be able to go ahead and unmute your mic and be able to ask or type it into the chat. Otherwise, have a wonderful night. I'll see you guys on Wednesday. All right.
Okay, so I guess that's it for today. Yeah, I'll see you on Wednesday, Tony and Justin. Good night.
Sounds good. Thank you. Good
Excellent.
night.
Good night. You guys were able to go ahead and start to get onto that Windows portion, right? Be able to go ahead and try and be able to exploit our Windows machine. Hopefully, if you guys were having difficulties with being able to ping the machine or being able to have it being recognized by your Kali machine, you were able to go ahead and take advantage of what Justin was telling us. Just reset the machines, right? Turn them off, start them back up again. And hopefully with that, you were able to go ahead and get the connection up and running. So let's go ahead and go over a little bit of what was happening there, and then we'll move into the next section, right? So let me share my screen. And if we take a look at our LMS, right, the first portion, we wanted to be able to go ahead and make sure that we were as our Kali user. And it told us let's go into opt/Linux priv check and then run that script, which we showed you how to do, right? And then it said inside of this, as part of the information that's coming back, we wanted to see where does it tell us about this privilege escalation vulnerability program, right? So there's a few ways we could do that, right? If we're doing it that we're looking through our results, well, you recall that I went ahead and I created this results file, which shows us the stuff, right? So I could say, let's cat out results, right? And we can pipe this over to grep, because we want to remember, anytime we're searching through the contents of a file, we can use grep and then just tell it, what are we looking for, right? So I'm passing the contents of cats, right? I'm telling it to cat out the results, passing it over to grep, and then I'm telling grep to go ahead and search for, and we can be able to say privilege escalation and then vulnerability, right? And we'll notice that only one line comes back, and it tells us exactly where that is, right? It's under our opt directory, and immediately inside of that opt directory, we find this file, privilege escalation vulnerability. Now, if we knew that that file existed, which we were able to find that out because of the results of this scanner, right? That, hey, we have this vulnerability, we have this file that is owned by the root, right? It's owned by the root account, the root group, and so we might be able to use it, right? But if we didn't know about this, some of you may have used the find command, right? Which, if you recall, we have to then tell it the directory that we're going to search in, right? Any options that we want to be able to go ahead and use. And then we have to tell it after that, the name of the file or something that's similar to be able to go ahead and kind of find what we're looking for, right? So typically we're going to do that based off of the name of the file, but there's other ways we could search, right? We could go searching for all files that are of a certain size or a certain amount of bytes on the hard drive, for example, things like that, right? So taking it in this way, we could say, hey, start searching from the root directory, so that /, right? And then what is our option? Well, if you want to go based off of the name of the file, we have to specify that because that's not the default thing that find does, right? So we're going to go -name, and then again, what is the name of this file? Well, it was privilege escalation vulnerability. And you'll notice that it comes up with a bunch of errors, all these permission denied stuff, right? So to clean this up so we don't have to see all that, we kind of want to get rid of those errors. So if you recall, our standard output, which is our regular messages when we run a command, that's the first channel when it comes to output. Our second channel is our standard error. So if we want to get rid of that, we want to redirect that, we can be able to use our regular caret sign, right? That greater than symbol to redirect, but we have to put a 2 in front of it saying, hey, we're redirecting that second channel, the error channel. And then typically we can be able to send that to dev null, which is kind of a place to send it to not really pay attention to get rid of it, right? So if I do this, we're going to clear it up. We're going to get rid of all those error messages. And once again, we're going to see there's only one that comes back with this specific name, right? And again, we find that it's in our opt directory, just like we saw from the results, right? So what we want to do is we want to be able to go ahead and go into that directory. So I'm going to go ahead and change into opt. And then if I go ahead and take a look, we see here is that file. So I'm going to try and be able to run this file. If we recall how to be able to run a file is very much like we've been doing when we've ran our scripts most recently, right? We can go // and the name of the file. Now, when we run this, we're going to see it says enter an IP to ping. This is very similar to what Justin was showing us when he was showing us our file inclusion, right? Or not file inclusion, but our command, right? To be able to go ahead and do where we inject our code for a specific command into something that's already there to try and get it to run our new command that we're putting in, right? So we can be able to test this out. We say, hey, let's ping, let's say ourselves. And we see that it goes ahead and pings. Now, the key thing here is that it does tell us, first of all, that it's running this as root, right? We saw when we were looking at that results information from our vulnerability scan, that this is a file owned by root and also our root group, right? And so it's running, that's why this is looking red right here, because it can actually run it as if it were root. Anybody that runs this is going to run it as if it were root, so therefore it's running with root privileges. So even though our account right now is the Kali account, and it doesn't have the same privileges as root, when we run this file, we are running the file, and anything that it does as if it were root, right? So how can we be able to go ahead and try and be able to escalate this on over to seeing how we can be able to use it to do things as our root account when we're not root? Well, we can do what Justin showed us, right? Justin showed us that, hey, when we did this in DVWA, right, there was a website inside of our DVWA that we saw when we were doing our vulnerabilities labs that also asked us, hey, enter in a ping address and we'll ping it, right? And so we can do something like that. But then he also showed us how we can really make use of our binary operator, right? And he did our double ampersand that's essentially going to tell it, hey, yeah, go ahead and ping this address, but then also do this, right? We got to do that and do this. And so I can be able to go ahead and then run any command that I want afterwards. But our focus was, let's try to be able to see the etc shadow file because only the root user should be able to see that. So the normal way that we can be able to sort of display a file is just our cat command, right? And then what file do I want to display? etc shadow, right? And so we do this, we see our ping information again, but then we see immediately afterwards, it's showing us our shadow file, right? So with that, we're able to go ahead and see that even though, if I were to go ahead and type it right here, outside of that, right? If I were to say cat etc shadow as the Kali user, right? It says permission denied. But by putting it inside of this program while it was running, a program running as the root user, it was able to show it to us regardless. So that's what we're kind of getting at with that first exercise, right? We were able to escalate our privilege into the root account to be able to see stuff we shouldn't be able to, right? To be able to do things we shouldn't be able to. All right. The next one was to be able to go ahead and then try to do this with our Windows, right? For privilege escalation. So they said, let's go ahead and open up our Windows VM. So I do have that open up right here. And we can be able to go ahead and see that if we go here, let's sign out. And then if we were to go ahead and send over that Control-Alt-Delete, we see that we have administrator and administrator 2. So this is our Windows 1 machine, right? So I'm going to log back into FStack. And then what am I going to do here? Well, it tells us, let's go ahead and once we are in, right? Once we've logged into our Windows VM, let's open up a command prompt and let's just take a look and see what the account shows us, right? So for who am I? So I'm going to go ahead and open up the command prompt. We can be able to do that by simply entering CMD. We see that it says command prompt there in our search file. And then I'm going to type in who am I? And it tells us we are FStack. And then this is the domain that we are logged into, right? So we are the FStack account. Then it says, let's do an IP config so we can be able to get the most current IP address, right? So we see right here, this is the IP address for that virtual machine, 172.3.1.49.80. Then it tells us, let's go ahead and open up a notepad document. We're going to be using this later on, right? So I can be able to go ahead and click down here in our search bar again, type in notepad, and let's start that up. So we have that up and running. Then it tells us, let's go ahead and establish our interpreter session. So this is what we've been doing yesterday and the day before on Monday, right? We were able to go ahead, get into the administrator account with the information that we've been given and to be able to go ahead and essentially set up our interpreter shell from Kali, right? Now, I did have to go ahead and reset this, so I believe we're going to have to reset the passwords here. Let's see. So if you recall, we would go to computer management. We'd go over to local users and groups. We'd go into users. We'd right click on administrator, set the password. We'll proceed. And then we'd be able to change it over. So if you needed to do that again, or I forgot how we did that, we were able to go ahead and demonstrate that again, right? So it's now been set over to Academy. So that way we can be able to go ahead and get in there. And so here we're going to go into our MSF console. I'm going to go with the -Q to enter it quietly again. It's going to take a little bit of time to be able to go ahead and get into our Metasploit framework, right? So MSF console is how we get into Metasploit. Once we're there, we're going to see that it'll say MSF and then the version of Metasploit we are running. So for us, it's MSF 6. And once we see that, we know we're in our Metasploit framework. once we have that, we're going to make use of the exact same exploit we've been doing, right? Where we were saying PS exec C was the vulnerability that, rather the exploit module that we wanted to be able to go ahead and use. And then we have to set up our information, right? We got to set up our payload to the 64-bit version. We got to be able to go ahead and set up the administrator's username, the password, the domain, and then the IP address of who our target is, right? So we're going to say search PS exec. And this was the one that they had wanted us to use, right? So it was our exploit /Windows/SMB, because we're making use of the Samba server, and then /PS exec. So that's module 4. So I'm going to say use 4. And then it'll go ahead and load up that module, right? So we see that right here is using our exploit for Windows for the Samba server PS exec. We can then say show options. And we see again here, what we really need to provide is a target. And then if we want to go beyond that with our host, once that's known, we can be able to go ahead. Give me one moment. Started to freeze up on me there, so I'm going to try and see if I can clear up some system resources so we can be able to go ahead and get rid of that. All right, let's try this again. All right, hopefully that runs a little bit smoother. So we're going to go ahead and try and get our target, so our host, right? And then as additional information to kind of make things a little bit smoother for us, right? We said we're going to provide the domain, the password, the user information, and so on. So let's say set, I'm going to go SMB user. And then we're going to go ahead and say administrator. So we've set that. Next, we're going to go ahead and set our SMB pass, so the password. We're going to set that to Academy. So now we've set that. We're going to set the domain. So set SMB domain. And that was the first part of our server name, right? So EC2 AMAZ -L3 and then 00, well, not 0, but 00, right? And then UG8. So we set that. And then let's see, if we go show options again, we have set up our username. We set up our password. We set up our domain. We just need the R host now. So we're going to say set R host, and then that's going to be the IP address that we had over here, right? So we see that this is the 172.3.1.49.80. So 172.3.1.49.80. So we set all that. Let's go ahead and hit run. We see that it's starting to execute. And once it's done, it should say session 1 opened. So we see that right there. So we've established our session. We should be able to have that connection to the Windows machine. So that's exactly what we wanted to do, right? We've done all this right here. Let's see, I forgot to set the payload. So let's go back and do that, since we're using the default payload, and then that might interfere with what they want us to do. So I can type in exit to exit out of my shell at any time. I'm going to go ahead and let's say set payload. And then we're going to go ahead and go with, as it tells us in our LMS, right? So Windows x64, so that we're making sure we're using the one that's explicitly for the x64 architecture, and then interpreter reverse TCP. So we're going to say Windows and then /x64 /interpreter /reverse _ TCP. So we've set that. Now that we have the right thing, let's go ahead and clear this. Let's go ahead and show our options. So we see that it did indeed switch over for the payload, so that we were using the one that's explicitly x64. Let's go ahead and run this. And notice that this one's going to set up a whole new session. So we'll have a new session number. This one says session 2 opened. All right, so now we should be able to go ahead and be able to do anything and everything that we want, just like it's having us do on our LMS, right? So we've gone ahead, we've set up the administrator for our username, Academy as a password, our SMB domain correctly. We set the payload to the one they want us to use. So it says, now let's go ahead and find the process for that notepad that we opened up earlier. And let's go ahead and migrate into that, right? So you recall we set up notepad right here. So let's go ahead and look for it. So inside of our interpreter shell, we can say PS, right? To be able to go ahead and list out our processes. We're going to look for the one that is our notepad. So if we go ahead and start looking around, here it is right here. So our process ID is PID. That's the one on the left. So that's 1732. So we're going to say migrate 1732. That's going to go ahead and migrate on over into that. So we've migrated successfully. And then it says, let's go ahead and type in background to set that interpreter session to the background, right? And it says, take note of the session ID. So I'm going to go ahead and type in background. And it tells us right here, just like we saw when we started it, it's session 2. That's our session ID. We want to pay attention to that, right? So now we're back in the framework. We're running that in the background. And so it tells us, let's go ahead and run a different module. Now that we have access, we can be able to make use of our post modules. So it says search for our post, multi-recon, and then local exploit suggester. So I'm just going to go ahead and say search local exploit suggester. And we see that there is just one, and it's exactly what they were saying, right? Post, multi-recon, so on and so forth. So I can be able to say use 0, because that's the number that shows up from our search. We see that it switched over. Then it tells us, go ahead and set the session to the interpreter session, right? So we can be able to say show options. And it shows us there's only 2 things, right, that needs to be put there. One already has a default value. The other one is what session that we want to be able to go ahead and run this post module on. So I'm going to go ahead and say set session to session 2 in this case, because I had a second session, right? That was our number there. And so now you can run this. And we see this collecting the local exploits for this Windows machine, right? Specifically for 64-bit architecture. So that's what they want us to do. We see right here, it says we're going to execute that exploit suggester module. We're going to view the output, and it's telling us that, note, there's going to be various privilege escalation exploits that might be applicable here, right? In practice, you would try some of these as the module suggests, but in this case, you can only see the exploits that the module finds. And it says sometimes the module may freeze, so you might have to do Control-C to cancel out and run it again if it freezes, right? Now, after this, it's going to say, okay, we're going to want to then search for this exploit Windows local ask module. So the suggester should have this listed as one of the suggestions, right, that we can be able to use this exploit. So we then can be able to go ahead and load up this module. It says this module will prompt the user to run an executable to establish an elevated interpreter session. We can then set the session to the interpreter session we noted previously, set the payload to once again being our reverse shell payload, right? And then execute the new module and move back into our Windows VM, which will have that pop-up window appear asking us to run that executable. If the user were to then click yes, they've just given us permission, right? Which we can see then we will move back into our Kali VM, and we should be able to see that we have another new session with elevated privileges. And then we can be able to go ahead and type in get system to then become our system user, right? So let's go ahead and take a look at that. We see right here, it's running a check for out of what it thinks might be about 41 vulnerabilities. It's doing 12 out of 41 so far, right? So we see that here's one of the ones that is suggested, right? And so on and so forth. It says that target appears to be vulnerable. Let me hit Control-C just like it suggested, because we're going to see that in order to kind of speed things up, right, we're just going to go ahead and load up the one that it's asking for us. So we're going to search for this exploit Windows local ask. So search exploit Windows local ask or /ask. And we see there's the module. So I'm going to say use 0. We're going to go ahead and set payload. And I believe they want us to use the exact same one, which we see right here, right? So the specifically x64 version. So we're going to set payload to Windows/x64/meterpreter/reverse_TCP. Now let's go ahead and go show options. We're going to see right here, the only other thing I need to know is a session, right? We see that these two aren't required. They say no. And this stuff is already there right for us by default. So we're just going to have to supply the session number. So I'm going to say set session to 2. And so now we have it all set up. We're going to go ahead and hit run. So it says executing command. If we come over here, we see that we did get that pop-up. If we hit yes, we've just given them permission to be able to go ahead and have that escalated privilege, right? So we see over here, we now have our next interpreter session, session 3. This is going to be escalated. So now we can be able to go ahead and use this command, get system. So we're going to type that in. And we see then, we should now see that it says that it got system via technique 1. So we should have system access. And so we should see that we are now successfully the system user. How can we do that? Well, we can type in shell to drop down into an actual shell on the machine. I can type in who am I? And we see then, bam, right there, we are system. Any questions on how we were able to do that so far? All right, then let's go ahead and go back into our LMS and let's scroll down to the last part that we have for you guys today, how we can now do lateral movement. So remember, privilege escalation, we're pretty much sticking on the same device, right? We were having Kali attacking one of our Windows machines. Once we got access to that Windows machine, what we were doing was trying to move into a higher privilege account, right? We were trying to move from the account we started off with to that system account, which has more privileges, right? Same thing with our Kali machine. When we were showing how we can do that against our Linux stuff, we said, hey, here's our Linux machine. We scanned it for vulnerabilities. We were trying to then show you how we can be able to go ahead and do stuff as root, even though we weren't root, right? So we're trying to be able to still stick on the same device, but what can we do to increase our privileges, increase our authority, so to speak, right? And so now with lateral movements, we're going to see if I gain access to one machine, how can I use that to gain me access to an entirely separate machine, right? So that's what lateral movement is. A little bit different than just our regular privilege escalation, right? So we see that happening right here, right? We see how they go ahead and state that in their own way right here. Lateral movement is the concept of extending our access. We're not extending our privileges. We're not getting the same device, but just with a better account. We're now saying, let's go ahead, now that I've infected one machine, let me go for a second or a third, right? And so on and so forth. So we are moving from one compromised system to another. Now, this might also be referred to as pivoting, right? Pivoting allows the attacker to move deeper into the network, furthering their control and increasing their chances of gaining sensitive information. Now, we're going to see that it's typically going to be done in one of the following ways, right? So the two ways we have it, the following means is we can steal a key or credentials, right? So a username and password, for example, and then use them on another system. So maybe I found, let's say I was able to go ahead and access a website. And on that website, I was able to gain into their database and have it show me what their website username and password was. And then once I use that, I try and log into the website, right? And then try to be able to use that. And now I have access to their systems. And I say, okay, well, what if somebody else on another system, maybe a database system or an SQL system, what if they also have the same username and password? And so we tried that and it works because a lot of people use the same username across many different things and the same password, right? For instance, you might have your same username and password for Facebook, for your email, maybe God forbid, you're using the same username and password as your Facebook and your email and stuff like that for your bank account, right? So anybody that knows what your Facebook account is, well, now they also technically know your username for your bank, right? And so on and so forth. So once they have these credentials for one system, trying to use it on another one. And if you're using the same stuff, well, now they have access to that other stuff as well, right? Because it's the exact same information. The second way is to exploit some vulnerable external service that allows for the compromise of the system while it's running that service, right? So the means by which to laterally move between our systems is different depending on what operating system is running, right? So we see that it tells us if it's between Linux, There's one way to do it, and it's different than if we're doing it with Windows systems. So there's two different techniques there to do these things, right? So we're going to see right here with Linux, the lateral movement is usually done with SSH or getting a password, right? So we see right here, we can compromise the password of a user, use that on another system. And again, we can do that by just guessing the password, using a brute force attack, doing something like John the Ripper if we have their hash values, right? And then the other thing is if we're somehow able to find their SSH key. So let's say we got a foothold into somebody's machine, or as Justin pointed out before, right? Maybe we're going down the hall to another user's computer while they're out of the office. Maybe they went to the restroom or went to go get water. Maybe they're on a coffee break. When we enter into their office, they didn't lock their computer, so now we have access and we're able to go in and get their SSH key, right? Well, once we have that information, we can be able to use that file to then be able to kind of log into certain networks, provide that key, and then they think that it's that user, right? So we see right here, SSH keys are files, right? Nothing really special about it. It's just a file with certain information on there. And it's used to do authentication when we're using something like SSH as a service. SSH, as you know, it typically runs on port 22 by default, right? Now you will find that SSH services tend to run on Linux systems. So if we have a Linux system, chances are it's usually going to be allowing for SSH unless they specifically close that port, right? And it can be available on Windows systems, but usually that's more by default closed on Windows because it's not as oftenly, it's not commonly used, right, for Windows. It's more common in Linux. Now, how can we be able to find these SSH keys? Well, SSH keys are typically going to be found in the user's home directory. So if you're able to gain that foothold, kind of like what we just did with that interpreter shell to begin with, to gain access to Windows, right? We can be able to go ahead and look there. In this case, we're talking specifically more towards Linux. So if I were able to go ahead and gain a reverse shell into a Linux machine and now logged in under a certain account, I'm going to try and look inside of that user's home directory to see, can I find their SSH key? Now, specifically, we're going to see that it's under this .ssh. So we see right here for Kali, it's going to be /home/Kali.ssh. And we can see that when we go over here, right? I'm going to go ahead and hit exit right here, exit out of our shell, exit out of our MSF console stuff. Let's see. Let's actually just go ahead and right now to make this quicker. So if I were to go ahead and do an ls, here is our regular directory, right? We can tell this is our login directory because we have that Enya, that squiggle line, right? The tilde. This is going to be that we go ahead and then we don't see that .ssh because we need to go ls-a, right? So now we can see our hidden stuff. And we should see that if we've already used SSH, here is that .ssh hidden directory, right? So it's in whatever the user is, their home directory, and then hidden in this directory of .ssh. So here, if we cat into it, or excuse me, we should do change directory actually. And we take a look here, we see here, there are some authorized keys, right? And so on and so forth. So that's what we're looking at right here. We're going to see if we can go in there and then find those keys. We see SSH keys. If there is an actual file that's a key, it'll be a .pem file, right? So within that SSH directory, if we have any that we are using, it'll end in .pem. We also might find a file known as known hosts. This is going to be a list of places we've already connected to with SSH, right? So if I made an SSH connection to a certain computer, a certain device, and if you recall, the first time we make that connection, it says, hey, you've never connected to this device before. Do you trust it? And you say yes or no. When we say yes, then it does the connection and it's going to add it into this file, right? It's going to create this file of known hosts, add the connection that you just approved into there. So that way in the future, when you run it again, it says, oh, we've already connected to this. We can already trust this, right? So and that's actually, if we're able to take a look at it as the attacker, it's going to give us a list of places that they may have already used their SSH key because they've already connected to that place. So now we know, hey, if I try to connect to that IP address with this SSH key, it'll probably recognize me as the target, right? It'll recognize me as whatever account I've taken over, right? And so we say, And you should, if you're trying to be able to go ahead and gain access to those other systems, try using the SSH key with those IP addresses that we find in this list, right? And then we can be able to go ahead and do the following, right? We can say SSH-I and then provide the key. So what's the name of the file where we have that key, right? And then the username. Well, if we already figured out what's the account username, right? Then we can be able to specify that. And then the host. So what is the name of the device we are connecting to? Now we point out right here again, key is the actual SSH file ending in .pem. Username is the account we're trying to be able to kind of control, take over when we go ahead and make this connection. And then the host, that's going to be the IP address that we found inside of the known hosts file, right? And then it says, keep in mind that some SSH keys might be password protected, in which case, if they are, you would have to provide the password anytime you try to use that file, in which case it will prevent you from using that key unless you know what that password is already, right? So that would be one way to do this lateral movement if we're in Linux. Now we're going to see for Windows, we're doing things entirely different, right? But before we move into that, let's see, in the chat, Henry asks, is a BitLocker equivalent used for Linux OSs by some corporations, or is it not commonly used? Let's go ahead, Justin, if you have an answer for that.
So there is a way for data encryption because BitLocker is proprietary to Windows and Microsoft. So I will push it back out in chat. There's another version of it, but you can do disk encryption when you install Linux. I know you can do that, but if you want like what the Linux version of it is, I will put that in chat. Let me just look it up.
Excellent, excellent. So yeah, so that's how we're able to go ahead and do this with Linux, right? So when it comes to Windows, we're going to see that lateral movement is performed by using tools specifically made for Windows, right? So we're going to see right here, two main tools to do this. One we've already kind of been using, right? PSExec, and the other one is going to be titled WMI, right? So right here, you can go ahead and click on this link that they have to find out a little bit more about PSExec. It lets you execute programs on remote Windows systems. Per the PSExec documentation, one of PSExec's most powerful uses includes launching an interactive command prompt when we connect to those remote systems. Now, it says as a tool used by Windows system administrators, the functionality of PSExec has been adopted by penetration testers, red teamers, and is used in standalone tools and exploit frameworks. In fact, this is what we were using when we used our Meterpreter reverse shell. Now, it says something to keep in mind when using the tool is that it leaves traces in our Windows event log on the target's Windows system. So as we've pointed out, right, the more stuff you do, the more you're interacting with the target system directly and using their resources, you're leaving fingerprints, right? So we point out this isn't the stealthiest tool because there are going to be traces that they can find. Now, WMI, our other method for doing this, right, our other tool is Windows Management Instrumentation, is the second well-known means of lateral movement within Windows environments. Similar to PSExec, it allows us to issue commands remotely. We utilize WMI, it was normally performed using the WMIC.exe binary. This binary is now deprecated and is being phased out. So they're no longer using that to be able to do it. We point out, however, WMI MI functionality can still be used within Windows systems, and its functionality has been implemented in other hacking tools like Metasploit. It is somewhat stealthier, although its usage can still be seen in the Windows event log. So what does that mean? It means if you know what you're looking for, you can still see the fingerprints in the log, right? It might not be as many things that are getting logged as PSExec, and so that's why it's a little bit stealthier, but you can still find it and see what's happening and be able to identify it if you know what to look for, right? Now, normally speaking, you would need to have a username and password of a user to access the remote system properly, right? So we already got to first get a foothold in the system, and then we can be able to use these tools to then kind of expand upon that. So you would need to authenticate into that remote system before executing the commands. However, the biggest benefit of Windows environments is that both of these tools can be used with a user's password hash. So you don't need to know their password if you're able to gain access, right? Just get a small foothold and then kind of do what we were doing earlier, right? With dumping those hash values, where we were able to go ahead and do something like load up our Kiwi module in Metasploit, right? And then be able to go ahead and dump the SAM database hashes or something similar, right? Once we get those hash values, we can use that with these tools to authenticate ourselves. And that way the system thinks we're that user, even though we didn't even know what the actual password was, right? So you can become a user just by using that password hash that we're able to find, right? And this is what's known as passing the hash. So we see then down here, passing the hash is technically not a lateral movement tool in the sense of a program like the PSExec or WMIC, right? It's just an action we're able to do, right? These two things, when it comes to PSExec or WMI, those are actual tools that give us that lateral movement. Passing the hash is just a technique that helps us when we're using these tools, right? So passing the hash takes advantage of the flaw that exists with our NTLM authentication that allows us to become the user of whoever's hash we are using without ever knowing what the actual password is. And once we do that, once we authenticate ourselves, so that way the system thinks we're that user, we have access to all the resources and all the rights that that user normally would have access to, right? So we see right here, anywhere that we have to use a password, Metasploit will specifically go ahead and use that. So all we have to do is once we figure out what is the proper hash, we set our SMB pass to that for our interpreter shell we've been using, right? And then it'll go ahead and use that to validate us. So we see then right here, we're going to go ahead and try to establish a interpreter session. We're going to dump the password hashes from our SAM database, and then we're going to try and see if we can pass a hash attack by literally moving from one Windows system to another, right? And then we're going to go ahead and have you guys work on these exercises. So we have this exercise for Linux lateral movements, and then this one for Windows lateral movements. So let's go ahead and take a look. So here, we're going to go ahead and let's clear this. Let's go ahead and open up our MSF console again. And then once that is opened up, we're going to go ahead and try and get our interpreter shell once again, and then take a look at those hashes. All right, so there we see our MSF6. So we're inside the console there. So we're going to go ahead and search. We're going to go look for PSExec. We're going to go ahead and again use 4 because that's the one that they had us using, right? To be able to go ahead and establish our interpreter shell. I'm going to go ahead and set the payload to our Windows x64 x interpreter. Then slash reverse underscore TCP. Let's set our SMB user to administrator. So we can be able to go ahead and get our password hash, right? To be able to go ahead and try and switch over. We're going to go ahead and then set our SMB pass for right now to be the academy. We're going to go ahead and set our SMB domain to go ahead and be EC2 MAZ-L3 OOUG8. And then finally set our host to 172.3.1.49.80, I believe it was. And let's go ahead and run it. We should be able to go ahead and gain access. All right, so we have our interpreter shell. And so if you recall, to dump, we're going to go ahead and first load Kiwi. So we can be able to go ahead and get our Kiwi module up and running, right? To our Mimikatz to be able to go ahead and have that to be able to go and dump our hashes. So now that we have this, we can go, I believe it's LSA, dump, SAM. So those are the hashes, right? We see then right here for administrator, here is that hash, right? For guest, doesn't have one. The default account doesn't have one. Here it is for fstack. And then here we have for administrator 2, right? So I can go ahead and copy this. So I have that hash for administrator 2. Let's go ahead and exit out. Let's go ahead, let's clear this. Let's change our password, right? So I'm going to go ahead and set our SMB pass, and I'm going to paste in that hash value that we just got from that dump. So I'm going to go ahead and do that. And for our demonstration purposes, I'm going to log right back into that same machine, but we're using the hash value now so we can get into administrator 2 instead of administrator, right? So I'm going to go ahead and run. And let's see if it's able to go ahead and do that. So I didn't change the username. So it says, hey, your stuff is invalid. So let's go ahead and set that SMB user, and let's set it to administrator 2. Now let's try running it. And let's see what it says this time. Did I spell it right? So here it is saying that it's having it when it's coming to that authentication. Here our exploit failed, and it's telling us the login is invalid. So let me go ahead. Let's make sure that I did this right. So set SMB user. Let's try spelling this again. So admin administrator, I believe it should be 2. And that should be this account over here. So if we go over here and let's not do that. Let's go here. Let's sign out. We'll see that there are 2 administrator accounts. So there's administrator and there is administrator 2. So we're trying to get into that second one and seeing if we can log into the same device for that. So we've set it up to administrator 2, and we set, let's see, SMB pass, and we should have it with that hash value. So yeah. So let's go ahead, let's try that again. Let's see if it's able to do it. All right, so I'll see if maybe it's because I'm trying to log into the same machine. And maybe we need to be able to go ahead and come over here to Windows 2 to be able to do that. But that's essentially what we're trying to do over here, right? So we saw how we were able to establish our interpreter session like we've been doing. We got a refresher on how we were able to dump out the SAM database so we can be able to see those password hashes. And so now we just got to perform that pass the hash attack. And what we want to do is we want to be able to try and see if we can be able to move from one Windows system to the other. So what we really want to do is saying, hey, if this was the password for this account here, can we be able to go ahead and get into Windows 2? The second machine, did they use the same username and password? So can we be able to go ahead and log into that, given the fact that we have the same username and password as what we had for the first machine, what we're able to pull there, right? So we're going to want to be able to go ahead and do that. So what are you guys going to do for this exercise? For this first exercise, right, for the Linux portion, you're going to go ahead and on your Kali system, you're going to try and become the root user, right? So again, remember how we do that. We're going to change into this directory right here, right? So we're going to go ahead and go into, you should have a account known as compromised user. We're going to go into their home account, go into that hidden.ssh account like we showed you, right? And we're going to look at their .pem file. That's going to be their SSH key, right? Then it says run the following command to use their SSH key and simulate a lateral movement. So we're going to go and execute this right here. We're going to do a SSH with -I. And we're going to go ahead and specifically tell it where that file is, right? So we say, hey, from the root directory, we're going to go into home, into the compromised user, and then we're going to go ahead and have the id_rsa.pem file. That's our SSH key. And then we're going to go ahead and try to log in as compromised user at, and then the same machine, right? So 127.0.0.1. Now keep in mind, anytime you see this underscore, if you see that /, or in this case, the / in front of it, right? It's just the underscore. So whenever you're seeing this right here, for example, with compromised user, or right here with that id_rsa, or again over here with compromised user, it's just the underscore, right? So when we do that, it should allow us to log in with our SSH and show us that we've now accessed that compromised user account. Right. So that's the first exercise. The second one, we're going to kind of do like what we're trying to do here, right? You guys are going to go ahead and open up the Windows machine, right? Figure out what IP address you have for your first Windows machine. You're going to do that interpreter session like we just demonstrated to gain access to it. You're going to dump the SAM database. You're going to get the password hash for the administrator 2 user, right? And then you're going to use that to move laterally. So notice that this time when you do this, there's going to be some parts that we're going to need, right? So we're going to copy down both the LM and NTLM parts of our hash. It says then send that session to the background. So you're going to keep that session open for the meantime. You're going to log into the Windows 2 session. So you're going to go ahead and start your Windows 2 machine like we have right here, right? You're going to open up a command prompt and figure out your IP address. So similar to what you did to the first one, right? IP config to figure out what is the IP address of this machine. And then we're going to establish an interpreter session on that Windows 2 machine. We're going to try and log into that machine as the administrator 2 account using the password hash that you would have copied down earlier, right? So same thing that we did to be able to go ahead and gain access to our interpreter shell for Windows 1. We're just going to go ahead and provide it now with the our host IP address to Windows 2, the administrator 2 account name, and then run it so that way we can use that password hash to gain access to that. If you do everything successfully, then you should have been able to gain access to the Windows system on Windows 2, even though we don't know what the password is for administrator 2. Any questions on what you guys are going to be doing for this? All right, then we're going to go ahead and give you guys about 20 minutes to work on this. The first one should go by rather quick, and the bulk of what you guys should be kind of working on should be the Windows one, trying to be able to go ahead and establish that interpreter session, do the dumping of our password hashes, and then using that to laterally move into Windows 2. If you have any difficulties, feel free to reach out so we can be able to help you out. Otherwise, let's go ahead and open up the breakout rooms and have fun with doing lateral movement.
Hello everyone, welcome to today's session. I'm Anusha Vernikar. I'm the cohort manager for cybersecurity. I hope you guys have had an amazing day so far. Before we get ahead with the session, please give me a quick confirmation if my voice is loud and clear. Am I audible?
Yeah, we can hear you, Anusha. Thank you.
Thank you, Justin. Okay, I have made you and Tony the co-host of today's session. You can wait for a few more minutes. We'll see if more learners are joining, and then we'll get started with the session. Thank you.
All right, hello and welcome to everyone that's here right now. We are going to go ahead and wait for a few more people to join us before we begin. So give it a few more minutes and then we'll get started. In the meantime, go ahead and make sure you guys are starting up your VMs. We should be past the recon VM, past the vulnerability VMs. There should be the privilege escalation VMs now. That's what we're using, right? So make sure you guys are going ahead and loading up that one. It should be, as Justin was mentioning yesterday, that when you go into the privilege escalation VMs, you should see in the top left-hand corner that we have our Kali machine and 2 Windows machines, right? So if you haven't started those up, go ahead and start those up so that way you'll be able to follow along and then be ready for the breakout rooms. If it's safe to do so, if you're not driving, please turn on your cameras that we guys can see each other, we can see you, and vice versa. And we'll go ahead and wait a few more minutes, try and see if we can get this closer to 20 people logged in rather than just the 11 that we have at the moment. And then hopefully within a few minutes, once those people log in, we'll begin at that point.
Hey, Tony, what when did you say to open the labs?
So if we look at the labs, we've moved past the recon labs, we've moved past the vulnerability labs, we should be in privilege escalation. And when you open that one up, you should see there's a Kali machine and 2 Windows machines.
Okay, perfect.
Excellent.
Thank you.
Mm-hmm. All right, we have about 13 people, now 14 logged in. It is 5:35, so we're gonna go ahead and get started. And hopefully those that are gonna be joining us will be joining us pretty soon, so that way we can be able to be on the same page as we begin. So I'm gonna go ahead and share my screen. And we're gonna see that if we go into our LMS for our self-learning track, we are now over here on the right-hand side at 1.12, privilege escalation and lateral movement. And so with this, we're going to see that with what we've been doing so far, right? We learned about recon, so that way we can be able to get information about our target. With that, we then learned about vulnerabilities, right? So how can, as we learn about that target, how can we turn that knowledge into finding out about their weaknesses? Once we know where they're vulnerable, then we try and be able to see, is that vulnerability something we can exploit, right? And so we started learning about different exploits. Once we go ahead and did that, we went ahead and saw how if we exploit something, we can get a shell. And then with that shell, we can do something like getting credentials, right? So we can be able to go ahead and find passwords, password hashes, and so on. And so then what is it that we are trying to do with all of this? What we are trying to do is see how much control over the machine we can get. So we've seen that we can get certain passwords, we can get access to certain accounts, right? But it may not always be that we get total control over the machine. Why? Well, if you recall, even when we're using machines that are, we kind of picture as our own, like let's say our Kali machine that we've been having for our VMs, right? It might be that the account doesn't have the proper authorization or the proper permissions to execute some commands or to be able to do something, right? And so we might have still needed to get into root for the root access that it has, right? Or for Windows, maybe we need to get into administrator, right? Or the system administrator, and so on and so forth. And so that's where our privilege escalation and lateral movement comes in, right? This is going to be how we can be able to move in the same device from one account to another, right? That's privilege escalation, where we're going to be going from, let's say, our Kali account to root, right? So how can I be able to, if I gain access to a basic account, how can I move into getting root access? So now I have complete control over that machine. Or lateral movements, how can I be able to go ahead and move from, if I've already compromised one machine on the network, to then using that machine to compromise another one on the network, right? And so that's typically what these terms mean. With privilege escalation, we're kind of increasing our access, right? That's why we're escalating our privileges. So we're trying to be able to get from a basic account into one that has more authority, more authorization to be able to do more stuff, more permissions, right? And then that lateral movement, we're kind of expanding what we have control over, right? Rather than just over the same device, we're moving from one device to another. And so that's what we're doing now, right? We're checking out how we can be able to go ahead and do this privilege escalation and this lateral movement. So we see then our learning objectives, right? We're going to explain how we can be able to go ahead and find out about these security issues, these risks, these vulnerabilities to be able to help us do this. We're going to see how we can be able to go ahead and find out about whether or not we have these opportunities for privilege escalation or lateral movement happening, right? And then also this technique known as passing the hash, right? So sometimes we're going to see that when it comes time to being able to take advantage of some of these vulnerabilities, if we've already gained access to a system, we can be able to go ahead and gain the pass, not necessarily the entire clear text of a password, but the hashes of those passwords. And if we are able to do things properly, then we can pass that hash value over in a way to be able to take advantage of how Windows NTLM authentication works. And so that way we don't even need to know the password. We can just pass that hash value over and still gain access as if we had provided the password, right? And so we'll see about that as we go throughout tonight. Now, for this first part, we're going to see that we're dealing with our privilege escalation, right? So again, as we kind of mentioned, privilege escalation is the act of gaining an elevated access to the resources on a system. So you've already gained a foothold, right? You found some way that the system was vulnerable. You've exploited it. Now you have an access to that machine. So privilege escalation, we are trying to elevate our access, right? We're trying to be able to get more permissions. We're trying to be able to go ahead and have more control over the same device. Now, in practice, this typically means if we're dealing with Linux, then we're trying to get root access. If we're dealing with Windows, we're trying to get administrator privileges, right? So we see right here, most of the time when you hear this outside, you might hear it where we might refer to privilege escalation as getting roots, right? Or just having root access on the system. Now, as the root or administrator user, you can extract more useful information than normal because you have access to everything, right? For example, as a regular underprivileged user on the system, you may not be able to see something like the shadow file, right? Because only root user can be able to access the shadow file. And so you wouldn't be able to go ahead and get those password hashes, right? But if we're able to go ahead and gain access to those hashes, right, by somehow escalating our permissions to root, then we can be able to go ahead and then pretty much impersonate any account we want, right? So therefore, it is in our penetration tester or red team's best interest, right? So whether we're doing red teaming in general or just penetration testing, to see, can we escalate privileges to gain better access to the system, right? Now we're going to see right here as a penetration tester or a red teamer, your goal is to try and gain access to administrative accounts, right? So these are the type of account names that tend to have these elevated privileges associated with them. When it comes to Linux and Mac systems, typically that account is going to be the root account, right? On Windows systems, there's a variety to what we might hear it being called as, depending, right? So it could be the administrator account. It could just be the system account, or it could be NT authority. And we kind of saw some of these over the past few weeks, right? Especially when we took a look at those processes and who was running them. So we were able to see then some were ran by our NT authority, some were ran by the system, right? And then for some of these exploits, we had to have administrator access. Otherwise, it would say you didn't have the proper authorization. So when it comes to Windows, the names are a little bit more varied, right? But it's going to be typically one of these three. Now, you can also go for users on a system that are in the administrative group. So the account itself isn't technically an administrative account, but as part of the administrative group, they still have elevated privileges, right? So we're going to see that when it comes to groups, these are the group names that we want to pay attention to, right? So root, once again, when it comes to Linux and Mac systems, or you might actually find one called wheel when it comes to Linux and Mac systems. And then on Windows, we're going to see the group is going to be administrators, right? So with an S, a It's plural, administrators. So when we see that, that's typically going to be our administrative group for Windows. Now, if we can gain access to either of these, right, whether it's the account itself that has that elevated privilege, or if we can be able to somehow be included or gain access to an account that is a part of the administrative group, then we're able to go ahead and do a lot more on that machine, because we're going to have a lot more privileges, a lot more permission, a lot more commands that we can execute without it saying we don't have that authorization, right? Now, when establishing the command and control of a system, it is unlikely that the very first foothold you get will be as an administrative user, right? Typically, you're going to get something like a basic underprivileged user, maybe the guest user, or if you access it through the web, maybe just the web service user, right? So it might be something like www-data, right? Instead of an actual full-fledged user account. So you'll start with limited privileges, and then you have to try and escalate the privileges that you have to be able to go ahead and get higher, to get to those administrative levels. Now we're going to see right here, we're going to take a look at how we can find out about escalation. What can we be able to do to figure out what is available? What weaknesses are there that we can be able to exploit to be able to go ahead and kind of increase our permissions, right? So we're going to see that the techniques for privilege escalation tend to be one of the following. Number one, we can gain access to a user account with administrative privileges, right? So if I already have a foothold, I somehow find a way to switch over to another account that already has those privileges, right? Now, how can we do this? Well, there's a few different ways, right? We see this right here. So we could do password guessing, right? Maybe we know a little bit by doing our recon about that person's account. Maybe we know a little bit about that person themselves. Maybe their birthday, maybe the name of their spouse or something similar, right? And so we could try guessing passwords. And if they're not using proper password security, we might be able to guess at that and be able to gain access, right? Or maybe we have a password that's been compromised, and so we were able to know what it is already. Maybe they've accidentally posted it somewhere, or they had it in a file somewhere, and we were able to gain access to that and be able to see it, right? Or maybe we somehow got the password hash and we're able to crack it with John the Ripper or something similar, right? Of course, there's also user account control bypasses and so on. So there's a lot of different ways we could be able to do this to gain access to that account. The second is we could exploit a vulnerable program on the system. They can possibly go ahead and give us that access, right? So we've seen before this concept in Linux of our SUID bits, right? So we say right there, when we go back, if you remember when we were dealing with this in Linux near the beginning of our boot camp, we said that we could set up a bit for a file, right? Where it'll run the file as if it were the owner, regardless of who's running it. And so if the owner has root privileges, right, then we could possibly try running that file. It'll give us temporary access to root privileges, and then maybe we can be able to use that in some way, shape, or form to then gain access to a root account or some other one that now allows us to be able to expand our privileges, right? In Windows, it'll be through DLL hijacking, right? So we have these ways that we might be able to run the programs themselves. These programs already have the privilege kind of built in to themselves, where if you run this program, the program will have that permission. And so then we're going to use the program's permission access to then grant it to ourselves. And then, of course, the third one that was typically done is an OS vulnerability. So something that's vulnerable within our operating system, right? That can help lead us to getting those administrative privileges. So some examples of these type of vulnerabilities we see are named here: Dirty Cow, Polkit privilege escalation, or Dirty Pipe, right? And we say, please note that these exploits sometimes have a likelihood of crashing the system that they're executed on. So we got to keep that in mind, right? They're not going to be perfect. They're not going to be able to be unnoticeable a lot of the times. It's possible that as we run them, the system crashes. And so it'll be very noisy, very noticeable when we do that. Now, there are several techniques that can be able to go ahead and be used to escalate your privileges, which, if you recall, I believe it was Justin that went ahead and showed us about the meter attack, the attack framework. So we see this documentation right here. If you click on this link, we'll see that it'll take us to this website, right, where it talks about privilege escalation. And we see a few of the different techniques, right? For example, here it's talking about that set UID bit again, right? Here we can be able to abuse elevation control mechanisms, and so on and so forth. We have a total listing here of recognized ways that we might be able to go ahead and just switch from one account to gaining more access than what that account initially had, or switching to an account that's already having it built in, right? So there's a lot of different ways we have right here that it mentions. You can go ahead and take a look at this at any time. You can click on any of them and get more information about it, right? So for example, reopen applications, we can click there and kind of see exactly what are they meaning by this, how this allows for that, how we can mitigate this, right? And how we can detect it, and so on and so forth. Now we're going to say, luckily, there are some open source scripts, right? And there's also Metasploit modules that can help us check the system for privilege escalation vulnerabilities. So similar to what we saw with Nessus, right? Nessus was some software that we could run against our system to see if it could find some vulnerabilities for us, and where was our software, our defenses weak, and then how we could be able to handle that, right? So a similar thing is for when it comes to these privilege escalations. There's some scripts that are open source we can be able to go ahead and run, that they'll go ahead and scan our system and kind of try and give us an idea of what is happening on our system, how what is happening or the configuration that it has could be exploited to grant somebody privilege escalation. And then from there, we can kind of figure out how to be able to go ahead and mitigate that so that way we can prevent that from happening, right? Now we're going to see for tonight, we're going to learn about a particular one, a popular Python script that's going to be used for checking this privilege escalation. And it's very straightforward named. It's known as the Linux privilege escalation checker. Now, once this script has been put onto a system, it can be executed to be able to check for potential escalation opportunities. Now, inside of Metasploit, right, we can be able to have a module as well. Now, throughout these things, it seems like that they have this error, right? So if you see this where you got that backslash and then an underscore, ignore the backslash, right? So we see this right here. The module is going to be under post /multi, right? And then /recon, because we're trying to scan, we're trying to get information about the system. And then this would be local _exploit _suggester. So if we were to load that up in Metasploit, we could also use that to scan Windows systems to see how we can check that for escalation vulnerabilities that might be there, right? So for Linux, we can be able to use the Python Linux privilege escalation checker. For Windows, we can be able to go ahead and use our Metasploit module that's named here to be able to go ahead and scan Windows and look for that as well. So for our demo for this first one, we're going to go ahead and kind of run that script, right? And we're going to take a look at it and kind of see what the information is there. And then you guys will go ahead and do your first exercise where you're going to go ahead and use that to try and be able to go ahead and escalate into reading some information that only the root user should be able to do, right? For your Linux. And then similar thing for when it comes to your Windows privilege escalation, right? So for Windows, you guys are going to go ahead and similar to what we've been doing this week, right? You're going to start off with trying to set up a interpreter shell. So this is the same thing that we've been doing since Monday, right? Going into MSF console, going ahead and loading up the proper module, the exploit that we want to be able to have for that, setting up the proper information for the username, the password, the domain, the R host, right? Setting up the payload to the 64-bit script that we want to be able to use, and then being able to go ahead and trying to run it to gain access to the Windows machine, right? Then once you've done that, you're going to follow the rest of the instructions here to try and be able to go ahead and escalate your access into, instead of being what we initially logged in when we gain access to that system, to trying to be able to go ahead and gain access to the system account, right? So you're going to be doing those two things. So let's go ahead and take a look at that script. So the first thing we're going to see is that the script is located here, right? Inside of /op/Linux priv check. So I'm going to go ahead and exit out of this. Want to clear, and let's go ahead and go back. So if you recall, if I just hit CD, our change directory command, and hit enter, that should take us back to our login directory, right? Known as that little tilde symbol for the shortcut. Now, all I had to do was change directory, right? And then go /opt, right? So this is kind of like our optional stuff that we've installed onto this machine, additional modules we can be able to have installed for Linux, and then and then Linux priv check. Once we go there, if I do an ls, you should see these three files, right? readme.md, Linux priv checker 3.py, that is going to be our script, right? and then the old Linux priv checker. What you won't see at the moment is this file, results, because ahead of time I already ran the scanner and I put the results into here, right? So we can be able to have a quick way to be able to take a look at this. Now, how would I run the scanner? Well, if we look at our LMS, we're going to see that it tells us, right? It says, hey, once you're where that script is, run it using Python 3, right? So the script doesn't have it like I've been doing, like I've shown you guys for our scripts, right? If we cat out, or let's actually use head, let's say the first 10 lines of our Linux priv checker script. Well, actually, it seems like it does. So we see right here, it has this shebang, right? Where we're going ahead and trying to be able to use Python 3. But at the moment, you'll notice that it's recognized as just a regular file. It doesn't have execution privileges, right? So that's why our LMS is suggesting, instead of trying to be able to go ahead and run it like we've done with previous scripts, right, where we can just go / in the sample name, we can be able to go ahead and say Python 3. So there we're explicitly stating, what do we want to run this with, right? So we're saying use Python 3, that interpreter, to be able to go ahead and run this file, right? And so if I type in just that Python 3 in the name of my file, it'll run it. And so you'll notice that it stopped right there because it's still working on stuff, but it's providing a lot of information. So we're going to have you guys do that. I'm going to hit Control-C for right now. So you'll see that I stopped it before it finished. It was enumerating files and directory permissions and so on, but I stopped it. But I've already went ahead and saved everything to results. So let's go ahead and take a look at this. So we're going to see when we run this, it goes ahead and runs our privilege escalation checker script, right? And it starts to get basic information about our system that we're running this on. So what is the operating system? Well, we're able to recognize that this is Kali, right? What is the kernel? So this is kind of like the beginning part of our operating system, the core portion of it, right? Well, it's running a version of Linux, version 5.15, so on and so forth, right? And we see all that additional information. What is the host name, right? So we see that this is Kali. And then we see that it starts to get our network information, right? So we're able to see, for example, what is our IP address? What is our network subnet mask, right? So on and so forth. We are seeing all this information about our network. We can see even our routing table, right? So this is starting to get pretty deep into networking information. But we see our routing table. So we can see, for example, what is the gateway, the default gateway it has. This is how it's able to access, for example, the internet and other things outside of its network, and so on and so forth. We see it even ran netstat, right? So netstat, if you recall, one of the ways we can be able to look at all the connections that are happening on our machine, right? So we can be able to see all the different connections on here. It has quite a few compared to what it might typically have because we're running this over the internet on a VM, right? We then see that it starts getting the file system information, right? So we start seeing about how's our hard drive mounting certain file stuff, what is the system information that it's using, and so on, right? So we're able to see all that information there. We start getting into right here, scheduled cron jobs. So we can start taking a look at those cron jobs. What scheduled, what days, what times, what scripts is it running, right? Things like that. So we're able to go ahead and kind of take a look at that as well. Scrolling down further, we see right here, system MD timers, right? When do they last happen? When do they pass these things? We see what is the current user? Well, I ran this while I was in the root account, right? I went sudo -s to go ahead and run this script and save the results into the same folder. Mainly because since I wanted to save the results into this directory, Kali or underprivileged accounts don't have permission to write into this directory, right? So that's why I switched into the root user. So it shows us, hey, who was the current user when we ran this script? It was the root, right? What is that user ID? So it shows us based on their information, what group are they a part of? What is their group ID? What is their user ID? Root is typically going to be 0, right? We then see essentially our information for the Etsy password file, right? Where it shows us all of our users and our user information. So we start seeing all the users here, right? All that user information. As a matter of fact, let's scroll back up. we'll see from earlier this week, right? The users that we added to this. We see compromised user, and then the ones that I added on Wednesday, compromised user 1, compromised user 2, so we can be able to try and crack their passwords, right? So we see those users there. We see right here, it tells us who is the super user, right? So that's going to be the target, so to speak, in our privilege escalation, right? This is the one that's going to have ultimate access to everything, all their privileges. So if we weren't a part of this account, this is the account that we'd be trying to go ahead and escalate into, right? So it lets us know who that user is, what is the name of that account, right? Right here, the root and current user history. So it kind of shows us that right there. And then it shows us our environmental variables, right? So if we go back to the beginning of our Linux stuff, we did go ahead and briefly talk about these environmental variables. This is what's set up kind of by default when our machine begins. So that way certain things are already recognized, right? So for example, when we load up, if we load it up into root, then it knows that the user is the root one, right? It knows root's home address, that the home directory for it is /root, and so on and so forth, right? So it sets up all this information there for it. We can then see right here, the privileged account, right? So this is in Linux typically going to be sudoers. So we start seeing information about that sudoers account, right? We can be able to see logged in user activity. So we can be able to see, for example, I was logged in as Kelly, right? And I do have a shell open where I ran sudo -s, right? And since then, what's happening? Well, we see then I have two things open for root, right? So far, we're able to see what is it that's happening on this machine? What's the activity, right? If we had anything for SSH, we'd see this here, right? So we have our SSH agent connection. We're able to go ahead and scroll down further here. It says, are you sure you're not root already, right? So if we weren't already logged into root when we ran this, it'll go ahead and kind of give us some information here about what we could do to get into root, right? And then finally, we saw right here that it starts to enumerate file and directory permissions and contents. So this part's kind of what we were talking about earlier, where we said, hey, if we may not be able to gain access to the accounts that have administrative access, maybe there are some files that have like the SUID bit activated, or they are able to be ran as the root user. And so we might be able to use those files to give us access, right? So here we're seeing that we're going to enumerate through these files, through these directories to see if there's anything like that that we might be able to do, right? And where is it located, right? So for example, we see here are some files that are owned by root, right? And we're seeing their location. So we're able to go ahead and kind of see what's happening and where they're located so that we can take a look at those, see if any of those could possibly be used to give us access to root, right? We see right here, writable directories for users other than root. We're able to see where those are. World writable files. So where can everyone be able to write to, right? We see right here, specifically SUID and SGID files and directories, right? So we're able to see all those specifically. Where are they located? And then if we go scrolling down even further, we see right here, checking if root's home folder is accessible. So they go ahead and try and see, can we actually look in there? And if we can, what can we see? So it's showing the contents of the root home directory, right? And what's in there. So we're able to go ahead and kind of see all that information as well. Now scrolling down even further from there, because of course we had root access, right? Since I was already logged in as root when I ran this script to scan it. So after it goes through one by one and kind of looks in all the directories that we have there to kind of see what is in the home directory, what files are there, what's available. We're then able to go ahead and go a little bit further down, and let me actually go ahead and move over to the right here. And let's see if we can be able to do this quicker. So all of this stuff that we're looking at right here is what I had Control C out of before, because it can take a little while. And this is why I ran this ahead of time. So let's see. And then, let's see, towards the bottom, we should be able to go ahead and finish this out right here. Well, we'll leave it at there. It's a lot of information that we're going to see that's there. Again, it's going through all the different files. It's going through all the different directories, everything that you can be able to access to kind of show us what's there. Because again, any of these things could possibly be an entry point for us, right? We may see that, hey, maybe there's a file that we can be able to access that has information. Maybe it has compromised passwords. Maybe it has hash values for us. Maybe it's able to be ran as an SUID bits. And so we can be able to go ahead and execute that file and be able to have it give us access, because the file when ran is ran with root privileges, even if our account doesn't have that, and so on and so forth, right? So running this script, we see that we're able to go ahead and gain access to all this information. And then it's kind of up to us to kind of sift through it, pick it apart, and figure out what could possibly be vulnerable and what isn't, right? Finally, we get right here, the next part, we start seeing that it gave us access to the shadow file. So we see right here, with access to the shadow file, again, if we go and we see that there's something like this, right, then we now have that hash value. So right there, we have this hash value for this account. We can try John the Ripper to go ahead and crack it, right? If we scroll a little bit further down, we see the ones that we had earlier for user 1, compromised user 2, right? And so on and so forth. We can see right here, we have scripts. So these are saying these are SH or shell scripts containing keyword password. So somewhere in these scripts, it finds the word password. So it might be something that we can be able to go ahead and use, or it might be somewhere where you can be able to go ahead and put in information that we were able to get from above to try and be able to go ahead and escalate, or to be able to go ahead and run these scripts and then use some of the passwords or the information we gained earlier to be able to go ahead and run it as if we were those users, right? And gain permission from there, and so on and so forth. So again, all that information is there available for you guys. And it's just a lot of information, right? So we see right here, it tells us finally at the end, finding relevant privilege escalation exploits, right? And it kind of goes through and says the following exploits are applicable to this kernel version, right? And should be investigated as well. So you can be able to go ahead and take a look at what it tells you and kind of have an idea there of where to kind of try and attack this. So how is this going to help us for our first exercise? Well, we're going to see right here, again, for the first exercise, right, we're going to try and be able to go ahead and use this on our Linux machine. So you guys are going to go ahead and try running it yourself, right? Try doing that privilege escalation yourself, where you're going to run this scanner. And it says the privilege escalation vulnerability program contains a command injection vulnerability. So once you go through this on your own, you guys are going to sift through this information. You're going to try and be able to see, can you find in that output, right? Which you guys should know how to do if you remember our Linux commands, right? Especially if you're able to save it into a file like I did here. So how can we be able to go ahead and search through the contents of that for the privilege escalation vulnerability keyword? Once we see there's going to be that it'll mention a program that we can be able to go ahead and run, right? Which will allow us to do command injection. So Justin showed us an example of this when we were going over our vulnerabilities. So we can be able to go ahead and try and run a program the way that it was intended, but we can include something like a command, like Linux commands, right? And see, does it run our command as well? So we saw that with that website where he was able to ping a machine, but then he was also able to say, hey, could we be able to go ahead and do something like print out the working directory or show cat out etc password, right? Stuff like that. So can we be able to go ahead and inject a command so that way we can get that program to display to us etc shadow, even though we're not the root account, right? So that's gonna be the first part. And the second part, just like we mentioned earlier, you're going to use the exploit we've been doing so far for this week, right? Where we can be able to go ahead and set up that interpreter reverse shell into the Windows machine. And then once you're there, we're going to go ahead and it tells us you're going to migrate, right? You're going to go ahead and once you're in the Windows machine, open up Notepad, kind of like how we did in our demo back at the beginning of the week, right? And then migrate over into Notepad. And then you're going to go ahead and look up, research how we can then set that interpreter session to the background command, right? So it's a pretty key word right there, right? Background. So if we type in background, we should be able to go ahead and have it go back. So we can be able to go ahead and do other stuff. And then we're going to go ahead and take use of this post module, right? So we mentioned that exploit allows us to gain entry into the machine, but there was also post modules that are stuff that we can do once we have that access, right? So what can we do after the fact that we've gotten this foothold into a computer? So we're going to then look at this module right here in post, and we're going to go ahead and have it work with our interpreter session, right? So that way we can then be able to go ahead and follow the rest of the instructions here to try and be able to gain access to that system account, right? So we're going to try and see with that post module, can we be able to go ahead and take control of the system account? Any questions so far on this concept? So with privilege escalation, or what you guys have to do for this first exercise? All right, then I'm going to go ahead and stop sharing my screen here. Let's go ahead. Let's start with our breakout rooms for 30 minutes, let's say, and then we'll go ahead and jump in, see how you guys are doing, see if you guys were able to go ahead and do both portions. And if you guys need more time at that point, we'll give you more time. If you're not able to finish it within the 30 minutes, don't worry, don't stress, right? It can be a little bit not frustrating, but it can be taking some time when you're first starting off with privilege escalation to see how can we be able to go ahead and take advantage of these vulnerabilities to be able to go ahead and gain access to these accounts, right? So the first one, you guys should be able to do it relatively easy, right? For the Linux machine, we've kind of shown you how to be able to run that script. Then you should know how to be able to look for that program for that vulnerability and to do our command injection to take a look at Etsy Shadow. The Windows one is going to be the one that's going to take you a little bit more time to try and gain access to that system account, right? So again, we'll go ahead and open up the breakout rooms. If you guys have any difficulties, always feel free to reach out, be able to go ahead and ask us for help. Otherwise, have fun. All right. Hopefully you guys were able to go ahead and work through that. If you guys weren't able to get it, that's fine. We're going to go ahead and demonstrate it real quick right now and then see if there's any questions that you guys may have. And that way we can be able to wrap up tonight's session with being able to see how we can be able to move laterally in these fashions, right? Let's go ahead. Let's take a look at my screen. And the first one we're going to do is we're going to show how we can be able to go ahead and do our Windows lateral movements. So here we see that how we were able to go ahead and set up our interpreter shell just like we've done before, right? So we see that I set the R host. This is to our first machine, right? So this is Windows 1. We can see that right here. And then we set our password to Academy, our username to administrator. The domain was already set as it was before. And so we ran this and we were able to get our session opened up. And then we're in our interpreter session, right? Now I do apologize. One of the ones we showed you, right? We said load Kiwi. And we said one way we can be able to see some of these hashes was to do LSA dump and then SAM. And we do go ahead and see some password hashes here. This is only part of what we're actually going to need. So we do need this right here, but we also need more than just this, right? So we can in fact do the hash dump. So remember, we showed you both of these previously, right? We showed hash dump and how that can be able to go ahead and give us a dump out of all the different accounts and their stuff. But we also then showed how we can be able to dump the SAM database just by itself, right? So we do a hash dump, we get this, and we're going to see that we're going to need this portion right here, which is what we saw up above, right? You can see that right here. It says E13 ends with B5AB, and we see that what we've highlighted as well. But we're also going to need this part right here that comes right before it, right? So we're also going to need this portion as well. So if we highlight the whole thing, and we said that first portion was our LM hash value, which we said isn't really used anymore. So it's just that same placeholder for all of these, right? So we're going to go ahead and copy all of that for administrator 2. And then we can be able to go ahead and exit out. So let me go ahead and delete what was accidentally copied here. We're going to type in exit. So we've closed out our interpreter session. I'm going to go ahead and clear this so we can see a little bit better. And now we're going to go ahead and set our SMB user to administrator 2. We're going to set our SMB pass. We're going to have both of those values now, right? So we're going to see that all we did was get that first part all the way up into the colon, and then the second part, which is the actual password hash, right? So both of those together, and then we're going to hit enter. If we show our options, we see that it does show both of those, right? We see that right here. So it has those just one right after the other, just as it shows, right? And then the other thing we're gonna have to switch is our target, the R host. So let's switch it over here. We see this is the one that we want to be able to use for the second Windows machine. So 172.3.1.5.6.248 is the one that I have. So we're gonna go ahead and say set R host 172.3.1.5.6.248. And so now we can run this, and we see that it was able to get through the authentication, right? And it's going through and forms our next session. This is now on Windows 2. So we've gained our access to Windows 2, and that's kind of what we were trying to do, right? We were able to see, once we went ahead and started up the second one, could we be able to log into Administrator 2's account and be able to go ahead and have it use the hash that we discovered from the first machine. And once we did that, we said, congratulations, you were able to move from one Windows system into another. And that's what we just did. Any questions with that so far? All right, so let's go ahead and take a look then back to our Kali machine. Let's exit from here. Let's exit out of our console. Let's go ahead and clear this. And we said, let's move into our root account, right? So we're here in root, and we said, let's go ahead and move into /home. And we take a look right here. Here is our compromised user, right? So we're going to go ahead and switch into there. We do an ls. We see there's nothing there. Let's go do an ls-a. We find those hidden files. We were specifically trying to get into our SSH. So we're going to go cd.ssh. If we take a look in here, here are the different files that we see. We see our authorized keys. We see our PEM file and our pub file, right? The PEM, that's our secret key. That's the one we want to be able to use for SSH, right? So that's what we're going to go ahead and use in that first part. So if you go right here to our Linux lateral movement, it said, let's go ahead and issue this command with that key, right? So we're going to say SSH, as a matter of fact, let's clear this. I'm going to say SSH-I, and we're going to go ahead. We can actually be able to go and either do like it shows here, where we're going ahead and specifying the whole thing here with a absolute path, or we could just, since we're in that directory already, right? We could say id_rsa.pem, and then we're going to go ahead and sign in as our compromised _user at 127.0.0.1. And we see, let's see here. See, it says right here, remote host identification has changed. It's possible that someone is doing something nasty. So here it's saying that we were able to detect that something is a little bit different. Here it says the fingerprint that was sent by the remote host is this, and that's different from what they regularly normally have, right? And so let's see. Is there something else we should be doing? So there it was kind of detecting it. Yes, go ahead.
Yeah, so I was trying the same thing. I had to go to the known host folder and then get rid of the old record to be able to log SSH into it.
Excellent. So what's happening here is when we're trying to do an SSH in, it's coming back with this value right here, saying, hey, I'm going to send you this value. Do you have that as your recognized host? And as it's kind of telling us here, it's telling us that, hey, that value has changed. So what we have inside of our file as a recognized authenticated hosts, it's not matching up with what's being sent to us. It's different. So as Min just mentioned, right, if we go ahead and take a look here, we have these authorized keys, right? So let's go ahead and let's see. If we were to go nano, we see right there, these are the values that are going to be kind of recognized, right? This is what's going on. And so you said, Min, you got rid of that file, or you modified it? Was that it?
No, you go to the root SSH and known host, and then just get rid of those entry in the known host.
Okay, so
you see
yeah,
that?
that would be correct. All right, so since we are logged in as root, as Min just pointed out, it should be that we're inside of here. And if we look here into our .ssh file here. So we're using these informations here when we're logging into anywhere through the root account. And so we're taking a look here, and we're going to go ahead and move this. I'm going to go ahead and say, let's move known underscore hosts to older known hosts. And so that's getting rid of the file. As far as it knows, there's not a known host file now. So it should be able to go ahead and say, okay, I'm trying to connect to this. There's nothing to look back to compare it to, right? So that's what was happening. It was looking at what was already known, what was saved before, seeing what value was coming back when it was making this connection and saying, hey, these are two separate things. Somebody might be trying to be able to play you dirty, right? Somebody might be doing something fishy. And so it wasn't allowing us to do it. But if we get rid of that so that way it doesn't have anything to go ahead and compare it back to, then we can be able to go ahead and try and run this. We see that now it looks like it's the first time we're connecting to this device. So it says, hey, are you sure you want to connect? We can say yes. And then we're able to get in. And for here, it's telling us that permission is denied, not because we couldn't connect to it, but because the public key that we were using wasn't recognized, right? So there should be some, there might be some issues with that. We'll take a look at that, kind of see what's going on there. But that's kind of what's going on with us, right? We are able to see that, hey, if we have the right information, if we were able to get the right file, then it's going to allow us to be able to go ahead and get in, right? Any questions on how we were able to go ahead and do that with the Windows machine? All right, any questions for in general? John, I see your hand is up.
Hey, Tony. Yeah, I had a weird issue where the Windows machine 2, I couldn't connect to it. Like I couldn't even ping it on the network. I double checked the IP address using ipconfig. I couldn't ping it from Kali and I couldn't ping it from Windows 1, but I could ping Kali machine from Windows 2. So it looks like it's on the same network, but I just can't find it.
So with that, I would say if it's not communicating correctly in both directions, then kind of like what Justin was mentioning earlier, if the communication isn't happening to where you can't ping it, try shutting down the labs completely and then starting them back up. And hopefully when you restart it, the connection will then be established correctly and they should be able to communicate just fine.
Got it. Okay, I'll try that later. Thanks.
Any other excellent questions or comments or concerns like that?
Hey, Tony,
All right.
I just noticed the reason you were failing because you weren't using the compromised SSH key, public key. You were using the root public key. So
Thank you. I just realized once you pointed that out, yeah, since I wasn't using the absolute path to that file, it was
that's
using
right.
the wrong one.
Yeah.
So yeah, if we were to go, as a matter of fact, let's go ahead and share my screen. Let's make that correction. So when we were using the file earlier, we were in compromised user's account. So I was going ahead and using a relative path to the file since we were in the same account, right? But now we went ahead and to be able to mess with our known hosts so we can be able to connect appropriately. We switched our directory and we didn't change the access to that file. So if I were to go ahead and say right here, /home/compromised user, and then and then leave it .ssh, and then / our ID underscore RSA.pem, that should give it that absolute path to where the correct file is. And so if we run this, it should allow us to be able to go ahead and get in, and we see, bam, we got in as our compromised user. So thank you for pointing that out, Min. Excellent eye. Any questions whatsoever with how we were able to do that? All right. If you guys do have any questions, Justin and I will stick around a little bit so that way we can be able to go ahead and address that. If you guys don't have any questions, have a wonderful weekend. We'll go ahead and see you guys on Monday to continue with our journey.
Thank you so much, Tony and Justin. Thank you all for your participation. The survey link is in the chat box. Make sure you read the session and give your valuable feedback. And I'll see you on Monday. Have a great weekend and good night, everyone.
Excellent. Good night and have a great weekend.
Anusha, did you still want to hang on and talk about
Oh,
that?
right. Yes.
Because I feel like there's several of us more than responded in the chat that have
Mhm.
trouble with web version. And when you run the web version, sometimes the problems aren't initially apparent, but like sometimes when I go into the breakout rooms, all of a sudden
Mhm.
some peripherals aren't working. And I'm wondering if we can just, I know that you said there was like an attendance recording
Issue.
issue
Yes.
Zoom link. Is there
So
some other thing we can do to help you with the attendance so we could still use the Zoom application? Because it seems more stable for a lot of us.
okay, so tell me, every time you use a Zoom link to join the session, is the attendance captured in your LMS?
I honestly don't check every time.
Mhm.
It's just off the top of my head, it seems like sometimes it captures, sometimes it doesn't.
Okay, is there anyone else who would like to answer if it was capturing the attendance or not? So this has become a main issue that every time you join from a Zoom link, the attendance is not captured. We have to check and then uh, unlock your courses or certificates accordingly. So I've definitely am considering this. I'll escalate this and let them know that you are facing issues joining through the LMS. And if there is any way that you can mark the attendance and still join through LMS, I'll definitely have a discussion over this and get back to you on Monday or post it on Slack channel before Monday.
Thanks, Anusha. Like off the top of my head, some of the people have already left, but it was
Uh-huh.
at least I think it was me, Ryan,
Ryan,
Pam,
yes.
Alex.
Henry.
Yeah. Um, yeah, and if you could just I appreciate you asking that, but please understand the priority for us as students is being able to participate and see and talk and share our screens and do all the things we need to do to learn the materials from the class. So if they could find any workaround where we could still use the Zoom
Mhm.
link, something
Yes,
that's
after what happened yesterday, I've already pointed this out, but we wanted to check it again if this still continues and then make a decision. So I'll definitely have a look into this.
got it. Appreciate it. Thanks again, guys.
Thank you.
Thanks, everyone. Have a good night.
Have a good night.
Okay, I had just a really quick, simple question. I was just wondering what the actual time frame is like to utilize lateral movement within an organization. You mentioned before that in this class that typically like you want to increase the layers of privacy and security so that way a malicious actor will probably give up and just to maybe target an easier fish, an easier target. So if a malicious actor was utilizing lateral movement within an organization, say targeting Google or something, how long does that actually take to do what we just did on at scale?
Well, if you think about it, you're a bad guy. You're trying to get into a network, so you're doing your scans, right? You're recording your scans. You're making notes of where everything is, and then you're looking to find those vulnerabilities. You got those vulnerabilities that could be out there. You're looking up CVs. You're looking up what can be compromised, and then you attempt to get in. So once you get in, you need to make a foothold so that you can come back in if somebody drops your connection. So you may be sitting there, you might be scanning more, but you don't want to make a lot of noise because when you make noise, then you can get detected. So it could take weeks, months to
Years?
usually years. It's possible, but people upgrade equipment, stuff changes, computers get upgraded, servers, firewalls. So it's usually like weeks to months if somebody's trying to compromise a huge network. Um, yeah, days to weeks to months is usually what it's going to take for somebody to get in the network, start finding where things are, to start moving laterally, making their foothold so that they can get back in there. A lot of times with the ransomware, they get in, they find what they want, they make the backup of it, they throw their code out there to encrypt it and bounce. So at that point, they don't care if they're detected, they're just getting out. So
Yeah, I mean, I'm assuming at that point they want to be noticed, right? In order for them to get payment.
They just don't care. They're just bouncing. They're like, okay, we did what we want to do. If you pay us, if not, then your computer's locked down and you have to reformat it. Hopefully you had a backup. But yeah.
Okay, cool. Thank you. Yeah, that was my only question. I was just kind of curious about that as we were going through the exercise, like, you know, the actual time frame. But thanks for class, guys.
Yeah, no
Hey,
worries.
Robbie, I had a question for you.
Sure.
Can you please? I checked your LMS and then I saw it was you have only certified one, that is asset and inventory management. Do you have any other email ID that you log into, or is it the one that says Flores Robbie 90 at outlook.com? Something.
The Outlook email was the initial one I used, but when I was having
Mhm.
this problem before, I asked them to use a different email, which was my Yahoo email. As far as my attendance, yeah, even though I've been filling out the competencies throughout this whole course, I mean, yeah, for months, it just hasn't been recording my attendance. I stopped caring though, just because as long as I had access to the recorded video, that's really what I
Mhm.
cared about most. And I'm assuming that in the back end when this boot camp is over, that I was going to reach out and just make sure that you guys
Okay.
manually opened and certified
So
those
keep a
modules.
track. So keep a track on your cohort, I mean progress of the course. I need your email ID. Can you just share it to me over Slack?
Sure, no problem.
Okay. Thank you.
Thank you. Have a good night, guys.
All right. I'll go ahead and see if I can
Good night,
finish
Robbie.
grading the submissions that they went ahead and sent for the last career simulation. So hopefully by the end of the weekend,
Yes,
that should
I
be
saw
done.
there are a lot of them.
Yes.
Mm-hmm.
So that would be my goal for this weekend. So by Monday, that's done. And we'll see you guys on Monday.
Sounds good. Thanks, Tony. Thanks, Nusha.
All right.
Monday.
Thank you both. See you on Monday.
We'll see you then. Hello and welcome to everyone that's here tonight. It is already 5:30. We're going to go ahead and wait just a few minutes. There are some people that are having issues with being able to go ahead and sign in. So we're going to try and see if we can be able to help them out. Hopefully they're able to go ahead and find that live session link that Justin was posting about to be able to go ahead and join in through the LMS. So we're going to go ahead and give it just a few more minutes, allow them to be able to go ahead and join. That way we have the most people possible here for when we start. And then we'll go ahead and get into our next section, which we're going to see is how we can be able to go ahead and start making use of those exploits we were learning about on Monday. And then what can we do with that, right? So now that we have unfettered access, so to speak, right, with that account that we were able to get in because of our exploit, what can we do with that? What's something that we can be able to go ahead and follow through with? And so we're going to see that our next unit is going to be dealing with credential collection, right? So that way we can be able to go ahead and kind of move from the account that we're in to other ones. So give it a few more minutes. We'll allow more people to go ahead and join us. We'll start helping out or see if we can be able to help out those that are experiencing issues. And then we'll go ahead and get started on credential collection. All right. There's an excellent question. Antonino says, in the reconnaissance lab, do we log into Kali or Windows 2016? So I believe for tonight's lab, we should actually be moving into the third one, right? So the very first one we started with when we got into Red Team was the recon lab. And so that was to be able to go ahead and learn about how we can be able to start gaining information about our target before we actually start attacking our target, right? And then from recon lab, we moved into the vulnerabilities lab to go ahead and see how we can be able to go ahead and find out what weaknesses our target has before we start to exploit them, right? And so I believe now that we've moved past vulnerabilities, right, that we should be able to go ahead and see the next lab that we're moving into goes beyond even that one. We started on Monday with using this lab, and so the third one should be privilege escalation lab, right? That one's the one that we're going to be taking a look at, I believe. So we shouldn't be in the recon lab. We shouldn't be in the vulnerabilities lab. It should be privilege escalation lab, I believe. And at that point, we should see that there is a Kali machine, and then there is 2 Windows machines, right? And I believe for right now, we'll most likely have you guys just start off with Kali, and then we'll go ahead and if need be, we'll have you start the Windows ones. But it should be that we are in that privilege escalation lab at this point. Justin does bring up a good point, though. If you want to be ready, since the privilege escalation lab does have a Kali machine and it does have Windows machines, you could go ahead and start up at least one of the Windows machines and your Kali machine, because chances are we are going to be having to go back and forth between them, right? Sort of seeing what's happening on our target end, seeing what's happening on our attacker end. So if you want to go ahead, you guys can go ahead and start up the Windows machine and the Kali machine for that one. But we should be in privilege escalation.
Thank you, Justin.
All right, so it is now 5:36. Right now, it looks like we barely have 12 people logged in. We are still trying to see if we can be able to go ahead and get more people to be able to go ahead and log in. There's still some people that are experiencing issues. But for those of you that are here, we don't want you to be wasting too much of the time because, of course, your time and our time is precious to us. So let's go ahead. Let's begin. We'll still be trying to see if between myself and Anusha, if we can be able to help O's that are experiencing issues be able to log in. Justin is going to go ahead and show us the next unit. So we're going to go ahead and have Justin take over, and he'll go ahead and show you guys how to do credential collection. So Justin, whenever you're ready, feel free to go ahead and begin tonight.
I believe everyone should be able to see my screen now. We good? Yep, good. So we had a knowledge checkpoint that was just done to be completed on Monday night. So over the last 2 days, did everyone get that checkpoint, that competency checkpoint completed? Do we have any issues on that competency checkpoint? Any parts of that you want to go over real quick? Got some thumbs up, nods. Okay. So this portion, we're going into actually looking at how can we grab credentials, information from the PC, from either your Kali or your Windows-based operating system, and some of it's already saved on the computer. So how can we look at it? How can we use some embedded tools that Kali offers us? But these tools also can be installed on any Linux distro. We'll be using John the Ripper tonight is our main tool. And the tool is very easy to use. There's a lot of utility with this tool. Good, my Kali box just came up. Was waiting for that. I'm gonna check something real quick. Yeah. We got a way around that. Before we go into that, bring over credential collections. So during your penetration test for Simple you found a way into multiple Linux and Windows boxes. So you hacked into them. You're able to use Metasploit to get into those systems. And we're going to use, now that you're in there, let's grab some information off of them so we can see how far we can get. As part of the penetration test, your goal is to extract as much information from these compromised systems as possible. To facilitate your effort and expand control of your Simply Learn domain, you have been tasked to extract credentials, which can be passwords, can be hashes, can be any sort of the few there, from those Linux and Windows systems. So how are we going to do that? Continue explaining emergency security issues, risks, and vulnerabilities. We're going to use and configure tools to perform the offensive security techniques, John the Ripper. That's what we're using tonight. Short for John. We're going to extract the SAM. So if you don't know what SAM is, your SAM is your Windows operating system that contains your security accounts manager. That's what your SAM database is. And your NTLM hashes, which are only on Windows-based computers, and explain their values of them. So we're going to go over that. We're going to research measures to prevent Mimikatz on Windows systems. Pretty fun there. So let's see, we've got 3 different exercises tonight. We're going to go over Linux first. Talk about some of the files there, use a tool. Then we're going to go into NTLM on Windows, and then also the SAM database also on Windows using, it says PS exec, so we're probably gonna use some PowerShell there, so that's pretty fun. All right, so authentication. So what is authentication? Authentication is using those passwords. So your just regular passwords, extended heavy passwords, or complex passwords with lowercase, uppercase letters, special characters like the £, the $, the %, series of numbers and letters. That's a complex password, usually like 12 or more characters, and a combination of those different items would make it a complex password. So that's how you can authenticate via password. You also can authenticate via a little USB drive called a YubiKey or a password encryption key. So that's these right here. So you can use a key to get into it. Sometimes you can use even a 2-factor authentication on your phone, or maybe on your lanyard for work. You may have a key with a bunch of numbers on it. So those are double or 2-factor authentication keys, multi-factor authentication keys. Another way to authenticate yourself onto a system or into a system, into a server, whatnot, will be biometrics. So you may use a fingerprint. You've got fingerprint scanners on laptops that help you scan a series of fingerprints or fingers. You also have like face detection. That's another biometric verification, which allows you, in combination with any of these, to make it stronger and harder for somebody actually to get in. So when you recall the CIA triad that you went through and discussed earlier in this class, which was confidential, integrity, and availability, authentication would be under that confidentiality section of the triad. Authentication for systems is done primarily through passwords and keys. So, for a password, then we have a second multi-factor authentication, whether it's a key or a password or a text that may come to your phone or tablet. Combination of both these makes that password stronger, so it's less likely to be compromised. Yeah, so Linux and Windows stores their credentials differently. Compromising accounts on Linux systems is primarily performed through the following means. So either you're going to guess the password, like a brute force, like using a word list, and just spraying it, or just trying to multiple different passwords. That's like brute forcing the account. Cracking the hash passwords via the Etsy shadow file. So we looked at the Etsy password file. We're going to look at the Etsy shadow file, and we're going to talk about the difference between them here in just a second. Or SSH keys. So let's say you don't even have the user information or admin information, but there's an SSH key that you can get into the network or into that system. Sometimes people don't realize that you should change or disable SSH, even adding a new access point to your house, adding a new, sometimes network connected printers have a way to SSH into them, either for configuration or setting them up, or just to update firmware on them. If they're at default value, it could be just default admin with a bunch of series of, let's say HP printers. It would be admin for the username and admin123 for the password. If that's still enabled and you can do your Nmap scan and you see on the network that there's an HP printer, you're like, let me do a scan on just that device, just the IP address that comes back, and you see port 22 open. Oh, that's the SSH port. So let me go in there, SSH IP address with the username and password, and you actually get in. So you just compromised an SSH key because it was a default value, and you're able to actually get through onto the network via SSH. And there's ways you have to jump around, but that could be a very serious vulnerability on any network. Compromising accounts on Windows systems primarily performed through the following means. So your security database or your LSAS.exe, so your local security authority system subsystem service process. LSAS runs on every Windows computer. You open up Task Manager and you will see LSAS. LSAS stores information like in RAM, it's temporary. So as long as the system's on, there's a possibility that you've got some credentials that are stored within the executable, and you can compromise that to gain access to the computer. So let's understand now how the Etsy shadow file works. We'll pull over here to my VM real quick. And where's the Etsy shadow file? It's under Etsy shadow, but we're gonna cat that file so you can see. So you need to be root to actually see the shadow file, unlike if you cat your Etsy password file. So does anybody know the difference, or off the top of your head, what's the difference between the password and shadow file? You can throw it in chat if you want. You can scream it out, unmute yourself. So your Etsy password file is going to tell you all about the accounts on the computer. It'll tell you all the information about those accounts. So I just did that right here. I catted my Etsy password. So you can see all these different accounts on the computer. Root, daemon, binary. There's a backup account. There's a MySQL account. There's a Debian account. But all the way down here to the bottom, we've got beef cross-site scripting, compromised user account. This is going to tell you all about the accounts on the computer. But your shadow file, so we have to go in the root so we can see your shadow file, unlike our password file. Our shadow file is actually tell you about the passwords on the computer. If I can actually type, I think my left or my keyboard's dying. You can only get the Etsy shadow file if you have root privileges. If you don't have root privileges, you're gonna have to find another way to be able to copy that. Because even though, I'm root right now, but if I only had a user account, you just can't copy the file. It's still gonna keep the security settings. So you may be able to copy it, but you won't ever be able to view the file because you don't have the privileges to see that. Normally, it's just not even gonna let you cat it or echo it to a file, or even go into that directory to see it. So we can see we've got compromised user, Kali, and here's a password here. So you've already got some sort of password or encrypted password for the Kali user. Just keep that in mind. There's all different pieces of information here. You can get off of that. So your password file is your accounts. Your shadow file is your passwords. It's kind of backwards, but that's just the way Linux does that.
I will point out that the reason it does that is because of how Linux used to be. It used to be in the password file, it had all that information together, but in order to kind of make things a little bit more secure, they decided to split it once they started going ahead and making things a little bit different with how they were handling the actual hash values of the passwords. So in order to be able to make things a little bit more secure, that's why they split it into two separate files. And that's why it is the way it is now.
Etsy shadow contains the hash information. Yep. Correct. No. So you're going to see in that shadow file, we saw the username, we saw passwords. We can see when the last password was changed. Got some should be some date time groups in here. And then maximum days before users can change their password. Yeah, we're in the shadow. Maximum days before passwords required to change. All this information is in there. Date of expiration, number of days since 1970. So they're all separated here by colons. So I will go over here. Send them away. So we can do let me see this. This is a little bit better. Can I make this a little bit bigger? No, I can't make it. Can everyone see that? You can look this up. So how is your Etsy shadow file contained? So here's your username. Username is on the first bit. Separated by the colon is your encrypted password. So $sign to the following colon is the last password change. So 19142. Password age is 0. Maximum password age is, so this means it doesn't ever expire. It goes on forever. It's a bunch of 9s. Password warning period is 7. And then these last few are empty. So inactivity and expiration. You can just look this up. It doesn't change. It's all the same. It goes down here to give you a little bit more fidelity in there. I'll actually copy. I'll put this in the chat right here. just in case you want to look over it. All right, so now that you know what a password file is and a shadow file, let's look at an application that we can use to modify, edit, and view those two files. I'll clear my screen here. So it wants us to use John. So John is running right in the binary of the system. However, as I was playing around with this lab, we will have to do one small step to make it actually work. You know, executable files you can run with a // correct? But it's not, we're not in the directory where John actually is. So John is supposed to be mapped right to your normal binary that you can run it right off of just typing in John. But it's not working. So where is this file? This file is under, so we're going to do cd sbin John. Cd sbin. So ls, John should be in here. And before class, I was going through here, making sure John would run right, because sometimes either John needs to be updated or it's just your, like we're going to be using these word lists. Sometimes they may be moved. Where is John? I should be able to do cd. So let's just do. There, it's in there. I can run it now. You see it went green. Oh, I'll do this for you. So ls tech LA. I'll put in all. Should have done that first. Just to show you John's in here. John, right there. And it's executable. We will have this fixed, but I just want to show you if it's not mapped correctly, then you can go into your folder where that application is housed, and you can just run it by / the name of the program. So if you're following along here in your LMS, only difference is we have a / here. So we're going to run. Okay, before we go down there, sorry, I'm getting ahead of myself. So John the Ripper is an open source security audio and password recovery tool. It can crack passwords. You can use this on your own computer. It comes pre-installed on Kali. That has been hashed in several different hashing algorithms, including ones used by the Etsy shadow file. John the Ripper works by supplying the Mac is not working with me tonight. By supplying a file containing the passwords and hashes telling which kind of password hashes it's in the file, which we do that by using the TAC format flag. So it tells you, you're telling John saying, with this format, look at those hashes. Once provided, John will then attempt to crack the passwords by generating all kinds of different hashes to see which ones will match up. This effectively is a brute force attack against the password hashes. So using John to brute force attack passwords, whether using a word list or a list of words you've created, or using just something supplied on your system or self-generated, allows you not to try to brute force on the actual system. So why wouldn't you want to do that? Is if you do that, you could lock yourself out. Sometimes when you do brute force hash or cracking the hashes, or excuse me, passwords, to a system live, you would limit that to no more than 3 times. Why? Because if you do it more than 3 times, you can lock out the system, or you can create a log that will signal somebody trying to security log will pop for somebody trying to get into that system or that computer. Yes, you can add the SBIN to your executable path. We can run that. That's fine. And that's just basically mapping it. Yeah, export path. Yeah. It should be in the binary, but that's been everything in path. So if we go back to our home, so we should be back here. We should just be able to run John. Yeah. Thanks, John, for putting that up there for us. And that path can be used for anything. So you can export the path to any directory, right to, let's say you have your own folder here, either in root or embedded within the system. You can create a path right back to home, so you can run all those binaries or applications right from any drive, or excuse me, any folder that's on your system. Okay, go back to my notes here. John can also accept a word list, like we said, with the TAC word list option. Kelly's a number of word lists already in your system under CD, user, share, word list. So there's that RockU. It's actually zipped up right now, but you got Durbuster, Metasploit, MF list. So we've got some lists right there. So for example, let's run this. So let's do John, TAC word list equals, or point it to a directory. I think it was user. User share word list. And then we're going to select John.list. Was that in there? We don't have a John list in there. We're gonna see if it still works though. Then we'll go to our home. Kelly password hash file text. Password underscore file. Oh, hash file. And then it wants us to do the format XYZ. Is that right? Looks about right. So let's launch that. Let's see what it does. So we created a .john directory, unknown ciphertext requested. So I don't think, because the John list was not in there, but what we can do is you can always unzip the rocku.txt if you forget how to do that, like I do all the time. So unzipped easy file on Linux. So gzip.txt D. So I can do, since we're on a word list, so we can do gzip, D, and then the rock U. And there's a rocky.text, so we can cut that. There's a bunch of passwords in there. So there's a word list we can play with. Rocky.text is on every Kali installation, FYI. Where am I? Do you know what this one was trying to do? Tony, I've never used that one before. Dude, John, that help. So we're putting in word list. Is anybody?
I'm not 100% sure, but I think
Yeah.
that it's
Just-
mainly, I think it's placeholder is what it is, because if we look at it, the word list, as we saw, John.list isn't there, but there is our rocku.txt, which we were able to show them how to be able to unzip and prepare for that. And then I think the password file, we will still have to go ahead and kind of like point to where that is, right? And then of course, after that, once we have a password file with a password value that's been hashed, that format, I don't think we're literally going to be using format equals XYZ. I think again, that's also kind of a placeholder where we can be able to say, if we look at the demonstration there, it says generate MD5 hashes of various words. So I think what they want us to do is be able to go ahead and the format, we'd specify that the format is going to be an MD5 hash value that was used. So I think that that instruction that they have there is just a lot of placeholder is what it is.
Because you would never, we're showing you that you can use, input word list, input a hash file. So this would be your, right. So we're trying to crack a list from John, or we call it John list, but it could be a list of anything. So a list of files you have, or excuse me, a list of passwords you placed in there, right? So list of passwords, and then you're also going to point it to your hash files, and then you're going to select the format. So yeah, that's what that's saying. I had to think about it for a second too.
Now, the thing to remember, of course, is why does this work with John? Because if we go back to what we were talking about when we were going over our concepts in Linux, when we talked about encryption, encoding, hashing, things like that, we mentioned that a hash value, when we take a hash of something, it's a one-way function. It's irreversible. So how is John actually able to go ahead and crack it, so to speak, and figure out what that value is for the password? Well, it's not doing what we think, right? It's not like an encryption where it's taking what has been encrypted and reversing it and getting back the original value. What we're doing here, as Justin mentioned earlier, we are brute forcing this attack. What does that mean? It means that word list we are providing, it's running through every single one of the passwords that's in that file, all the different words that we have in that list. And then when we specify that our format is MD5 or another algorithm for hashing, it's getting those words, running it through that hashing algorithm and trying to find out what is the resulting hash value, and then comparing that to the hash value we provide as that second component, right? So when we see that we have that hash value.txt, that's where the hash values of our passwords are being stored. And we're comparing the results of our word list to that to see, do we get something that matches? Because if we find a match, then whatever word we ran through our algorithm to get that value, that must be the word that our password was. And that's how John the Ripper works.
Trying to get this just to show you. So in your exercise here, you're going to generate some users. So it's going to append to your password and your Etsy shadow file. So we're going to create three new users using the user add command, which is sudo user add, unless you're on sudo tech s. It's user add and then the username. Since we don't have verbose in there, it's just going to go back to a blank line. And then you're going to sudo password for that new user, and you're enter password in there. So it says passwords don't match because I can't type tonight. So, and we'll just type in test. There we go. Password updated successfully. So I created a user and a password. It just wanted to say password, but that's fine. So it gives you some instructions here. Verify these changes are done with the Etsy shadow and file. So sudo tech s, and then we're going to do cat Etsy shadow real quick, and you're going to see test user, and you can see now it's encrypted. So we've got a password in there. Yeah, so let's do that. So the reason why you're going to use password hello and monkey as your passwords is because there is a password list that should be in there. Look at that real quick. PD, where they use a word list of stack. Why not? Oh, it's share. Okay, fasttrack.txt. No. Monkey's in there. So it's not fstack password list. You're going to be using the fast track one. Everyone good with that? So there's a couple lists in here you can use, but it's going to be fasttrack.txt, not fstack password list. So I just walk through a couple of those steps with you guys. If we have the room set up, I think we're going to give you 15 minutes, 20 minutes on this. Let's do 20 minutes because this should not take you more than 15, 20 minutes just to, even though we're going to put you in the breakout rooms, I encourage you all to share your screens, but just to create 3 users, 3 passwords, and verify that's in the Etsy shadow file should take about 15 minutes. Any questions on that? All right. As soon as you're done, please exit the breakout room and come back to the main room so we can go on to the next step. And we'll go down to, I guess, room number 8 for us.
All right, I'll see you there. Go ahead and crack that hash. Excellent. I see a few thumbs up. Antonino, go ahead. I see your hand raised.
All right, so when we're we're not logging in, right? So we're just actually encrypting the password and it automatically saves to a text file. How noisy is that? Is that easily detectable by a SIM in an organization or?
Excellent
How-
question. So typically what would happen is what we're doing right now with John, we would do that on our machine. So what we would want to do is going to be kind of tying into what we're going to see in this next exercise, where we're going to try and compromise the target, take a look at those hash values, right? Or get a look at that hash file, and then try and get a copy of it, right? So as far as how noisy is it that we are going to be, about as noisy as we were before in compromising the target, gaining access to it. And then the only extra is now that we are able to see, like, let's say if I were able to compromise a Linux file, right, a Linux system, just copying over that shadow file, right? The next exercise, we're going to see how we can be able to take a look at the authentication hashes for Windows. So once I compromise a Windows machine, which we saw how we can kind of do that on Monday, right? Then how noisy would it be to just copy that file over to us, right? That file of those hash values. And then once we have the hash value on our machine, then we're going to be able to use John to kind of at our leisure, be able to go ahead and crack those hash values to be able to figure out what the passwords are, right? So as far as how noisy we are being, not much when it comes to this, because again, we're doing the actual cracking of the passwords. What we're actually doing to go ahead and figure out what those hash values are, we're doing that on our end, right? So all that noise, all that stuff that's happening at that point is being done on our machine. The target's not going to even know that, right? In order for them to kind of realize that we may have cracked their passwords, they would have to look into their files and kind of see that we copied over that file to our stuff, right?
So is there like an automatic detection that logs it as someone's actually? I know we're doing it on our computer, so it's not detectable really, but is there like a detection somewhere that automatically logs it on their end?
So it should be that when we have these sensitive files, right, that who's accessing these files, what type of thing are they doing, and then what are they using it for, that when we have the proper setup for our security system, yeah, it should be logging that, hey, somebody accessed this sensitive file, right? And then what account it was that did that. Now, of course, if somebody doesn't set things up correctly, or if they were able to go ahead and modify those files after the fact to try and cover their tracks, right, then that could be able to make it a little bit more difficult to figure that out. Any other excellent questions like that? All right, before we go into the next exercise, for those of you that may have been struggling with this, let's take a quick look at how we can be able to go ahead and do this, right? So I'm going to go ahead and share my screen, and that way we can be able to go ahead and kind of take a quick look at what we can do with John, right? So Justin was able to show us an excellent example of how we can be able to add to our environmental path, right? We were able to go ahead and see that, as was suggested, since SBIN wasn't already a part of our Kali account, right? We saw how John was able to point out in the chat earlier how we could add SBIN to our path environmental variable, so we could be able to go ahead and use John from the Kali account, right? Now, I haven't done that, so you'll notice right here, my terminal, I use, as we kind of seen before, sudo -s just to switch into root. And root, you'll notice when I type in John, recognizes it, right? So it is, since it's part of SBIN, SBIN is for our super user, right? And so that is part of our root account by default. So that is already as part of the path for root. But again, if you've installed some software, if you're creating a script, right, and you want it to be that, hey, I want this program or this command to be recognized, then what John was able to show us earlier and what Justin demonstrated is an excellent thing to know and to use, right? That we can then be able to add that folder or that directory that we have, that either that command or maybe even just a script file that we created ourselves, right? That we want to be able to have it recognized anywhere, no matter where we are inside of our terminal. We can simply add that directory to our path. And then when we type in that name, it should be able to recognize it, right? So that's an excellent kind of demonstration there. Now, for us, let's go ahead and take a look at what we can do first, right? So we said that John is trying to be able to go ahead. It can't undo the hashing function, right? And when we say that it's cracking the password, it's not doing it in the way we might actually think about it, right? It's not undoing that hash value. So if I were to go ahead and use the word monkey, right, and I pass this through a hash value, then it's going to come up with some random thing, right? Some random thing that's going to have, let's say that it's that, it's not, but let's say that it's this value, right? Then if I were to try and crack it with John, it's not going to take this value right here, right? It's not going to go ahead and suddenly take this, run it through some algorithm, whatever, and then get back monkey, right? So what is it really doing? Well, as we mentioned, right, when we kind of described that exercise command that it had there right before, as we saw it, right, where it's showing us John and then that word list and then our password file and so on. What it's doing is whatever we put into that word list is running through all of those words, running it through the format that we said was the hashing algorithm that was used, and then seeing, does that word give us back this value? And it does it for everything in that word list until it finds a match, right? When it finds a match, it assumes that, hey, that word that gave us this value that's matching with what we have must have been the password, right? So that's how it's doing it. And that's why it's a brute force attack. And so we can see an example of this, right? If I were to go, you recall, we did this back in our Linux section, right? We can use the command md5 sum to create a hash value, right? And we said we could be able to go ahead and pass an echo value into this. So I could say echo, and then I want to go -n. Now, what does -n do? Well, just so we can be able to take a look, right? If I go man echo, we see right here, -n means whatever I type in, don't automatically add in the new line character at the end, right? Why? Because that's going to change, right? If we change even a single small portion of the value we're sending into our hash algorithm, it's going to change the result, right? So if I go echo, and let's just say monkey, right? I can pass this over, I can pipe it over to our MD5 sum algorithm, right? And so if I do that, notice this is my resulting value. But if I go echo -n, so I'm telling it, hey, don't include a new line character at the end. And I tell it to, again, do monkey, right? And I pass this over to MD5 sum. Notice I'm getting a completely different value. Why? One has that new line character at the end, one doesn't. That makes a complete difference for what value we are getting, right? So when I'm doing it this way, I wanted to do it with that -n value. So that way we get it where it's just the word, it's not going to have that new line character, right? So let's say that I go ahead, I send this to a hash of monkey, right? I send the word over to MD5 sum. That's going to give me an MD5 hash value of this. And then let's say we're going to create this file that I'm going to call passes. So I'm redirecting the results. Instead of displaying it to the screen, I'm putting it into this file. Now, maybe I'm also going to go ahead and say something like scholar. So I'm passing this word, right, from echo without that -n into our MD5 hash. And then you'll notice this time I'm going to go with our double redirect, right? Instead of just a single one, which will create that file, I'm appending when I do it twice, right? So I'm adding it in to this file, which already has our hash value for monkey. So now if I cat this out, we see those are our two different values, right? Now I'm going to go ahead and slightly modify this because I don't want those dashes there. So I'm going to go ahead and open this up, and I'm just going to get rid of these dashes. That way it's just straight up the hash values themselves, nothing else, right? So this is going to be like if this were our shadow file in a sense, right? Our shadow file has our hash values in it. So how does John work? Well, John works, we said, with specifying a word list, right? Now, we said a good word list is if I go ls/user/share, and we go to word lists, we said a good word list that we can use that's a part of Kali is the rocku.txt.gz word list. But in order to use it, we got to use the .text version, right? We can't have it zipped up still. So we saw how we can be able to unzip it, right? We can go gzip with that -d to decompress it, or we can simply go gunzip, right? That's to be able to go ahead and do a, since this is gzip, unzip a gzip file, right? So I want to go ahead and copy this file over to my current directory. So I'm going to say, let's copy from that user share word list rocku.txt.gz, and then notice I go space period. If you recall, when we were working on our Linux commands, this CP is to copy the file, right? This is telling it what file I want to copy, and I'm using an absolute reference, right? So I said, let's go to the root, go to user share word list, and we're copying rocku.txt.gz. And so therefore this dot that I have at the very end, I went space period, that dot, that period is saying copy it with the exact same name to my current directory, right? So when I hit enter, If I do an ls now, we see that I have copied that rocku.txt.gz file into my folder that I'm in right now, into the current directory. So I'm going to now go gunzip rocku.txt.gz. That is going to unzip our file. So if I do an ls, notice it's now just rocku.txt. So now I can go John, I can go -- word list equals. Now here, no matter where the file is on my hard drive, I can be able to specify it. So I could do something like /home/Kali/documents, right? If I wanted an absolute path, and then I could be in any directory while I'm doing this. But since I'm already in the current directory and that's where it is, I could just simply say rocku.txt, and it will look, since I didn't start with that /, it'll look in the current directory, assuming this is a relative path, right? So it'll find it there. And then what am I going to do next? Next, I want to provide the file that I want to be able to try and crack. So where are my hashes, right? Well, this was, we passed it into the folder, right? Or the file we created passes. So I'm going to tell it, hey, look in here. Now, if that's all I did, if I said, John, this is the word list I want you to use. This is the file that has my hash values, and I hit enter. Notice it's going to give us this, and then it tells me session completed. But it wasn't able to crack anything. We don't see anything special, right? It's even telling me, hey, warning, we detected a hash type and we don't recognize it, right? It's going through and even giving us suggestions for what we might want to do. So what do we need to do when that happens? We need to help it out by specifying what was the hash algorithm that was used to create those hash values. And you'll notice it even kind of gives us a hint, right? It says, hey, one of the things you can specify is that the format is a raw MD5 format. So in other words, this is the raw value, the raw hash value from an MD5 algorithm. So that's what we're going to do. We're going to say, okay, the format that was used for these hash values was a raw MD5 hash value. Now, when I hit enter, notice it says it loaded 2 password hashes with no different salts. And then it tells us that there are no password hashes left to crack. So with that information, we now know that there are 2 values that it did crack. Now, how can we see them? Well, once we've cracked it, right, we're going to see that we can see what it is by going John dash, I think it's -- show. So 2 dashes show, and then we got to give it the file. So if I give it the file passes, notice right here, it says, hey, 0 passes cracked. What happened? When we specify a particular format to crack our hash values, when we tell it, hey, show us what those values were, we have to specify that particular format again. So instead of just going, hey, show me what's in passes, I want to go dash, and we're going to go right here with the passes. I want to go ahead and say -- format equals raw MD5 once again, and then the file that I want to crack, right? And notice right here, it shows me what they are. It says, hey, one of those values was the word monkey. The other one was scholar. Any questions so far on that before I show us how we can be able to go ahead and do that with our password and shadow files? All right, so that's just a general way of how we can be able to go ahead and use John, right? If we have a hash value, we have it in a file, and I have a word list that I want to be able to try and be able to use against that, I can be able to go ahead and specify that, right? And it'll go through that entire word list trying to see what manages to get us something that's equal to those values in the hash file, right? If I need to, I might have to specify what hash algorithm was being used to create those hash values. And that way you can be able to crack it, right? So let's do something similar with our shadow file, right? So let's see, I'm going to go add. Well, let's go user add. So that way it'll go faster. So I'm going to go add user, or user add in this case. Let's say compromise user 2. So I'm creating a new account, right? So bam, we've created that new user. If I go cat Etsy password, we see there is my second compromised user right there, right? So I have compromised user, which was there by default, and then I added compromised user 1. Now I've added compromised user 2, right? Now, if we follow the instructions that were there in our exercise, they had us change the password for some accounts, right? So I could do that by going simply password and then the name of the user account, right? So if I do that, it says, okay, well, what do you want to switch it to? So I'm going to go ahead and switch this over to, let's say, Scholar, and then retype it. And it says it was updated successfully. So now this user has their password as Scholar, right? So now, if I go ahead and let's cat etsy shadow, and if I spell crack correctly, right? So there we go. We see that for compromised user, there doesn't seem to be any password really right there, right? But for compromised user 1, we see that there is a hash value there, and we just created one for compromised user 2, right? So we have these 2 accounts, both of them have a hash value. All right, so how can we be able to go ahead and use John? Well, let's say I copy these over just so that way I'm not messing with the original files, right? So I'm going to go ahead and copy these over. I'm going to say, let's copy Etsy password, and then you'll notice I go period again. So I'm copying it into the current directory with the same name. So if I do an ls, there's that password file that we just copied over from Etsy password. I'm going to do the same thing for shadow, right? So I'm going to go right here. Let's copy Etsy shadow and then space period so that we copies it into the current directory, and we see there it is. So there's our shadow file. Now, what can I do here? Well, remember that we said that it used to be back before that Linux actually had our hash values incorporated into the password file. And that's why that had the name password, because it had our passwords in there, right? The hash values. But in an effort to make it more secure, they separated them, right? Well, John was created as a tool to try and crack these passwords back when it had those 2 files together. So in order to be able to work on something like how Linux does it now, we actually have to be able to unshadow those files. We have to be able to bring them back to being one document, right? So how can we do that? With the command unshadow, right? Now how unshadow works, if we hit enter, you'll see it gives us a little idea. It tells us first, after the word unshadow, after our command, we have to tell it which is the file that has the password information. That being the actual account information, the password file, right? Then we have the shadow file where the actual hash values are, right? Now, I could go ahead and again, from anywhere, I could provide an absolute or I could provide a relative path to where those files are. But since I copied them into the current directory, I can just be able to go ahead and give the file name, right? So I can be able to say passwd and then shadow. And if I hit enter, notice it sort of combines them, right? If we go ahead and take a look at this, we see right here, all the information from password for compromised user 2 and all that information for compromised user 1, but it also includes that hash value of their passwords in there. Now, all it did was display this to the screen. So if I want to use this, I have to go ahead and give it to a file. So I'm redirecting this into a file. I'm going to go ahead and call that file no shadow. You can call it whatever you like, right? When I hit enter, if we take a look, here is our no shadow file, right? It has those 2 things combined, right? So you're going to have this right here inside of that no shadow file. So now that's what I'm going to provide to John, right? I'm going to say, hey, John, let's go ahead. Let's give you the word list for rocku.txt. And then I'm going to go ahead and say that the file for our hash values is in the current directory. It's known as no shadow. And then I still have to specify the format, because if we did just this, notice it says, hey, nothing really worked, right? There are no password hashes loaded. We weren't able to crack it. So I have to specify what format it is. Now, if we go back to our instructions, right? So if I go up here, it was a little bit cryptic, but it tells us the hash type when it comes to our shadow file is crypt, right? So just like before in my previous one, I was having to specify that it was an MD5 hashing algorithm that was used. Here, the hashing algorithm is crypt, right? And they told us that. So here I'm going to go ahead and say format equals crypt. And when I do that, notice it's going through, it's trying to be able to go ahead and do this. And then it should be able to go ahead and crack those passwords, right? Now it might take some time. And notice that it is going through this, right? So here it's saying, hey, we're running through these values. Here I hit the button again, it says we're running through these values. And so anytime I hit a button, right, it's kind of going ahead and showing us what words that it has from that word list that it's running through to try and be able to go ahead and crack this password, right? To be able to try and figure out what these are. Now, notice that it said that it was able to load 2 different password hashes. So it was able to recognize that there are 2 values in there that it can be able to possibly crack, right? They were using our crypt algorithm, right? And it was able to go ahead and get one that says now there's still 1 more password remaining, right? So it's going to try and be able to go through and be able to get that other one. Now, it can take some time for this. So it does tell us, hey, we can press Q or we can go Control C to be able to stop what we're doing, and it will be able to go ahead and end it right there. Or we can hit any key and it'll give us this update, right? So if I hit a key again, notice it tells us how much time has passed. So it's worked over 1.5 minutes just about. And it tells us what is its estimated time. It's now giving us an estimated time of possibly 17 minutes, right? It's telling us how quickly it's running through this to try and be able to do it. And then where in that list is it currently working at, right? Now, I'm going to go ahead and just for now hit Control C. So session aborted, but we can see that I can be able to go ahead, if it's already cracked a password, right? If it already has some value, we can then go ahead and tell John to show it to us again, right? So I can go John -- show, and then I can be able to specify the format again, right? I can say format equals crypt, because if I don't specify the format, it's not going to work, right? Because we have to let it know what format was being done. And then what was the file that we cracked, right? So if I do this, notice it'll go ahead and tell us what happened. So it says, hey, we were able to crack 1 password, 1 was still left, and it tells us what that is, right? So here, it was able to compromise user 1 was the one it was able to crack. What was the password? It tells us that password right here instead of the hash value. So it tells us the password was monkey. Now, if we go through our list, right? So if we were to go ahead and cat out rock you, right? .txt, and as a matter of fact, let's see if we go man cat. Let's see if we can be able to go ahead and. So here, if we go -n, it should number out all the output lines. Let's see if I go cat and then rockyou.txt. And I tell it to do this with a -n. Let's see if it gives us the number that is. And I'm going to go ahead and say grep for scholar. Let's see how far down that word was. So we can see it was pretty far down, right? So we already seeing just the numbers that it's showing up at. The very first time scholar just by itself is about 38,000 lines down. So it might have taken some while to actually get to that word and then be able to crack it, right? Monkey was a lot closer up. As a matter of fact, let's check to see what number monkey would have been. So let's see, let's scroll back up to here. We go ahead and scroll faster from the right-hand side. Let's go this way.
So while Tony's looking over that, you notice how slow it was going when he was doing those cracks? There's one big reason why, because right now this computer in the virtual cloud environment is using the CPU to crack those. John the Ripper has the capability of using a graphics card or a GPU, using an NVIDIA graphics card to crack these hashes and these passwords makes it go so much faster. So there is dedicated cracking rigs out there with multiple graphics cards. You may use them for gaming, you may use them for productivity, but there's supercomputers that, you know, you've got a good processor, but a ton, like I'd say 4 to 15 different graphics cards on some of these rigs that people build, usually like 4 per CPU, and they're using that for that processing, that horsepower. So you could crack thousands of passwords a minute, versus where this one was going very slow, was one, every couple minutes it was doing another one, because it's using just that computer processor, not a graphics processor that's got all those CUDA cores and everything else nerd talk to make it crack them faster. So just a little piece of information there for you guys.
Definitely, definitely. Thank you for that, Justin. So we can see right here, the word monkey by itself is actually the 14th number, right? It's the 14th on the list there. So that's why I was able to crack that one really fast, but it was taking a while to get to Scholar because that was 38,000 deep, right? So just keep that in mind, right? When we're working on this, it can take a while to get through the list. As Justin pointed out, there are ways to speed that up, especially when you got a dedicated, something like a graphics card that can do things in parallel, right? And it does depend on just how common the word is as well, right? So let's see, let's go ahead and say, say head. Let's go ahead and have that the first 10 things in rocku.txt. And so rocku itself is one of these things. So let's go ahead and let's see if I were to go ahead and change the password to compromise user 2. This time, let's change this to rocku. So we've updated it successfully. Let's go ahead and copy Etsy shadow over again. Let's go ahead and copy our password over again. And let's go ahead and unshadow both, right? Back into no shadow. And now that we've done this, let's go ahead and let's try running John again. Let's see if it'll do it.
So Min had a question, does the password need to be in the rocku.txt file in order for John to crack it? Yes, if you're using that word list. So right now, we're duplicating a password that was already in that list right there, just popped up for us. So keep in mind, with the rocku.txt is the most common used passwords across the enterprise. That's why they're in there. As they get used more and more, yes, you can re-download, re-update that rocku.txt file with the latest and greatest, so you have the most up-to-date password. So yes, that you may have a personal password as long as it hasn't been exposed and out there and used multiple times, then it won't be in rocku.txt. You may have to take use rocku.txt. You may have to use another file. So you may have a common text file with a bunch of commonly used passwords for your company's network. You may add that in there and run that against those common passwords as well to make sure that if you're doing this on-prem, making sure that your users are not using the same passwords that they shouldn't be using, you may want to run it against Rocku and your own personal file as well.
Now, to that effect, if we look at this, you'll notice that we could do John just by itself, right? So we see right here, it says John, and then what is the file that we are trying to crack, right? So just as Justin mentioned right now, and to answer Min's question again, yes, when we go ahead and include that tac word list, right? So -- word list, and we specify a file to use, then we're doing what's known as a dictionary attack, really, right? We're going through this list of words one at a time and comparing that to see, does this give me that value, right? Now, if I don't do it, right? So let's go ahead and scroll down a little bit further. So we'll see then, here are those options, right, that we were using. One of them was specifying the format, right? Another one was being able to go ahead and tell it what was that word list that we were trying to use, right? So there's a lot of different things. We see that right here with word list. There's a lot of different options available. But if all we did was just go John, right, and we didn't use that word list, then it's going to do what is known as a brute force attack. Now, what is a brute force attack? It's going to go ahead and try every single possible combination at that point, right? So if I went ahead, let's say that I went John and I specify no shadow, right? But I don't have this word list. So it would try to be able to go ahead and run through this and be able to try and crack it. Let's try it without the format. Let's just try it pure, just John and the file. So right here, you'll notice it does go ahead and say that, hey, it's dealing with this encoding thing right here. It wasn't able to load up the password hashes, but once we specified that, hey, the password hash is crypt, it was able to recognize the two loaded password hashes, right? Now, because I've already gone ahead and cracked this, let's go ahead and let's copy this over just for the sake. As a matter of fact, let's take a look at this. If we've already cracked a certain file and it recognizes that, hey, everything in there's been cracked, there's actually, let's go ahead and go to /home/ I think it's root. Nope. Let's just go /root. So if we look right here, we're going to see there's a few files. These are for the root user, right? Now, if I go ls-a, we'll notice that one of these that gets created once we crack a password, depending on the account that you're in. So right now I'm in root. So this is going to be added to the root account. For those of you that are following along with what Justin did earlier, so that way it's able to recognize our John command because we've added it to our path, but we're still in Kali, then it would be inside of your Kali home directory, right? So whichever user account you are using when you crack the password, this .john directory is going to be added to it, right? And if we go and look inside, we're going to see that there is a pot file. So john.pot. Inside of there, if we go ahead and let's try catting this out, we're going to see all the stuff that it's cracked, right? So you'll see right here, this was for MD5, right? Our monkey and our scholar. And then this was for our shadow file where we did no shadow, right? We see our monkey and rock u, which was compromise user 1, compromise user 2, right? So if I want to do those again, I would simply have to remove my john.pot file. You remove that file, right? So now it's no longer there instead of .john. And now, if I go back, let's see, home/Kali, I think I was inside of the documents folder. So here we see our stuff, right? So now if I try to be able to go ahead and go John, no shadow, -- format equals crypt, it should be able to run through this. So now you'll see that it's actually kind of like what we saw before, right? It's trying to run through this. If I hit a button, it gives us an update on what is it doing, right? So you see right here, what is it trying to do? It's trying to be able to run through this and be able to go ahead and kind of crack it, right? Now, it's going to take a while to do that because since I didn't specify a word list, it's trying to brute force it. So what is it going to do? It's essentially going to go ahead and start off, like we said, every single possible character. It'll start with all combinations of just one character, right? If it doesn't get that cracked, then it'll expand it to all possible combinations of 2 characters. If that doesn't crack, then it'll move to 3, then it'll move to 4, then it'll move to 5. So that's one of the reasons why we say, hey, a good way to secure your password, make it a long password. Don't have it be just 4 characters, right? Have it be 8 or more characters, because the more characters you use, right? If you use a lowercase, an uppercase, a number, a special character, all that stuff, that increases the amount of different characters each thing could be. And the more you have, that's going to exponentially increase all the different possibilities it could be for brute forcing it, right? So if we were to just specify it without that -- word list, it's going to go through every single combination possible, slowly increasing the amount of characters until it gets one that matches, right? So is there a way to be able to break it even if the word isn't in rocku.txt? Yes. It's just how long is it going to take you, right? If we were to do it on this machine, as Justin pointed out, it might take a really long time. It'll be impractical, right? But if we had a dedicated machine with a graphics card or multiple graphics cards with multiple cores, each running in parallel, it might just take less than a day, right? And that's one of the reasons why we say, hey, in addition to having a secure password, you probably should be changing your passwords every so often, right? Because if we make it secure enough, then even with the most powerful computers running at the best top speeds, maybe it'll still take an impractical amount of time, right? Maybe it'll take them more than 30 days of continuous work to crack your password. And by then, you would have already been forced to change it to a new one anyway, right? So that kind of goes into what we've mentioned before in this course. You can never make something 100% secure. You're never going to be able to make it that it's going to be uncrackable or it can't be broken into, but you can make it impractical to where there's no point to trying, right? Just make it easier for them to get the next guy. Any questions on this whatsoever?
We have a couple of questions here. Anthony was said, John Ripper crack passwords in different languages, or is it based on which algorithm? So I did put a link in there. Basically, it was built on English, but you can set up encodings like, so let's say Russian, You can do a Russian word list and set up the encodings for like KOI 8R or Windows 1251 to help with cracking Russian. So you would have to look up the encoders for those, but yes, you can crack it in different languages. And then Henry talked about the hacker was running rocky.txt and it was about 90% complete. Can it append additional passwords to that text file or wait for the crack process to complete and run it again on another text file? So depending on how they have it set up, yes, you can wait till it ends. You can cancel it and restart it. Or you can just run it in a second terminal window. Depending on how much horsepower that computer has, you can run multiple things at once. The one we have at work, we can run, geez, we can go through like 36,000 passwords in an hour. So yeah, it's pretty aggressive. And that's done via remote too. So it stays here home in DC. And we can be anywhere in the world and be able to VPN in, upload a file, and have it do its thing back here. And that's like 6 different teams being able to use it at once. So it's a big server rack, but depending on the attacker, the hacker, the bad guy, how much money they have, how much time they have invested in it, is how fast they can do it, how many at a time. So so yes, let's see, my password's over 30 characters long. Is it still possible to crack it? Yep. Special
Go
character.
along with that.
So just because this went into the next part that we were going to talk about is salting your passwords. So that's adding a little character to it. So let's say you guys are using a password manager, right? So you let the password manager create your password, okay? And that's secure, but we've heard of password managers being hacked. They've been compromised, right? And somebody's getting a whole database of stuff. Well, that's great if you salted the end of your password, you added something extra. So just like you can make your iOS phone create a password for you, right? Series of numbers, letters, characters, great. But append a little thing to the end of it, okay? Like use a dog's name or use, something at the end of it. So if I was to, let it make a password, bunch of letters and characters, I will never remember it. That's why I saved it on my phone. But my password's not just that. I added a little bit of salt to the end of it to change it so that even if that password was compromised, it wasn't the full password. Because I remember at the end of all my passwords, I will add Bobby to it, okay? So it's never going to be cracked. At least if it's compromised, it's not going to be cracked right away. They don't have to run it again. So does that make sense? Yes, that's salting your password. They'd say that you salt a hash too. There's a hash value. You add extra characters to the end of it. Sometimes you can get a program that will pre-salt it for you and give something to you, or you can make it up on your own. Henry's got a question.
Yeah, I have a question. So actually, it's a good thing you brought that up about the password generators or random password generators and salting it, because I know, like in the past, I've used a Kaspersky antivirus, and they actually do have a random password generator where it randomly creates a user name and a password. But these are generally done by through some sort of algorithm or the software developer created that, right? So it's still vulnerable that a hacker can, if they were able to get a hold of that.
It's good not to attribute your name, your screen name, your handle to a bunch of the same username and passwords. We all do it. Right. I'm victim of it as well. But if you get the habit of taking your letting like a password manager like either Kaspersky or NordVPN, or there's so many different ones out there, let them create your password and then you add what you want to the end of it, whatever it could be. You can add your own characters to the end of it just in case that database gets compromised. They don't have
all right, that's a great idea.
Something at the end of it.
Yeah, thanks for the suggestion.
Absolutely. Anybody else?
while Justin is looking at the chat to be able to see about the other questions, I will also add that Henry did ask for a password length of 30. Can that be cracked? There is actually ways in John where you can specify how big, what's the length you think the password is. So if you already have an idea of, oh, this person is not going to be less than 8 characters, you can actually have it start with all 8 character combinations first, right off the bat, without having to go through all the previous ones of like, let's check every single 1 length character, right? All the 2 length, all the 3 length, and so on and so forth. So for example, if somebody was able to go ahead and already know that, oh, this person has a 23 character long password, they could set up John the Ripper to be able to go ahead and go through that brute force and be able to say, start it with 23 characters, right? And that would go ahead and slow down the time to crack it. But since we're brute forcing it, right, we're applying every single possible character that can be used to it to try and see if it can brute force it, then yeah, it can be able to still be able to crack it. It's just, again, how much time will it take to get finally to that combination that's correct?
Well,
Any
we
other
have
excellent
nothing
questions?
else. We can, no more questions in the chat, but if nobody has anything else, we can jump to the next section here. Got a little bit over an hour left. We actually have 2 sections left, and I think we can knock both of these out. Let me go ahead and share my screen. Here we go. So we just went over looking at John the Ripper. We had some really good instruction there and demonstration from Tony on more of how John really works. Because this was just to show you with your exercises, adding a user, adding a password, and watching that actually be generated in your 2 files, your shadow file and your password file. So let's go into a little bit of NTLM authentication. So what does NTLM mean? It's Windows New Technology LAN Manager, NTLM for short. Just a suite of protocols used by Microsoft to authenticate users. There's different versions of NTLM. In this one, we're going to use NTLM version 1. It's the older one. It's also a little bit easier to crack. That's why when protocols update, we always encourage you to upgrade to the latest and greatest protocol. So it helps secure your stuff, secure your network, so it's less likely to be compromised, or at least take it longer to be compromised if somebody's actually in your network. So NTLM authentication is a challenge response protocol used for authentication on Windows systems. From a user perspective, the user enters their password. Windows grants access to the system if the user enters the right password. Behind the scenes, however, NTLM authentication performs a number of steps. This is just the simplified version. So you enter the password on the computer. It's sent to the Windows authentication portion as a hashed password. So if it was just, password 123, you're not sending that over to the authenticator. It's going in a hashed form over there. Then the server sends back a challenge 16-byte random number. If the challenge the challenge is then encrypted using the hash of the password the user entered and sent back to the Windows authentication server. If it's correct, it will then go to the next step. If it matches it, it comes back and says, great, you can go in the system now. That's confusing, right? This is what it looks like. Authentication request goes from you, the client, to the host. It says, okay, sends back a challenge with a random number. Then the client says, yep, that's probably it. It goes back to the host. And if it's correct, everything matches from these first 3 steps, it goes back over to the client, says, go ahead, you can get in. If not, it could block your access or just say, yeah, wrong password. This is sometimes where you would also hear something called, pass the hash, right? One system's passing a hash to another system, passing a hash to another system. Not necessarily you need the password to get in the system, you just need to know the hash. And if you can pass and capture that hash, happens with man-in-the-middle attacks, then guess what? You garnished a username, you've garnished a hash, you even need the password, put those two together, and you're in. So there's a flaw in NTLM authentication, specifically the fact that it deals with password hashes. Because NTLM checks the password hashes as part of the authentication, if you get a user's password hash, you effectively become that user. Like I just said, you do not need to know the user's clear text password. Luckily, these NTLM hashes are generally found in two places on Windows system, the SAM database and LSAS process. So LSAS is running all the time. If you're on a Windows computer right now, you can Control-Delete, you can look at your task manager, and you will see that process running. And until you reboot the computer, it will stay, your password and your hashes stay in memory. So if that doesn't scare you, go ahead and reboot your computer. Not right now, wait till after class, but normally, if you're working in an office environment, right, you call IT up and you're like, hey, I can't get into this. I need you to help me out. Notice that they will remote into your computer. They will fix whatever they need to fix, and then they reboot it. Why? Because those domain credentials, those admin credentials are now saved in LSAS and will not go away until you reboot the computer. So 9 times out of 10, a good admin will, after they're off your PC, they will send a reboot command to reboot that system. So it dumps the RAM and the cache on it so that those credentials are no longer stored. It's a way that LSAS is a big way a lot of attackers get into systems, because somebody will go in and change something and not reboot the computer because they want to be back up and running so fast, and they can their network can get in that way. Passwords can be a number of different things, including lateral. Can be used for lateral movement, which is covered by in the next lesson. You can even crack them using John the Ripper. So hashes look similar to this, right? So we just saw Tony created a couple of hashes for us with MD